Hello, and welcome to the world's best Python bootcamp. My name is Angela, I'm a senior developer and the lead instructor at the Appbury, London's highest rated programming bootcamp. To date, I've taught over 500,000 students in person and online, and I'm so excited to be your instructor on this course. As a student on this course, you're going to get access to over 56 hours of HD video content, which contains step-by-step tutorials, interactive coding exercises, quizzes, and more. The course is structured around the 100 Days of Code challenge. So you can look forward to 100 days of lovingly crafted content that is going to cover every aspect of Python programming, from web development to data science. It's the only course you need to become a professional Python developer. Every day on the course, you're going to use what you've learned to build a new project. You'll build a bot that texts you in the morning if it will rain that day, so you never forget your umbrella again. You'll build classic arcade games like Snake and Pong to impress your friends by challenging them to a game that you built. You'll learn to make sense of complex data and create beautiful visualizations to impress your colleagues at work. You'll create a program that automatically sends happy birthday emails to your friends and family. Never forget mom's birthday again. You'll work on projects that clone real-world startups. Cheap Flight Club? Check. Build your own blog? Check. Twitter bot? Check. And there are so many more projects waiting to be discovered by you. 100 projects in total. So if you're somebody who wants to get a job as a Python developer, then this is perfect for building up your portfolio to show off at your next interview. Now, this course assumes absolutely no prior programming experience. So if you're somebody who's never coded before, I'll be with you every step of the way as I take you from programming fundamentals through to more intermediate and advanced programming concepts. You're going to learn Python from scratch. Now, if you're an advanced developer, on the other hand, then take a look at the curriculum and start at the level that suits you best. From beginner to professional, every level is covered in the course. Got school? Working a full-time job? Have to look after kids? I know you're busy. I've timed each day of the course to take less than 2 hours to complete, so you can fit the course around your life. This course has exactly the same curriculum as our in-person programming bootcamp. So instead of spending thousands of dollars and taking time off work, you'll get access to exactly the same curriculum with years of design and testing behind it to ensure that you don't just know what to do, but also why you're doing it. Now, don't just take my word for it. Check out what my past students had to say about my courses. So what are you still waiting for? Find out why over 500,000 students have rated my course 5 stars and see what you can do by mastering Python. Hi, this is where you start the course. But first, I want to tell you a little bit about it. Because this is more than a course. It's a journey. And it's a challenge. A challenge to yourself. I often hear people say, I want to learn to code, I want to become an app developer, I want a new job, I want to build my app. But without action, those words are meaningless. But you are different. I know it. Even though I don't know you personally, I know you purchased this course and you haven't left it at that. You've made a start, and success comes to those who show up, and you showed up today. I know you can do this. You can make your dreams come true. You can change your own future, and you can change the lives of those people around you. One of the questions I hear most often is, what's the best way to learn to code? Well, here it is. It's the 100 Days of Code challenge. Code for at least an hour over 100 days. You're practicing a muscle to get strong at coding. Then the next question, inevitably, is, well, what do I do each day? And I've spent years thinking about this question. And finally, I'm now able to definitively answer that. It's this course. Every day, you're going to learn and apply new programming concepts. After 100 days of repeating this process, not only will you have covered the entire professional Python curriculum, you'll also be so good that they can't ignore you. There are just 2 rules to get the most out of this course. 1. Pledge to code for an hour a day for 100 days. To keep yourself accountable, I recommend downloading the course pledge. This is a contract with yourself. You can print it out and pin it somewhere you can always see, for example above your computer or on your desk. By signing the pledge, you're making a commitment to yourself. It's only for you. No one else needs to see it. You can download the pledge in the course resources for this lesson. The second rule is to log your progress using the 100 Days of Code hashtag on Twitter. There are millions of other students who are on this journey with you, and they will support you when times get tough. I recommend tweeting your progress each day with the hashtag 100 Days of Code and search the hashtag on Twitter to see what others are doing as a part of their 100 days. And that's all there is to it. So here's to your success, and let's get started with the course.
Hey guys, it's Angela here. After I made this course, I decided to take it myself so I could see what it's like to be in your shoes. Along the way, I realized there are things we could create to make your learning experience easier and even more enjoyable. So in this video, I'm going to share my top tips and how to use all the tools and resources we built for you. The first tip I have for you is to use another screen. That way you can watch the lesson on a tablet or phone and code on your main computer. So you can code along with me and get practice instead of just listening to the videos. Programming is a practical skill, so just as you need practice when learning skateboarding, you also need practice to get good at programming. Tip number 2. I created a Python syntax cheat sheet, which you can download and print out. It contains some of the most common programming concepts we'll learn, and it's a handy reference to have when you're doing the coding challenges. You can download this in the course resources for this lesson, where you'll also find my 12 Rules to Learn to Code ebook. One of the hardest things about learning is keeping the motivation high. I find I'm usually more motivated when I'm in the library or a cafe where I can see other people studying or working hard. So I decided to create a 2-hour study with me video where I'm concentrating hard. We'll work for 25 minutes at a time and then take a 5-minute break before we get back to the next Pomodoro. Tip number 4. When you're learning new programming concepts, it's a good idea to note down how the code works while your mind is fresh on that topic. So I created a coding notes page that you can print out and collate to create a coding notebook. The note paper is the perfect place to write down examples of coding concepts you've learnt. It comes with line numbers and handy indentation guides, which is super useful when it comes to writing out Python code. Coding is not like history. There's nothing you need to memorize. It's a bit like baking. You don't need to remember the recipe. You just need to get practice and understand how to use the recipe. One of the most helpful note-taking systems for learning is the Cornell Note method. In our coding notebook, we've incorporated all the key elements from Cornell, including the sidebar, where you can write comments on each line of code, and the bottom summary section, where you can write an overview of the concept you just learned. In the course resources for this lesson, you'll also find some desktop wallpapers I've created for you. They contain some of the messages I keep around my desk to keep me motivated, and I hope they'll help you too. Tip number 5. Celebrate after you complete each day. Because this course is designed to take you from beginner to professional, as you go from day to day, there will be less and less tutorial and more practice. To keep you on track, I've created a 100 days of code poster. Once you complete a day, you can check it off on the poster. So print it out, put it up on a wall, and take each day as a challenge. Reward yourself after each day you tick off, and day by day you'll learn and grow as a developer. This course is a safe space where you can make mistakes, ask questions, but most importantly, become confident in your skills as a programmer. I had so much fun building this course, and I hope that you'll enjoy it as much as I did. So here's to your success. Hey guys, welcome to day 1 of your 100-day journey. And today we're going to learn about printing, commenting, debugging, string manipulation, and variables. So it's chock-a-block full of really fun stuff. And by the end of today, you will have created a band name generator program. So this is the final project of today. And the idea is that, let's say that your friend was starting a new band, a rock band or a classical band, and they're struggling to come up with a good name. So you come into the rescue and send them your band name generator program. So it asks you for the name of the city that you grew up in. So mine was Bristol in the southwest of the UK. And then it'll ask you what's the name of your pet. I had a pet rabbit when I was younger, and I am probably the least imaginative person, classic programmer personality. So I called my rabbit Rabbit. So now when I hit enter, it's going to give me my band name, and it could be Bristol Rabbit. So that sounds pretty cool. It could be like a rock band. So this is what you're going to make, and in the process, in order to create this, you're going to learn about printing, inputting, commenting, debugging, name errors, syntax errors, string manipulation, variables, and a whole lot more. So if you feel like you can already achieve this and you can prove it by making this program yourself, then feel free to skip to the next day's lessons. But for most of you, even if you've started learning Python programming, there's probably still a lot of new things that you'll find in today's lessons. Now, as with all the projects that we're making in this course, you get to try it out before you make it. So you can either go to the URL. Alternatively, if you don't want to type out the full URL, you can head over to the course content here and then click on the resources and click this link to head straight over there. And then once you're there, all you have to do is to click run, and you'll be able to preview how the final product is going to work. So you can type in your own city and follow the instructions until you get to the end result. So once you're ready, head over to the next lesson and let's get started and get coding straight away. Now, hopefully you've already got everything set up so that you're ready to go on the day 1 tasks, and you're able to see what I'm seeing right here. Now, if you don't know what I'm talking about, or if you don't have access to any of this, be sure to go back to the previous lesson where I showed you step by step how to download and get hold of the latest version of the curriculum exercises on PyCharm. So be sure you do that before you proceed, so that we're all starting at the same place and you're seeing exactly what is shown in the videos. And we're ready to start learning how to program. Now remember that the whole reason why we're learning to program is to be able to tell the computer what it needs to do and for it to follow our commands. So let's go ahead and tell the computer to do something. And we're going to do that by writing our first line of code. So in this case, I'm creating something called a print function, which is just the word print, all in lowercase, and then followed by a set of parentheses. Now, inside these parentheses, I'm going to tell it what I want it to print. And hopefully it's going to output that inside our console. So I'm going to start off by writing the classic hello world inside here. And then once you're ready, then go ahead and click run. After a few seconds, you should see the computer follow your command, namely printing the words that you told it to print inside the console or the output area over here. And once it's done, it indicates that by writing process finished with exit code 0, which means everything was successful, everything was run without any issues. Now, just to break down this area a little bit more for you, if you look at the top line here, which you'll always see, there's a lot of text in here, but it's actually very simple to understand. Essentially, it's telling you the location of the current file that is being run that has resulted in this output. So in our case, it's the day 1 task. And you'll see this change as you go through the different days because the location of this file where you wrote the code will change. So the first line is the location of the file that you executed. The second line, or multiple lines in between, is the result of your command to the computer. And then finally, at the very end, it tells you if the process finished with success, which is in this case, or if there are any other issues, it would show up here as well, which we're going to see very shortly. And to be sure that you're always running the current file, make sure that this drop down is selected as current file. And that way, every time you press the play button here, it will run the code into the output area. Now, if you want to do a shortcut and you're really into keyboard shortcuts, you can hover over the play button and you'll see the shortcut on what I'm using, which is a Mac, is Control+R. In Windows or Linux, it'll show up different shortcuts, but it should all show up there if you want to try that out. Alternatively, just keep pressing the play button and it works just as well. And the way that this command works is super simple. You have the keyword print, followed by a set of parentheses, and then inside the parentheses, you tell it what you want it to print. And once you've inserted that, then when this line of code gets executed by the computer, it'll know to simply print or output the thing that you've placed in between the parentheses. But notice here that it's not just the word hello world ! That I've put inside my parentheses. I've also added some quotation marks or double quotes around the word. And the reason why I've done this is so that I can tell the computer that this bit here in between the double quotes is not code. It's not like print where it's supposed to do something. This is just some text that I've made up that I want it to print out. And these pieces of text in programming lingo is known as strings. And you can imagine it as almost like a pearl necklace, right? It's a string of characters. And what the double quotes do is they basically show the beginning and the end of that string of characters. So that means you have to be really careful when you're typing. For example, if I go ahead and I miss out the closing double quote, well, now you can see that there's some changes that have happened to our code already. Namely that the last parentheses, instead of being colored in white like the opening parentheses, or how it used to be, it's now colored in green, the same color as the rest of our text or our string. And this is a subtle hint to us. You're going to get really attuned to these subtle hints because they are the clues that will tell you what might have gone wrong in your code. If I run this code as it is right now, it's going to break. It's going to give me a syntax error. And it says something that seems like it's completely not English. So how can we figure out what this means? Now, the thing I want you to know is that all programmers make mistakes. We all make lots of errors, like forgetting to add the double quotes at the end of the string, or forgetting to add a closing parentheses. These things are just common errors because we're human. But the thing that differentiates great programmers is we're really good at figuring out what the problem is and how to fix it. So you can imagine that coding is just a whole bunch of problems that you have to solve. And in this case, when we get some sort of red text and our code is not doing what we expect it to do, then all we have to do is take this entire error message where it says something error, and this is some sort of message that we're supposed to understand. And we're simply going to drop it into Google. and usually the first link you come across will be from a website called stackoverflow.com. And this is basically the Q&A website that all developers will go to whenever something is wrong with their code or when they can't figure out how to do something. So if we click on this link, you can see that somebody else has also had this error, and some kind souls have told us that the solution might be the fact that you're missing a double quote before the end of the line. So if we take a look back at our code, the code that generated this error looks like this. And indeed, we are missing a double quote at the end of our string. As you're learning to code, as you're going through your 100 days, I want you to become more and more attuned to the color of your code. Because one of the most helpful things that code editors such as this do for us is something called syntax highlighting. For example, when I was missing that double quote, it highlighted this entire thing. And that is basically it telling us, it seems like this whole thing is some text. It thinks that all of this is a string and that we're missing a closing parenthesis. So if you notice this and you're like, wait, actually, that's not right. This part should match the color of the open brace, which is white. So there must be something wrong here. And indeed, if you have a look at the error message, it actually has a little caret sign right here showing you that there's something that's probably not right here. And it might jog your memory that, oh yeah, I've forgotten a closing double quote. Now, the really handy thing about PyCharm is it actually underlines your errors before you even run your code. And if you hover over the underline, it usually gives you some intelligent guess as to what your problem might be. And in this case, it's absolutely spot on. It says you're missing a closing quote, which is exactly what we're missing. So that will also be really helpful for us to figure out what it is that we need to do. But as with all things with AI, if we don't know what we're doing in the first place, these hints don't help us that much. For example, if I put the closing quote right here, I've got other problems and I'm going to create more problems for myself. So it's important that we first understand how things work and then use technology and AI to help us, such as in this case, to fix our bug. Now you'll notice that there is also a tiny squiggly line under this closing brace, but in this case it's not in red, so it's not an error, but instead it's in yellow, which is a warning. Now most of these warnings come from a good standard practice for how to write code. And if we hover over this warning, it tells us that PEP 8, which is guidance for how to write Python code, and it tells you that the problem that it's seeing is there's no new line at the end of the file. Now we can ignore all of this because it's a bit too complicated, and it's actually very simple to solve this problem. All it's saying is that in good practice, when we're writing Python code, there should be a new line at the end of the file, so that we have our cursor down here instead of ending right there. And that's all there is to it. And with that one thing, we've gotten rid of all our errors, we've gotten rid of all our warnings, our code looks good stylistically as well as syntactically. All these big words that all that it means is that it looks great in every single way. And we've got our little check mark, which means no problems found by the editor. Now, sometimes the editor can be really picky, and some of the things that it tells you, you can safely ignore. But as always, we need to understand how everything works before we can do that. So now that we've embarked on our first step to write some code and start commanding the computer to do what we want it to do, which is to print out some words into the output area, it's now time for a challenge. So head over to the next lesson and we're going to test you on what you've learned in this lesson by practicing writing some print statements. So for all of that and more, I'll see you on the next lesson. All right, guys, let's get back to learning about a few more things that we can do with strings. you saw in the last lesson that if we wanted to print things on individual lines, then we actually had to write them a few times, right? We had to write print on 3 lines if we wanted it to be printed 1, 2, 3, like so. Now in this lesson, I want to show you a method where we can do the same thing, but by using a single print method, so saving ourselves a few characters. So the way that we would create a new line is by writing a backslash and the N character. And now if I go ahead and write hello world again afterwards and I hit run, and you can see that once that line of code has been executed, I've got hello world printed on 2 separate lines, separated by this backslash N character, which gets replaced by a new line. So go ahead and give that a go and see if you can create another one. Remember though, it's a backslash and not a forward slash, but the syntax highlighting should help you. All right, we can simply just add another backslash N, and remember that unless you want a space to appear right before where your hello world appears, you actually don't want any gaps between each of these lines. There we go, we've got the same result as before, but now using only a single print statement and creating some new lines with the backslash N. Now, one of the other things that we can do with strings is we can concatenate them. What this means is we combine different strings so that they will be added to the end of another string. Here's an example. Let's say that we had the word hello and I wanted to add my name to the end of this word to make it a single string. Well, I can combine 2 strings by simply using a plus sign. So I can write hello plus Angela. Now, here's a question. When this runs, what do you think it will look like? Do you think it'll write hello space Angela or hello Angela all in one word? Let's see what happens. You can see that these 2 strings have now been combined into one. And there's no space in between because we don't have a space character anywhere in here. Pause the video and see if you can add a space in between. All right, so there's 2 ways that you can do this, or maybe 3 actually. You could add a space to the end of hello, you could add a space to the beginning of Angela, or you can actually continue using string concatenation by simply adding another string in between these 2, and this one is just a space. So now when I run my code, you can see the space gets inserted, and this long thing gets combined into a single string that looks like this, once this bit of the code gets executed. If we think of strings as a string of connected characters, then string concatenation is simply taking those separate strings of characters and merging them into one. Now, this is a good point to mention that in Python programming, spaces are really, really important. And what I mean by this is not so much the spaces that are inside strings like this one, but the spaces that you add in your code. So here you can see that the print statement starts at the very beginning of this line 2. But what happens if I add a space before the print statement? Now you can see I've got the editor screaming at me already. I've got errors, I've got squiggly lines, and if I run this code as it is, I'll get something that's called an indentation error. Now this is different to the previous error we had, which was a syntax error. Now what this error tells you is that there is an unexpected indent around this part of your code. That's what the error message is telling me. So we can then go and investigate and see our squiggly lines, and we can hopefully realize that, oops, we've added an extra space which we can easily get rid of, and it will calm everything down and get rid of that error. So remember, previously we were missing a closing quotation mark and we got a syntax error. And in this case, we have a indentation error by either adding in an aberrant space or accidentally inserting even a whole tab, which is created using the tab key. And all of these things will give you indentation errors. So it's really important that you be careful when you're adding spaces in your Python code. It doesn't matter so much when we have spaces in between the quotation marks, because that's a part of the string. But anywhere that is a part of the code, so in this case, anything that's not green, and you go ahead and add some spaces, you might end up with an indentation error. Now, you might also, when you add spaces in your code, not have an indentation error because the code can function. For example, if I add a space between print and the parentheses. But in this case, nothing really changes in terms of our output. But we do get a warning because this is not really ideally how we should format our code. So our warning tells us that according to PEP 8 and best practices, there shouldn't be white space before an open parenthesis. So we can also use that hint to get rid of any of these issues. So the message here is be careful when you're adding spaces. Make sure you know what it's doing, and when you see the error indentation error, remember what you learned in this lesson to be able to fix it. Now, as helpful as these warnings and errors are, you'll notice that I'm putting a lot of emphasis on looking at the errors that come out after we hit run. And that's because this comes from the Python compiler itself. This will be the same whenever you write Python code. However, these squiggly lines and these errors that you get when you hover over them are specific to the editor that we're using here, which is PyCharm. Now, if you happen to be using a different type of editor, they might not give you the same kind of warnings and they might not give you the same kind of errors. And the messages will also be wildly different. So it's always really important to learn the errors that you get back after you run your code and to remember these words, syntax error or indentation error. And this is something that will help you no matter what tools you use, making you a more flexible developer. And we're going to see this in practice right now because I've got a debugging exercise coming up for you right after this lesson. And we're going to be doing it inside a different editor without the assistance of all of these helpful squiggly lines. So can you rely on your skills, your ability to debug when you run your code and see error messages and go through each of the lines of the debugging exercise one by one and fix each problem from top to bottom? This word debugging actually comes from a story where back in the 80s, a moth actually flew into one of the early computers and it got electrocuted, unfortunately, for the moth. And for the programmer, it meant that his code wasn't performing as he would expect it to. So he actually had to go into the computer, pick out the moth, and fix the wires so that it would work again. Now, we don't have any moths flying around in our code, thankfully, but what we do have to do is we have to pick out the errors so that our code will run in the way that we expect it to, without any errors. So head over to the next lesson and try out your first debugging exercise. Now, if you head over to task number 3 in today's set of exercises, you'll see the code that we had from previously. And today, I want to talk about a different function. So we've seen the print function and all the things that we can do to strings and use the print function and debug it. But what if we wanted to be able to enter some data? So if we wanted to say, ask the user, what is your name? And when we run this code, you can see that being printed. But there's no way for the user on this side to be able to give our code some data to work with. In order to do that, instead of using the print function, we're going to use a different function, and it's called the input function. And notice how, as I'm typing, Code Intelligence is already giving me some suggestions because it thinks it knows what I might want, and it's right. So this is what the input function looks like. This is the name of the function, and again, it's followed by some parentheses. Inside the parentheses is the prompt that I'm going to give the user. So when I run this code, it will say, "What is your name?" Now this time you'll notice a couple of differences. Firstly, it doesn't have that final line process finish with exit code 0. It's actually not saying anything at all. Plus, when you look up here, you'll see that in addition to the play button, there's the stop button being highlighted, and the play button, it has changed this rerun symbol. So what does all of this mean? Well, it means that we're actually in the middle of the process of running our code. It hasn't exited yet. And what exactly is it waiting for? Well, it's waiting for us to click into this output pane and actually type in an input. So the prompt is the text that goes into the input command. And then afterwards, we can add some actual input, whatever it is we want, into the output area. And now once I hit enter, you'll see that finally we have the process finished with exit code. You'll see the stop button is gone, and we can now rerun the code as usual. But where did this text go, and how can we capture it? The input function looks pretty much identical to the print function, but instead of the word print, it's just got the word input. And inside the parentheses, instead of adding what text will be printed, we're adding the prompt for the user to give them a hint as to what kind of data we want. And then when you run this code, it will print out the prompt, but then there will be a cursor. In some places, you'll see it like a flashing cursor. Other places, it'll just be a solid cursor. And in some places, you won't even see a cursor until you click into the output area, ready for the user to type in some piece of data. So what can we do with this data? Well, we can use it inside our code. Now, the way that this works is when this line is run by the computer, it takes your command as understanding that you want the user, so somebody to be able to, you want the user to be able to type in an input into this area. And whatever it is they type, you're going to take it back into the code and replace this command with it. So this is a little bit abstract when we see it like this, but let's imagine we wanted to write a print statement and we wanted to say hello and we wanted to greet the user. Now, I know that in my case, my name is Angela, so I would get it to say hello, Angela. But what if you didn't know the name of your user? Well, you wouldn't just want to say hello user or hello something generic. You would want them to be able to type in their name. So this is where a little bit of string concatenation comes in, which we learnt before. If we take this input function that we've explored just now, and we paste it into this print statement. So this can be a little bit confusing, so just concentrate right here. There's two parentheses at the end. And the reason for this is because this first one closes off the print statement. So we're saying everything between here and here, we want it to be printed. Now, what is in between there? Well, firstly, it's the string that says hello, and then a space, and then what we had as the input. So whatever the user types into here will replace this highlighted part, and we'll end up with hello, concatenate, so add to another string. So let's try this out. Let's go ahead and hit run. And you can see the prompt show up in the output area. So now if I click into this area, my cursor starts flashing and I can type whatever it is I want. Now when I hit enter, what I type is going to go and replace this input function. And then once it's in there, the print function is going to carry out its role, and it's going to add the word hello in front of it and then print it out right here. So we can see now, hello, Angela. But this is, of course, making our code a lot more adaptable. So if tomorrow I decided to change my name to Cherry, there's a really embarrassing story about this. So when I first moved to the UK, I wanted to pick my own name because I was 9 years old, and I wanted a very fruit-related name. And this was the name that I wanted. And my parents, as wise as they are, said, no, we will pick your name. So that's how I ended up with the name Angela. So now you can see this gets added in to the hello, and we can have a completely adaptable bit of code. So now it's time for a small challenge. Can you use what you've learned from previous lessons and also this lesson to figure out how to add a exclamation mark to the end of the sentence that's being printed? So instead of just hello Angela, we want the output to say hello, and then we take in whatever it is user inputs into here, and then we replace that with the user input, and finally we add an exclamation mark. Now, of course, we have to do this using strings and using what we've learned about Python code. So pause the video, read the description of the problem, and see if you can solve it. Okay, so if you remember from string concatenation, what we need to do is we need to treat this input function as its own string, because eventually it's going to be replaced by a string. So we can take that part, set it aside, and then we can use the plus sign to concatenate the final character, which is a exclamation mark, to this entire long string. So now if I go ahead and run this code and I type in an input, that input gets inserted and replaces this entire input function, and then finally I get the exclamation mark added to the end. If you find this line of code difficult to understand and to wrap your head around, then I recommend heading over to a website called thonny.org and downloading an application called Thonny. It's completely free and it's available for Windows, Mac, and Linux. And once you've installed this application, you can go ahead and paste your line of code here and click on this little debug symbol. And then we can click on this button, which is called the Step Into button, to step into the execution of this line of code, to see how the computer is evaluating this code here, step by step. So you'll see the first thing it tries to do is it will try to run this print statement. It looks inside these parentheses to see what it needs to print. So the first thing is this hello, and it turns that into a string. And then it looks at the next thing after the plus sign to see what it should turn this into. And this, of course, is the input function. So as I continue stepping into it, it's actually going to execute it. So it's going to run this input function and show the prompt, what is your name? So that's what shows up down here. And now if I enter a value in here and hit enter, then that value that I put right there replaces that previous input function and is now held inside the print statement. So if I continue stepping through this code, then you'll see it concatenates all of the pieces together, and finally it just ends up with a simple print hello Angela exclamation mark. And if I continue stepping into it, you'll see that line of code executed until there are no more instructions left. So if you prefer seeing your code run like this step by step so that you can see what's going on, then I recommend giving this a go. As you're learning to code, there's going to be new concepts covered. There's going to be things that take a little bit of thinking before you can understand it. So what a lot of programmers love to do is they like to comment in their code. Now, you might have seen this already throughout the coding exercises and the solutions I provided. But in Python, if you wanted a line of text to not be considered by the computer at all you have to do is add the hashtag or pound sign in front of your text. And this turns it into a comment, so something that the computer will completely ignore. So in here you can write code as much as you like, but it won't be executed. And when you click run, you'll see that this is completely ignored. What I recommend is whenever you come across a new concept in the course, to make a comment above it so that you can explain to yourself what's actually going on in the line of code below. This way, the next time you come across this line of code and you're not quite sure what's actually happening here, you can have a look at the notes that you've written for yourself in your own words, and hopefully it'll re-jog your memory and make it much easier to comprehend what's going on. In addition to adding a pound sign manually, you can also highlight a line of code or simply have your cursor on a line of code and hold down Command and / if you're on Mac, or Control and / if you're on Windows.
And what this does is it takes this line of code out of the computer's awareness, and it's no longer executed when you run this code file. So the process is finished without anything being carried out at all, because all the computer is seeing is a blank page, because we've taken all the code out into comments. So in order to take this back into code, all you have to do is use the same command that you tried just now. So Command / on Mac or Control / on Windows. And this will now again be considered as code by the computer.
All right. So in this lesson, we learned about the input function. We learned about putting functions inside other functions and being able to get user input from the console by using the input function. And if you've commented this line of code thoroughly and you've fully understood how it works, then you'll be able to breeze through the next exercise. So for all of that and more, I'll see you there. Now, in this lesson, I want to talk to you about Python variables, and it's a really, really useful concept. The first thing I want to do is to take a look at this line of code that you should have already. And when we run this, we should be pretty familiar with what happens, right? It will ask us for our name, and when we hit enter, nothing happens. But behind the scenes, this name or this input has now been received by this function. But once that's done, it kind of just disappears, right? And there's no way for us to be able to refer to it in the future. Or is there? Well, this is where variables come in really handy. If I give the result of this action a name, well, then I'll be able to refer to it later on. So at the beginning of the line, I'm going to call it name, and then I'm going to add an equal sign. And what this does is it assigns whatever it is that the user typed in as the input to this prompt to a variable called name. So now, if I go ahead and run my code again, and I enter a name, now once I hit enter, normally there's no way for me to get hold of this anymore, right? But now I can actually go ahead and write print. I'm going to print the value of this variable name. So now if I run my code and I write a name, hit enter, you'll see that this gets printed, and I can use this at any point in my code just by referring to the name that's attached to this value. So it's almost like we've saved the data from this action to a name. And if you think about it, if you had a phone book, let's say, and you just jotted down the numbers of people, the next time you look at this, there's no way for you to know whose number that is, right? In a sense, it's the same thing with the computer. Even though we've inputted this piece of data, there's no way for us to be able to refer to this data unless we give it a name. So in our phone book, we might say that this particular number is associated with the name James. And in programming, we would call this name James a variable. So we could write something like James equals, and then his phone number. And this means that in the future, if we ever need this piece of data, we can just refer to it by its name, the variable name of James. Now, as the name variable suggests, it's something that can be changed or can be varied. So, for example, just because this name is set to something up here doesn't mean that I can't change it later on. So, to make things simple, let's go ahead and delete the input function, and let's just say name is equal to Jack. Print name. When I run that, Jack is what gets printed inside the console, because I'm now referring to that piece of data by the variable name. But if later on I decide to give this variable a different piece of data to hold on to, let's say Angela, and I print name at this time point after I've changed it, what do you think these two lines will print? What do you think will first be printed? What do you think will be printed second? So even though they're both printing the same variable, at this point, when we first call print, it's holding on to the value of Jack. But by line 5, I've now changed it so that it's holding on to the value of Angela.
So to practice that, I have a challenge for you. So I want you to be able to figure out how many characters are in the name that the user types in using the input function. So you already know how the input function works. You already know how to get the user to enter it and then to get that data back into our code and print it out. But here's the extra step. Can you calculate how many characters there are in the name that they type in? For example, if they typed in Jack, that would be 4. If they typed in Angela, that would be 6. Now, how do we figure out things when we're programming and we're trying to do something that we haven't done before? Well, one of the most important skills as a programmer is to be able to use Google well, is to be able to find the answers that you need, because it's inevitable that you won't remember every single function and you won't know every single function. So we need to read documentation and we need to know how to get hold of it. So very simple, we start off with our query, how to find the length of a string, and then we add our programming language, because this will be different in every programming language. So I normally just add Python to the end of it. And then once we hit enter, normally we'll get hold of some form of documentation, and the W3 Schools documentation for Python is not bad, and you can also browse through all of the other examples. So normally for Python, I stick to W3 Schools or Stack Overflow, and both of these will give you the right answer. But if we are reading documentation, then you can see that normally there's a whole bunch of other things that we can look up, just like a dictionary of Python. Now, as you wouldn't start with a dictionary when you're learning a new language, believe me, I tried that, it did not work. You also wouldn't want to learn through everything in the documentation because it's very dry, and when you don't have a real life application, when you're not trying to use a particular function or some sort of component, then you also don't remember it very well. So I recommend to find what you need when you need it, and our brain is for thinking and not for storing, because these days, as you know, it's super cheap to buy a single terabyte storage hard disk online. I think it costs something like $10 or $20, and it's just getting cheaper every day. So don't use your brain to store things, use it to think. But coming back to our documentation here, in order to get the Python string length, we use the len function. And just like the print function, it's an inbuilt function in Python. So we can simply just write len, and then we can use whatever it is we want to measure. For example, in this case, it's hello world, and it will output the number of characters in that string. So now give it a go yourself. So the pos1 is the instruction set, and I want you to get user input. I want you to take that user input and calculate the length of the string that the user inputted, and finally to print that number out into the output area. And everything could be done in just one line of code. So try to find the documentation, try to figure out how to do this, and I'll see you on the other side where we run through the solution. So pause the video now. All right, so referring to the documentation, it's pretty straightforward. The first thing we're going to do is we're going to get hold of the input. So we know the input function looks like this, and we can add in whatever prompt we want. So what is your name? And then we're going to wrap this input inside another set of parentheses. And you can do that without having to type open and closing brackets. If you just highlight the entire line you want to wrap and then type the open bracket, and it should wrap everything inside. So the next step is to calculate the length, which is using the len function that we just heard about. And then finally, I'm going to wrap everything in just one more bracket. And this one is the print function. So the three steps are: we get hold of the user input, we calculate the number of characters in that input, and then finally we print it out into the output area. So now let's go ahead and run our code. So first line that comes out is these two print statements from before. And then the third line asks me, what is my name? And you can see the process is paused, waiting for me to type that in. And then once I hit enter, that name is going to replace this part of our code, and it's going to calculate the length. And then finally, that length is going to be printed, and we get 6, which is correct. That's the number of characters in my name. So hopefully you've learned a little bit about documentation and also search, and also the importance of being able to get your own answers as a programmer. So now I have another coding challenge for you. Can you use what you've learned about creating variables and using variables in order to take these two parts, the input function and the output of the len function, and store them in separate variables? So there should be a variable called username that will store whatever the user enters into the input area. And then using that variable, you're going to create a variable called length to calculate the length of the username. So then instead of this combined print statement, we can end up with simply just printing length at the end. So that way we can get the same result as this, but we use several steps to get there by creating and using some variables. So give this a try, pause the video, and if it doesn't work, come back and we'll go through the solution together. Okay, so the first step is we're going to create our first variable, which is called username. And this is simply going to be set to store whatever the user types into the input. And that will get stored under this reference, username. And then we're going to use that to calculate the length of the username. But instead of putting the input into the length, we can now refer to it using our variable name, username. So now we can print this new variable that we created on line 9, and through these 3 steps, we've made this one single line code, hopefully a little bit easier to understand. So we get the username from the input, we calculate the length from the username, and then finally we print the length. And when we hit run, you'll see exactly the same thing happens. We get the same code. Now, at this point, you might be wondering to yourself, what exactly is the point of variables? We've just turned one very, very short line into 3 very long lines. Now, of course, we're working with very, very simple examples here, and it might be hard to see the exact use case, but as things get more complicated, you will be glad to know how to use variables. Even in this simple situation, you can see that instead of this line of code, having these 3 lines of code makes our code a lot more readable because we're labeling each step of our code. We're saying, well, from this line of code, we're going to get hold of the username. From this line of code, we're going to work out the length of the username. And then finally, we're going to use that final variable and print it out. Now, as things get more complex, and being able to split up code into smaller modules will become a lifesaver. So in the next lesson, I've got a coding exercise for you, and hopefully through more and more examples, you'll see just how useful variables can be. Right now, bear with me
and just try to learn to create variables and use variables. And I promise it's going to all become very, very clear very soon just how useful they are. Now, when it comes to naming your variables, you can pretty much call it whatever it is you want. So instead of calling this name, I could have just called it N. And I could have called this L. And as long as I'm consistent, so if I wanted to get the length of N, then I would have to change this as well. And if I wanted to print out L, then I have to change this as well. But there's a couple of rules that you should probably follow. And the most important one is to make your code readable. Because if you come back to this in 6 months, 12 months, N and L is not going to have a lot of meaning for you. So try to make sure that it actually makes sense to you. And if you want to, you can actually have multiple words in the name of your variable. So for example, if you wanted to call this username, then you would write the word user, and then you would separate each of the words with an underscore. But you can't have a space in between. This is not valid code. And if you try to run it, you'll get a syntax error. So the name of the variable has to be one single unit. And in order to separate words in Python, we use the underscore. Now, if you want to use numbers in the name of your variable, you can. So for example, length 1, length 2, but they can't be at the beginning of the name of the variable. So you can't say 1 length or 3 length. That will generate a syntax error as well. Finally, there's certain privilege words that we use. For example, the names of our functions like print and input. And it's usually good practice to not use them as the names of your variables, because you can see that syntax highlighting gets messed up because it thinks that it's actually an input function you're trying to create. And even though often when you run your app, it might not have any issues, this is really bad practice because it's very confusing. So try to make sure that all the names of your variables get highlighted like the other variables in the same color. Now, the final thing to remember is that if you decide to call your variable this particular name, N-A-M-E, and at a later point you make a typo and you spell it wrong. So maybe instead of name, you said nama. This is not going to work. And when you run your code, you'll get what's called a name error because it says this name is not defined. And the idea is that you would look at where the error is, line 2, print nama, and you'll see, oh, that's not right. It's meant to be spelled N-A-M-E. So you'll have to go and fix it in order for your code to work. Now, remember that this is not because Python is doing any sort of spell checking for you. It's like, oh, that's not how you spell name. No, in fact, if you decided to call this nama, and you later on use it as nama, there's no problems. Other than this green squiggly underline, which tells you that there is a typo in this word, Python doesn't actually care, and that's why your file is still checked. Because very often you might be in the situation where you need to create something that is unique, right? You might have a player in your video game called Nama and you decide to call it that. It's totally up to you. And the only thing that Python really cares about is that you are consistent. This is the name that's associated with this piece of data. Later on, when you want to use this piece of data, you use this name to refer to it. And as long as these two spellings are identical, then the computer doesn't care at all. So when you get a name error in your code, you now know it's probably because you've misspelled or mistyped one of the variable names somewhere in your code. Now, in the next lesson, I prepared a quiz for you where you'll get to select which variable names are valid and which ones are not good practice. Have a go at that over on the next lesson. All right, guys, it's time for the final project of today. So the program that you're going to be building looks a little bit like this, and you can check it out if you head over to this link, either by typing it in or heading to the course resources page and clicking on the corresponding link. But essentially, it's a band name generator, and it asks you for a city that you grew up in and the name of your pet, and then it combines those together and gives you the name of your band. There's a couple of things to note here. Firstly is notice when this input got triggered, the cursor actually showed up on a new line. So if I run this again, you can see it says, what's the name of the city you grew up in? And then the cursor is on the next line. And what I want you to do is to go ahead and head over to this starting project. So there's a couple of steps in here as hints, but the important thing is once you've completed this project, it should work exactly the same as the one that you see here. And in order to do this, you're going to have to apply everything that you learned today, including printing, inputs, variables, new lines, string manipulation, debugging, and a whole lot more. So this is the time to grab yourself a cup of tea or coffee, pause the video, and tackle this final project. Alright guys, I hope you gave that a go and you were able to complete it. If you want to see how I've implemented it, or if you want to just check to see if you have any errors, or if there's something that you're unsure about, then continue watching and I'll go through the solution with you. The first step is to create a greeting for your program. In our case, it says, welcome to the band name generator. So that's exactly what I'm going to create. And we print these messages using the print function. So I'm going to say, welcome to the band name generator. And this, when I run it, will just print that message. Now the next step is to ask the user for the city that they grew up in. So in order to get some input from the user, we'll need, of course, the input function, and we're going to ask them using the prompt, which goes inside the parentheses, which city did you grow up in? So now when I hit run, it's going to ask me for the city that I grew up in, and I'm able to add a reply, like so. Now that data is just going to be lost to thin air unless I capture it and I give it a name. So I'm going to have to create a variable to hold on to the data that the user inputted. So we'll just call that city and then add the equal sign to assign whatever it is that the user typed in to this variable name. And now I have access to this city variable and I can print it or use it later on if I want to, like so. Now, the next step is to ask the user for the name of a pet. So we'll call that variable pet and we'll assign it the value that the user input for what is the name of a pet. Now, step 4 is to combine the name of the city and the pet and show them their band name. Now, there's quite a few ways of doing this, especially if you look around on the internet. But the way that you learn in today's lessons is using string concatenation. So we're going to do that. So we're going to use a print statement and tell them your band name could be, and then we're going to add the name of the city and then add a space and then add the name of their pet. So now when we run our code, it will ask us for the name of their city and then the name of a pet. And then it should combine those together and show us the name of our band. Now the final step is that the input cursor should show on a new line like this. So here's the cursor, but here's the input, just so that you get a bit of space and you're not typing it in directly after the prompt here, like what we have. So how do we do that? Well, you learned about modifying strings by creating a new line using the \n. And we can add that both to the end of the city input and the pet input. And now when we run our code, you'll see that the cursor now shows up on the next line and our program looks a lot better. So there you have it. This is how you solve this boss challenge, and this is how you create the band name generator project. So I hope you had fun with me today learning Python and a lot of the fundamentals of Python. And tomorrow I've got another jam-packed module of really awesome tutorials and code challenges and projects for you to sink your teeth into. I'm looking forward to seeing you tomorrow. So have a rest now and let your brain work on the things that you learned while you sleep. And I'll see you here bright and early. Good night and see you tomorrow.
Well done! You've just completed your first day. And remember that a journey of 1,000 miles can't begin without the first step. So congratulations on doing that and completing it. Now remember that the first few days might take a little bit longer than an hour to complete, just because I've got so much to teach you and so much to cram into each of these days. So it doesn't matter if you need to take a break in between or if you need to take a nap in between even. Just come back to it whenever you can, and you don't have to do it strictly in the day-by-day order. Now my hope is that you'll keep going and you'll come back tomorrow refreshed and you'll tackle the next day's subjects with the same vigor that you did today. So have a good rest and I'll see you tomorrow.
Hey guys, welcome back to day 2 of 100 days of code. In today's lessons, you're going to be learning about data types, numbers, operations, type conversion, f-strings, and a whole lot more. And by the end of today, you will have learned enough to build a tip calculator. So it looks a bit like this. It says, welcome to the tip calculator. It asks you for the total bill that you need to pay. So let's say it came to $124.54. We hit enter, and then it asks you what percentage tip would you like to give. So let's say we give a 12% tip. And it asks you finally, how many people do you want to split the bill between? So let's say there's 5 of us having the meal. Now it's going to calculate what each person should pay, taking into account all of these pieces of information that you've put in. So I know that I'm pretty bad at maths, especially when it comes to splitting bills. And I'm normally the person who just says, yeah, just tell me what I need to pay so I don't have to calculate it. It's like the bad at math tax that I pay. But in order to build this, you're going to need to learn some new skills, including working with numbers, converting data types from one type to another, and a whole lot more. So if you feel like you can tackle this no problems, then feel free to skip today's lessons. But I bet that there'll be loads of stuff that you'll come across in the upcoming lessons and coding exercises that's really going to make you a better developer. So once you're ready to get started, head over to the next lesson and let's start coding. Yesterday, you saw that we could use the len function to get the number of characters in a string. So for example, when I write len hello and I print this out, we end up with 5. There's 5 characters in the string hello. Now, here's a question. What happens if instead of counting the number of characters in a string, what if I put in a number instead? And I wanted to know how many digits are in this number. Now, if I go ahead and run this code, you'll see that it actually crashes. I get a whole bunch of red text and it tells me that there is a type error and something about the type int. So what is all of this about? Well, in order to understand it, we first have to learn about data types. Now, on day 1, we already explored this data type called strings. Now, you're probably not going to be surprised to learn that there's a whole lot more other data types out there. And today, we're going to explore some of the most important and some of the most basic data types, such as strings, integers, floats, and booleans. And we'll explore each of these in detail. So let's take a look at some of the data types. So we already learned about strings, right? And we know that this is just a string of characters. So the word hello is comprised of these 5 characters strung together. And we always know that strings, when we create them, we have to create them with these double quotes around. Now, because this is a string of characters, we can actually pull out each character individually. So we could, for example, instead of just writing hello, we can add some square brackets. So take a look on your keyboard and see where those are. And inside the square brackets, we can put the index or the position of the character that we want. So for example, if I wanted to have the first character out of this word hello, I would put 0 right here. And if I go ahead and print what this actually will give me, you'll see that you get capital H, because that is the first character of this string. And it's really important to remember that programmers always start counting from 0, because we work with binary, zeros and ones. So whenever you want to get hold of the first character or the first of anything, it always is at 0. So this method of pulling out a particular element from a string is called subscripting. And the number in between the square brackets determines which character you're going to pull out. And it just goes up from 0 to 1 to 2 and so on and so forth. So whenever you get a result that's just off by 1, then remember to check whether if you've started counting from 0 or if you started counting from 1. Now, you can of course extend this and get hold of the last character. So pause the video and see if you can change the code so that O gets printed out here. Alright, so this is as simple as simply counting from 0, 1, 2, 3, 4. So if we change this to 4 and we run our code, then you'll see that O gets printed instead of the H.
Now, there's also a secret trick that not many people know, even seasoned Python developers. And it's the fact that you can actually use negative indices. So instead of specifying the position as a positive number, you can also use a negative number. And -1 means get hold of the last character in the string. So we can go ahead and run this and you can see it's also O. And we can start counting backwards as well, starting from the end going to the beginning. So that's just a quick tip. So by using these square brackets and putting a number inside, we're able to dissect our string and pull out individual characters as and when we need it. And this will come in really handy in a lot of the programs that you'll write in the future. Now, it's important to remember though that just because I can write a number like 1, 2, 3, as long as it's capped inside these double quotes, then this is not treated as a number by the computer. It's treated just as any other piece of text. You can't, for example, say, what is 1, 2, 3 plus 3, 4, 5? If I try to print this, what do you think will happen? Do you think it will give me 1, 2, 3 plus 3, 4, 5 in the traditional sense, like calculating it? Or do you think it'll do something else? All right, let's hit run. And we get 1, 2, 3, 3, 4, 5. So it's basically just concatenated these two strings together, just as we have done with other strings like hello and world, right? Because it sees the data type of these two pieces of data as strings, when we use the plus sign, it will actually just concatenate these two things instead of doing a mathematical operation. Now, if we wanted to do that, then we actually have to declare our number as a number data type. So one of the most common that you'll see is called an integer. So this is programming lingo for just whole numbers, numbers without any decimal places. And in order to create an integer or declare an integer data type, all you have to do is just write the number without anything else. So now, if I just write the numbers 1, 2, 3 plus 3, 4, 5, and then I go ahead and print this, then you'll see that we actually get 4, 6, 8. So it's actually being calculated because I've got actual numbers instead of strings. Just as we have some useful things that we can do with strings, there's some really handy things that you can do with integers. Commonly, when we write large numbers, at least in the UK or in the US, we like to put commas in between the thousands. So when we think of large numbers with these commas in between to split it into an easier to understand number, in Python, we can replace those commas simply with underscores, and it will be interpreted by the computer as if you had written this. So the computer actually removes those underscores and ignores it. The benefit is just for us humans to be able to visualize it more easily. So I mentioned that all whole numbers, no matter if they're positive or negative, are called integers in programming.
So what do you call it when you actually have decimal places? Well, they're called a float. And this is short for a floating point number. So for example, if you had the numbers of pi, you have 3.14159. And this, because it has a decimal place, is now a float data type. So if you think of the decimal point as being able to float around the number because it could occur at any point, then you've got yourself a floating point number. Now the final data type is something called a Boolean. And this is very simple. It only has two possible values, true or false. Now note how these values always begin with a capital T or a capital F, and they don't have any quotation marks around them or anything. So this is actually a data type which is going to be used a lot in your programs to test if something is true or if something is false, and for your program to respond accordingly. So we're going to be using this a lot more in the future. Now that you've seen a lot of the basic data types, strings, integers, floats, and Boolean, I want you to head over to the next lesson where I've got a quiz for you to see if you've made this knowledge your own. So head over to the quiz and give it a go. Previously, we saw how the len function gives us a type error when we give it a number instead of a string. So let's talk a little bit more about data types and functions. And the way I think about functions is kind of like some sort of fancy machine that you might see in a factory, right? So in this case, we've got some sort of machine that's going to take potatoes into chips. And we don't really care how it does it, but it's probably going to have to peel the potatoes, wash the potatoes, cut it up, fry it, and then finally return it to us as an output in the form of fries. And if this is the first time that you're watching one of my tutorials, this is probably a health warning. I talk about food a lot. So be prepared if you haven't eaten. Now, let's say that we took the same machine that normally processes potatoes and we decide to give it a rock. And we just pass this through the function. Then we're going to get an error, right? This is basically what happened here. This length function doesn't like working with integers. And by forcing this through, we end up with an error and our code breaks. And it gives us this thing, a type error. Now, if we hover over this yellow warning, we also get the explanation here. Expected type, something called sized, and got int or an integer instead. So this is already pretty clear where our mistake is, even before we hit run. And the other helpful thing is when you hover over any function in Python, it gives you the definition of it. And in between the brackets, you can see the data type that that function expects. So the length function expects a data type with something that's called sized. And we can actually click on this link to see the documentation on docs.python.org, which is the official Python documentation. Now, I know previously I told you to try using something like W3 Schools or using Stack Overflow. And the reason is because the documentation from the official Python organization is very, very short. So sometimes it can be enough, but very often I find that it's helpful to find another source to back up this very, very brief explanation. But in our case, in this situation, it does help us. For example, it tells us that len will return the length, which is the number of items of an object. And the argument, which is what you put in between the brackets, may be a sequence, such as a string, byte, tuple, list, or range, or a collection, such as a dictionary, set, or frozen set. Don't worry about these other data types that we haven't come across yet. We're going to come across them in due time, and we're going to be learning all about them. But for now, you already see one that you recognize, which is string. So it can take string, but nowhere in this list does it say it can take an integer or any other number data type. So as the first pause exercise, I want you to fix this len function so that we actually give it a data type that it recognizes, and we fix this type error so that when we run it, it works as expected. And you can put anything in there as long as it gets rid of the warnings and errors. Pause the video now. All right, this should be relatively easy. We can change this to any string, which we already know is a data type that this function can accept. So we can simply change it to hello or whichever string you can think of. And now when we hit run, all our errors and warnings should now go away. If you see something like pep8 blank line at end of file and it bothers you, don't worry about it too much, but it's basically saying that in an ideal situation, a Python file should only have one blank line at the very bottom. So if I hit run again, that will clear up that warning. For everybody out there who has a little bit of OCD like me, this can be a lifesaver. So now that we've seen that in Python, each function expects to work with a specific set of data types. So there's only certain data types that can go into the parentheses of a particular function. Now, here comes the question. Well, how would we know what data type a particular piece of data has? So how would we know what is the data type of hello? Well, it's very easy to visually see it because it has the double quotes around it, and anything with double quotes around it, even if it's a number, is in fact a string. But there is also one function in Python that allows us to check the data type of any piece of data or variable. So all we need to do is to use the keyword type, and then in between the parentheses, we can put in any piece of data. It can accept any data type, and then it will give us in return the data type. But as always, in order to see it, we have to wrap this inside a set of parentheses and use the print statement to put this into the output area. So let's run that, and you can see it tells us that this is something called a class string. So this is basically saying it checked the data type of this piece of data we gave it, and it told us that it's actually a string, which is what we expected as well. So we can do this with various different data types. Let's check it with a number. Well, in this case, we gave it a whole number, so no decimal places, and it told us it's an integer. We could do this with floats, with booleans, and it will always very, very helpfully tell us what is the data type. And this is something called type checking. So now it's time for another quick pause check to make sure you understood what's going on. I want you to write out 4 lines of code to print out the 4 different data types that we have already learnt about. So it's going to be the string, the integer, the float, and the boolean. And we want all 4 of these printed out in 4 lines in the output area using what you've learned and the correct data type to put in inside the parentheses for the type check. So pause the video now and give this a go. All right, so we've got already the integer type. So let's put the string one above it. And we know that all strings go inside a set of double quotes. And then we want a floating point number. So we could do 3.14. And finally, we want a Boolean type, which we know is either true or false with a capital T and capital F. So now if I hit run, we should see class string, int, float, and bool, the full collection of all the major primitive Python data types that we learnt about in the last lesson. If that was confusing at all, review the last lesson, and hopefully this all makes perfect sense. Now, what if we aren't happy with the assigned data type? What if we want to convert a piece of data into a different data type? Well, then we would need to learn about something called type conversion, also known as typecasting in Python. So let's go ahead and clear the board to make this less confusing. And let's start out with a very simple string. So we all know that this is a string because it's enclosed in a set of double quotes. But what if I wanted to turn it into an integer? Well, I can use one of the built-in functions called int, and I can convert this into a number. So whereas previously we saw that if we tried to print the string 123 plus 456, then we would end up with 1, 2, 3, 4, 5, 6.
And because both of these pieces of data are string data types, the plus sign does concatenation instead of maths and adding these two together. But now that we've converted this 123 into an integer, you can see that if we replace this string with this typecasted integer, and we could do the same for 456, now if I hit run, you'll see that it actually treats them as numbers and adds them together. So this is the power of type conversion. Now, one of the dangerous things about this is, of course, sometimes you can't convert things into a different data type. For example, if I tried to convert ABC into a number, well, that doesn't really make sense. If I gave that to you, what would ABC be as a number? I don't know. So if we run this, you can see we get something called a value error. So I hope you're collecting these errors in a notebook somewhere, because we're coming across lots of them, and you will come across more in your lifetime as a Python developer. So this is saying that there is an invalid literal for the int, which is ABC. And so it doesn't really make sense to convert this into a number, is what it's trying to tell you. So you have to be really careful when you're doing type conversions, because sometimes you can end up with errors and sometimes you can just simply lose data. But we can use this method to convert things into all of the four major primitive types that we've learned about. So we can convert to an integer, we can convert into a float, we can convert into a string, and we can even convert into a bool. So to check that you've understood how to convert between different data types and why we get different type errors, I have a final pause challenge for you, which is to make this line of code run without errors. So I want you to go ahead and copy this line of code, paste it into your code file, and try to hit run. Now go ahead and enter a name triggered by this input, and then you will see that you get a type error. So read through the type error, see if you can understand what it's trying to tell you, and fix this code so that it does what you expect it to do, which is to print out the number of letters in the name that the user submits into the input. Pause the video, give this a go. All right, so in order to break this problem down, let's use some variables to simplify things and make it easier to read. Let's take this second part of this print statement and let's take it out into separate variables. So we know that we can get the name of the user by using this input function. And I'm making these variable names extra wordy just so that when you read it, it makes a little bit more sense. And I'm actually going to delete the rest of this as well, just to make everything easy to read. So next we need the length of name. And this is done by using the len function, and we pass in the name of the user that we got from line 1. So now finally, what we have here is the length of the name, which we want to tag to the end of this print statement. Now, what is this error trying to tell us? It's saying you can only concatenate string to a string, not an integer, which is what it sees in this line of code. So where is the integer? Well, we know that when we calculate the length of something, it gives us a number, it gives us a whole number. So this is probably an integer. Well, we can verify this by using a type check, right? We can print the first part of this concatenation and we can put it inside a type function to check what is the data type of this first part. And then we can also check the data type of the second part, which is now called length of name. So let's comment this out. Let's go ahead and run this code, enter a name, and you can see the first one is a string and the second one is an integer. So this is a
type string, and this is a type int. So now it makes sense that when we're printing, we can't simply concatenate a string to a number. It doesn't know how to do that. So how can we convert this length of name into the same data type as this first part, which is a string? Well, you learned how to do that already. All we need to do is to wrap this inside a set of parentheses, which is the string type conversion. And so now we have this part, which is now a string, and then we add it to another string. And now if I run this code again, then you'll see that it works without any issues. Number of letters in your name, 6, printed out. So hopefully this makes sense to you, and you'll be able to understand in the future how to do type conversions and how to understand when you have different type errors, what has gone wrong. In the previous lesson, we saw how we could use the plus sign either to concatenate strings together or as a mathematical operation where we add 2 integers or 2 floats, basically 2 numbers together. In this lesson, I want to show you some of the other mathematical operators that you have access to, in addition to adding. The next obvious one is subtraction. So 7 minus 3, you would just use the minus sign. But then when you get to multiplication, it's a little bit weird. Instead of using the X or some sort of time symbol, you actually use the asterisk. So you would say something like 3 asterisk 2, and that would be 3 times 2. Now the final one is division, and that's done using the /. So 6 divided by 3, and when that prints out, it'll give you 2. Now one thing to notice here is that whenever you're dividing things, you actually always end up with a floating point number. So you can see even though 6 divides into 3 cleanly, we're still getting 2.0. And in fact, if I put a type check around this division, you'll see that it'll print float instead of integer. And this is just the default Python behavior. It's something called implicit typecasting, because Python is implicitly converting the result here into a floating point number. Now, sometimes you might not want that. So there is an other Python division operator that might be worth knowing about. And it's simply done with 2 /. So now when I run it, you can see what comes out is actually an integer. And I can do a type check just to confirm that as well. Instead of float, it's coming out as an integer. But you have to be very careful with this second type of division operator, because what it's doing behind the scenes is it's actually doing this step first, and then it's simply just removing all of the decimal places. So what if instead of 6 divided by 3, which we know divides cleanly into 2, what if we divided 5 by 3? What is the result of that? That's 1.6 recurring. So if I change this into 5 divided by 3 using the double /, you'll see that it just gives me 1, and it wipes out all the rest of the numbers in this integer conversion, which can be quite dangerous if you're working with scientific numbers. But it can be useful when you know that you want an end result that has no decimal places. Now the last one that's really useful is 2 asterisk signs, and this gives you access to the exponent, or when you want to raise a number to a power. So for example, if you wanted to get hold of 2 to the power of 2, then you would write it like this, and 2 to the power of 2 is of course basically just 2 times 2, which is going to be equal to 4. Now, if I change this to 2 to the power of 3, then that's going to be 2 times 2 times 2. So that should be 8, and so on and so forth. Having the exponent being built into the language is one of the reasons why Python is really loved by a lot of data scientists and mathematicians, because it's really optimized towards manipulating and handling numbers. Now, one of the things that you have to be careful about when you are doing these mathematical operations is when you have more than one operation on the same line of code, then there's a certain level of priority. So some of these operations, like division or multiplication are going to be first class, whereas other ones are going to be more economy, like the plus and minus. And the rule that you might have remembered from high school is something called PEMDAS. It basically states the order of priority is parentheses, exponents, multiplication, division, addition, and subtraction. So the things that happen first are the things inside brackets, then it's our exponents, then it's our multiplication and division, and finally the lowest priority is our addition and subtraction. Now, it's a little bit deceiving because of this order. It makes it seem like as if multiplication happens before division, but actually they are equally important. And when it actually comes to your calculations, the calculation that's most to the left is the one that will be prioritized between multiplication and division. So let me give you a real life example to make this more clear. Let's say we had a line of code where we wanted to multiply 3 by 3 plus 3 divided by 3 minus 3. If I was to execute this entire line of code and print it out into the console, here's the time where you play computer again and guess, using what you've learned here, what exactly will be printed. Because you will get a number printed, it will calculate this entire line of code for you, but the order matters. Is it going to first add 3 to 3, then multiply the result by 3? Or is it first going to divide 3 by 3 and then add 3 to it? What is the order? And I want you to really pause the video and have a little play with it on pen and paper before you come back and we'll show you the result. Using our rule PEMDAS, we can see the first thing that happens is what's in the parentheses, so that doesn't matter. The next thing are exponents. We don't actually have an exponent here. We don't have 2 to the power of 3 or something to the power of anything, so we can ignore that as well. So the next level is the multiplication and division. And as I mentioned, they are of equal importance. So this 3 times 3 and 3 divide 3 are both equally important, but the calculation goes from left to right. So the first thing we see is actually the multiplication. So if it helps you, you might want to add LR to the end of this mnemonic. So it becomes PEMDASLO, or at least that's the way I would think about it. So even if this was division and this was multiplication, this calculation will always get executed first. Coming back to the question I asked you, what do you think this number would be? Let's go ahead and comment out all the other code and run this line of code, and it will give us 7. Now, if math is not your strong point, don't worry, it's not mine either, and you're the sort of person who would prefer to see it visualized, then I recommend, again, putting this line of code in Thonny, and then go ahead and clicking on the debugging symbol, and then just step into, so press F7 or this button multiple times, and you'll see it evaluate this line of code step by step. So first it looks at the entire thing, and then it goes from left to right. And the first calculation is 3 times 3. And that is the one that's going to execute first, and it becomes 9. Next, it's going to look along this line of code and see that the next most important thing is this division here, 3 divided by 3. So it's going to carry out that next, and that becomes 1. So now 9 plus 1 is going to be the next thing because it's the most to the left, and then it becomes 10 minus 3, and we finally get the result of 7. So now here's another challenge for you. How can you change this code so that instead of getting 7, we get 3? How can you change this line of code given what you know about PEMDASLO? See if you can figure it out. Pause the video now. Alright, so this will involve a little bit of trial and error, and the most important tool we have access to us is the parentheses or the brackets. This means that we can actually isolate bits of our code which normally have very low priority and turn them into higher priority operations. If we added a set of parentheses around our 3 plus 3, then out of all of these calculations, this particular one suddenly becomes the highest priority and it will happen first. So if I change what I've got in Thonny to our new version and go ahead and debug through it, the very first calculation it's going to perform is this 3 plus 3 inside the brackets. And we end up with 6. So then it's going to go again from left to right, prioritizing multiplication and division. So then it's 3 times 6 is 18. 18 divided by 3 is 6. 6 minus 3 is 3. Just by isolating certain calculations, you can elevate it to right at the top of the priority list, and you will be able to perform the calculations that you need. Now that you've learned a lot about calculations and performing mathematical operations using Python, I've got another code challenge for you. So head over to the next lesson and you'll be able to discover it there. In the previous challenge, you saw that when we calculated the BMI and we printed out this large number divided by another number, usually there is a large number of digits after the decimal place. Now, this is not really an ideal way to output some number to the user. We'd really like to be able to round it to the nearest whole number or to a specified number of digits. So how do we do this? Well, you've already seen that we can convert any number into an integer. So instead of simply just printing the original BMI, we can convert it first into an integer and then we try printing it. You can see what this does is it floors the number. And this is a programming term for basically just removing all of the remaining decimal places, flooring it to the lowest whole number. Now, that's not quite what we want. We want to use the round function, which performs the rounding in the traditional mathematical sense, where when it's 0.5, it rounds up to the next whole number, and when it's below that, it rounds up to the lower whole number. So let's go ahead and print using the round function and round our BMI instead. See what all three of them print. So this is our original value, 3.85, and when we simply chop off the end, we have a whole number, 30, and this is called flooring, whereas rounding will round up or down one whole number depending on the first decimal place. So in this case, it becomes 31. So this depends on, of course, whether if it is 3.9 will round into 4, whereas 3.3 will round into 3. So it's a really, really handy function when we're working with numbers in Python. Now, you can go even one step further. Instead of just rounding the number, notice that it actually takes two inputs. So when I typed out round, and you can see the auto-suggest showing me the function that it thinks I'm trying to get hold of. It takes two inputs. One is the number you want to round, and the second one is the number of digits you want to round it to, which is kind of helpful because what if we wanted to take our BMI and we wanted to round it to 2 decimal places? Well, then we would write BMI as the number that will be inserted here from this variable, and then we just simply type 2. And now when I hit run, you'll see that this time, instead of simply rounding it to a whole number, it rounds it to a floating point number with 2 decimal places of accuracy. So that can be really helpful if you're working with money, for example, and you're doing Pythonic calculations, working with currencies or conversions. So Python is just generally really, really number friendly. Now, while we're working with numbers in Python, another really handy operator is called the assignment operator. So we have various different ones depending on which mathematical operation you want to do. But essentially what this allows us to do is to accumulate the results of our calculations. Now, very often when you're writing code, say, for example, if you're keeping track of the user's score, so you could have score equals 0 to begin with, and every single time in your code, say a user scores a point, then you can get hold of this score variable again, and instead of saying score now equals the previous value of score plus 1, you can simply use this shorthand plus equals. So plus equals 1. And now when we print score, you'll see that it's actually equal to 1. So instead of using plus equals, you can use minus equals, which just takes the previous version of score and removes 1 from it, multiply equals, and divide equals. So this is really handy when you have to manipulate a value based on its previous value, which you'll have to do a lot in programming. Now, the final thing I want to show you is something called f-strings. And this makes it really easy to mix strings and different data types. So far, up to this point, if we wanted to print something like your score is, and then we wanted to print the score, we have to write plus, but of course, because these are different data types, this is a string and this is an integer, we get a type error. So we've had to convert this into a string before it will actually successfully print when both the data types match. Now, this is quite painful, and understandably, a lot of programmers will need some slightly more convenient way of incorporating things that have different data types. Let's say the score is equal to 0, let's say their height is equal to 1.8, and is winning is equal to true. So here we've got a integer, a float, and a boolean, and we want to mix it all in to a sentence that is a string and get it printed out. So instead of having to convert all of these and use a whole bunch of plus signs, and then you have to convert everything into a string, it's really, really painful, right? So what we can do instead is use something in Python known as an f-string. And what an f-string allows us to do is in front of a string like this one, we type the character f. And it's really important that it goes in front of the double quotes or single quotes if you want to write your strings like this. But I like to use double quotes, and a lot of other Python programmers do too. So essentially you're adding just the character f in front of the string. And now this is an f string, and you can start adding various values into this string. So for example, if I wanted to write your score is equal to this variable score, then I can put that variable inside a set of curly braces like this. And now when I print my string, this one right here, you'll see that it says your score is 0, and it does all of the converting and all of the stuff behind the scenes, and you don't have to worry about any of this. So if I want to continue along, I could say your score is this, your height is, add in the height, and then you are winning is, then let's add that final Boolean value and get it to run. You can see that our entire string now prints out your score is 0, your height is 1.8, you are winning is true. So all of these different data types got combined into a string by using an f in front of the string, and then using these curly braces to place our variables into this string. By using f-strings, you cut down on a lot of the manual labor of inserting different data types into a string. And this is going to come in really handy just about on the next lesson, where I've got a coding challenge for you. Head over there and complete the challenge. Hey guys, welcome to the final project of today. And in this final project, we're going to be building a tip calculator. So the final output is going to look like this. It's going to print welcome to the tip calculator, and it's going to ask you for an input for how much the total bill came to. Let's say that we and a couple of friends went out for lunch and it came to $124.56. And then it'll ask you what percentage tip would you like to give. So let's say we want to give a 12% tip. So we enter 12 and hit enter. And then finally it asks how many people are splitting this bill. Let's say there's 7 of us, and then hit enter. Finally, it's going to tell us that each person should pay about $19.93. Notice how the final bill even though after all of these calculations, it's probably got more numbers after the decimal point, we only want 2 decimal places of accuracy. So it should be rounded to 2 decimal places. The second thing to remember is that these are percentages, and in order to calculate a percentage of something, you can multiply a number by the percentage number divided by 100. Let me show you this in a little bit more detail, because this project is not about testing your maths, it's about seeing how well you've understood the programming concepts. Let's say that we had a bill of $150. If we were to apply a 12% tip on top of that, then 12% is going to be equal to 12 divided by 100, which is equal to 0.12. Now the next step is we can multiply 150, the total bill, by 0.12, and this will give us what 12% of 150 is, which is 18. Now we of course have to add the tip onto the final bill, so it becomes 150 plus 18. So $150 with 12% tip is equal to $168. Now, a shorthand way of doing all of this is simply multiplying 150 by 1.12. So the 1 is 150, and then it's 0.12 on top of that. So when we do this, it gives us pretty much the same number. Now, if during your testing and your coding, you come across some sort of number that looks a little bit strange because you think 150 multiplied by 1.12 should actually equal 168 precisely. So what are all of these extra numbers at the end? Now, the short answer is you don't have to worry about it. It's simply related to how Python processes these floating point numbers. If you're really interested and you want to read about this, then I'll link to this page in the Python documentation where they tell you why this is happening. But be warned, it's pretty dense and it's pretty heavy. But the final conclusion is it's just the way that Python is approximating this number. So you don't actually have to worry about this. Now, once we've gotten to 168, the next step is to split it between 5 people. So 168 divided by 5 is equal to 33.6. Now, what we want to show the user is we want to show them the amount that they have to pay with 2 decimal places of accuracy. So we want to say something like 33.60 if this is the case, because that's normally how we represent numbers when it comes to money. So what I want you to do is to also be able to round any of these numbers to 2 decimal places. If you have successfully created this program, then it should work exactly as this example version would. And you'll be able to see the formatting where it actually tells you each person should pay this particular dollar amount, and it's rounded to 2 decimal places. And this is the amount after taking into consideration these 3 different inputs from the user. Have a play around with the final product and then have a think about how you would create this program step by step, and then try to achieve this result. This is going to test everything that you've learned so far, including f-strings, including complex mathematical operations, including PEMDAS and calculating numbers and the order in which mathematical operations are run by a computer, as well as everything you've learned in the previous lessons and previous days as well. I think this is going to be a lot of fun, and the end result is going to be kind of useful the next time that you need to split the bill between friends. So I'm going to let you pause the video and get on with it. And then once you're done, if you want to, head back over here and I'll walk through the solution with you. But I really recommend you giving it a good go before you come back. So pause the video now and I'll see you later. Okay, so we've seen how the program is supposed to work, and we're trying to create it from scratch by reverse engineering it, essentially. Now, the first thing our program should say is welcome to the tip calculator. So that's easy enough. We just have to create a print statement. Perfect. And if you're creating a really enthusiastic tip calculator, you can replace the full stop with an exclamation mark. Okay, so let's run it step by step to make sure that we don't have any errors along the way. So the first step seems to be working. Now the next step is to ask the user for some input, and we want to know what was their total bill, what did it come to? So let's go ahead and create an input and ask them what was the total bill, and then we'll add a $sign or whatever currency it is that you prefer to work with, because when we actually run this, you'll see that the input will go straight after the end of that string, so at the $sign. So now we can enter a dollar amount like this, but it's not really saved anywhere. This data just disappears because we haven't stored it inside a variable. So let's go ahead and do that. Let's call this variable bill, and we'll set it to equal whatever the user typed into this input. Now remember that this bill is going to have a data type of a string, right? So if I go ahead and hit run, and let's just type some numbers in here, you'll see that the data type of the bill is, as we said, a string. In order to be able to do maths, you might remember we have to change this into a number format, so a float or an int. Now in this case, because the bill is likely to have numbers after the decimal place, it's probably better that we turn it into a float so that we get the most accurate result possible. Now that we're done with the bill, the next question the tip calculator should ask is, what percentage tip would you like to give? 10, 12, or 15? Or you can of course switch this up depending on how much tip you normally give. So the next line is going to be another input. Here I'm asking the user how much tip would you like to give and giving them some examples. And notice how in my examples I don't actually have the percentage sign here because I don't really want them to type the percent sign into this input, because if they do, when they say 12%, this is going to be really hard for me to turn the 12% into an actual number. So you could, in your input message, say something like, how much tip would you like to give? 10, 12, or 15. Please don't add any percentage signs, just add the number or something like that. But again, once we've done this, it's not stored anywhere unless we add it into a variable. Now we've got a bill that stores the total bill as a float. And we've got a tip, which is going to be a whole number, 10, 12, or 15, right? So depending on what you think is best, you can either turn this into a float, or in my case, I'm probably going to convert it into an integer. So now we're on to the final step, which is how many people to split the bill between. So let's go ahead and create a variable called people, and I'm going to add an int wrapper around this input so that even in the very beginning we know that we have to convert the number of people into a whole number, because I've never had a meal with 3.5 people before. So the input is going to be how many people to split the bill, and at this point they should enter the number of people, which will turn into an integer stored inside this variable called people. So now that we've got all the data collected from the user, we're finally ready to do some maths. And we said that the way to work out the tip is by multiplying it by 1 point, and then the number after the decimal point is whatever percentage they decided to give. So it would be 1.1 if it was 10% and 1.15 if it was 15%. Let's go ahead and calculate the bill with tip. So remember how we said that before, the tip percentage is equal to the whole number, 10, 12, or 15, divided by 100, which turns it into 0.1, 0.12, or 0.15. And then, once this calculation is done, we can multiply it by the bill. And then finally, we add that to the original bill. So let's go ahead and print this and just check to see that it looks sensible. So bill with tip is what we're going to print, and let's put some easy numbers in there. Let's say that the bill was $100 and the tip was 10%. So then the 10% of $100 is $10. So the bill with tip, that's what's going to be printed next, should be 110. So we can type anything in here because we're not using it. And you can see that this calculation, bill with tip, is 110, which is what we want. Now, there's a lot of other ways that you can express this. For example, you could say bill times 1 plus tip divided by 100. So this would actually give you the same result as well. But remember what we said previously about how Python is a little bit weird with floating point numbers. But essentially, this is still giving us the same result, which is 110. So you can choose whichever way you find most intuitive. And if you want, you can even split this up into several steps, right? We could say that tip as percent is equal to tip divided by 100. And then we can multiply the bill by the tip as a percent to get the total tip amount. And then finally, we can get the total bill by adding the bill to the total tip amount. Feel free to do this whichever way makes sense to you, but I'm going to leave it with as many steps as possible so that you can actually work through the logic if you got stuck on this maths. Now, the next thing we need to do is to divide the total bill by the number of people. So if we had 5 people, then we would divide it 5 ways, right? So let's call this bill per person, which is going to be equal to the total bill divided by the number of people. Now, at this stage, this bill per person is a floating point number, so it could have many, many digits after the decimal point. If we want to round this to 2 decimal places, then you might remember from some of the lessons today, we have access to a function called round. And here we can add the number that we want to round, which is the bill per person. And then after a comma, we can specify how precise, how many numbers or how many decimal places do we want to round this bill to. And in our case, it's 2 decimal places. So now this is the final amount, which I'll call final amount, which is the bill per person rounded to 2 decimal places. And we can now finally print this to the user and say each person should pay. And remember, you can either use string concatenation, which will require you to convert this number into a string again, or use the trick that we learned in the previous lessons where we can create an F string by adding F in front of the string and then using some curly braces to insert the final amount right here. And we can write the final amount dollars, or we can put a $sign in front and maybe a colon here. And now if we clear our console and run our code, then you'll see it work. So welcome to the tip calculator. What was the total bill? Let's make up some random number. What percentage tip? Let's say we're going to give 15, and then we're splitting it between 5 people. And it calculates everything, doing all of that maths. And finally, it rounds it to 2 decimal places, giving us the final amount each person should pay. How did you get on with this project? Did you manage to get it in one go without having to look at the solution? If you got stuck at any point, or if your code didn't work as you expected to, this is the time to go back to it, fix it, and make sure that you've understood everything that's been covered through this exercise. So I hope you had fun building this project and doing all of the coding exercises and learning about mathematical operations, f-strings, data types, type conversion, and all of the things that we did today. Have a rest, and I'll be back tomorrow teaching you about conditional statements and how we can get the program to do different things depending on certain conditions or certain parts of our code. So I bid you good night, and I'll see you tomorrow.
Hey, you've completed day 2. So you haven't just done 1 lesson, you've actually done 2 now in a row, which is fantastic. And in fact, you are now above 50% of all the people who start something and never finish. But I know you. I know you're not one of those people. I know you're going to keep going and you're going to get this in the bag. So keep going, have a rest, have a good night's sleep, and I'll see you bright and early tomorrow morning.
Hey guys, welcome to day 3. Today you're going to learn all about conditional statements, if, else, elif, logical operators, code blocks, scope, global and local namespacing, and a whole lot more. And by the end of the day, you will know enough to be able to build this awesome choose your own adventure game. So this is what it looks like when it loads. And our mission is to find the treasure. So it tells us you're at a crossroad. Where do you want to go? Left or right? Let's say I want to go left. You come to a lake. There's an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. I'm going to wait for a boat. You arrive at the island unharmed. There's a house with 3 doors, 1 red, 1 yellow, and 1 blue. Which color do you choose? Let's choose red. And unfortunately, it's a room full of fire. Game over. So this game lets the user make decisions, and depending on what they've chosen, it continues the game storyline. If you want to have a go at this game, you can head over to this URL or simply click on the link in the course resources and have a play around with the game. And once you're ready, head over to the next lesson and we're going to start picking up the skills that's going to be required in order to build this game. So I'll see you on the next lesson. Here's a question. Have you ever sat in your bath and wondered, why is it that no matter how forgetful I am, my bath never overflows like this? This is something I was thinking about the other day. And I realized that it's not because I'm particularly diligent. I forget stuff all the time. I mean, pizza, anyone? It's what my pizzas usually look like. But the reason why our bathtub or the sink doesn't overflow is because of this fantastic piece of engineering, the overflow. So this means that whenever the water reaches beyond a certain level, about here, the water starts overflowing so that the bathtub doesn't overflow and annoy your neighbors downstairs. In fact, we could represent this mechanism with a conditional statement. When the water level is, say, greater than 80 centimeters, then it should drain the water. But if the water level is not greater than 80 centimeters, it should continue filling up the tub. This type of conditional statement is known as an if-else statement. Depending on a particular condition, we would do either A or B. And when we want to write Python code to represent this, it looks something like this. There's the keyword if, and then the condition that we're testing for, and then a colon. And after the colon, we've got an indented block of code, which should be executed if this condition is met, if it's true. But if it's not true, then we will skip to the else block, and it's just the else keyword with a colon. And then this code block would execute if the condition is false. So we could represent that previous bathtub situation with code that looks a bit like this. Let's say our water level is at 50 centimeters, and then we would test if the water level is greater than 80 centimeters. Well, if that is the case, then we should drain the water. But if it's not greater than 80 centimeters, in other words, else, well, in this case, we should just continue filling up the bathtub. Let's put this into practice with a real life problem. Now, let's say that you've gotten a job at a theme park, and your first job of the day is to write some code that replaces the ticket box. Now, there's a couple of things that you'll need to think about. Firstly, in order for somebody to actually purchase a ticket to go on the roller coaster ride, they will need to be over 120 centimeters. So we have to check what their height is, because if they're too short, then we won't be able to sell them a ticket anyways. In the course resources, I've included a link to this flowchart that I've created on draw.io. This is a really, really useful tool for creating any sort of flowcharts or diagrams, and it's really easy to use. Now, if we take a look at this flowchart, this is basically the logic that we have to program using our if and else statements. If the person who's trying to purchase a ticket is not over 120 centimeters, then they can't ride on the roller coaster. But if their height is greater than 120 centimeters, then they can ride. So let's try it out. all that I've got here is a print statement that says welcome to the roller coaster, as well as an input asking the user for their height in centimeters, and then converting this string into a whole number, an integer. And then I'm storing it inside this variable called height. Now we're going to check whether if the height that the user has typed in is greater than 120. So we use the keyword if, and then we check if the height is greater than 120, and then we add the colon. And now when I hit enter, you'll notice that the code editor has automatically indented me slightly over. I'm not over here, because in Python, the spacing and indentation is really, really important. It tells the computer that the code that I'm about to write is what should be executed when this condition is met. So what should happen? If your height is over 120, then we will just print, you can ride the roller coaster. But what should we print if height is not greater than 120? Well, in this case, we would use the else statement to catch when that happens. And it's really important that you don't write the else here, because this is indented over. Instead, you want it to be at the same indentation level as the if statement. These two are essentially a pair, if and else. Now, after the else keyword, we again add a colon, and then we hit enter, and we're now indented again. And here we can write the code that should happen if this condition is false. Sorry, you have to grow taller before you can write. So the really important things here are the condition, which we're testing for, is the value of height greater than 120, the syntax of this code, so the keywords if and else, as well as the colons that come after each of these lines, and finally also the indentation. Everything that is indented after the if is a block of code. So this is indented and it's effectively inside this if. So this line of code lives inside the else statement. This block of code lives inside the if statement. And if you mess up on the indentation, then you're probably going to get an indentation error telling you that this line, 5, probably should be indented. But when we do actually correct it and we hit run, let's say that our height is 130 centimeters. Then we get back, you can ride the roller coaster. But if our height was, say, 90 centimeters, then we get a different outcome. We get, sorry, you have to grow taller before you can ride. So by using if and else statements, we're able to get our code to do different things, either printing this line or printing this line, depending on a condition that we're testing for. Now, when we use this greater than sign, effectively what we're saying is that is the height greater than 120, which means that it does not include 120. In fact, if I run this code and if I type in my height as 120, then it actually goes into the else block and prints this. So if we wanted to include 120 centimeters so that all the people who are exactly 120 centimeters can ride the roller coaster, then instead of just using a greater than symbol, we have to write greater than or equals. So these two symbols have to be next to each other. And now when I run my code and I write 120, you'll see that it's now falling into this block of code and it's telling me that I can ride the roller coaster. Now these are called comparison operators, and we've already seen greater than, so lesser than is pretty self-explanatory, but we've also seen greater than or equal to and lesser than or equal to. So if you want to include a particular number or a particular value, when you do these comparisons, you would be using these instead. Now in this table, there's also the equal to and not equal to. For example, if you wanted to check if somebody's height is equal to precisely 120, then you would use two equal signs. And very often it gets a little bit confusing, especially if you're new to programming, when you're typing equal signs, because sometimes we're typing 1 and other times we're typing 2. It's important to remember that when you have one equal sign, it means that you're assigning this value to this variable. But when you have two equal signs, you're checking to see if the value on the left is equal to the value on the right. And they're completely different. Now, the good thing is that when you get it wrong, usually you'll get enough clues in the error to actually hint to you, hey, maybe there's something that's wrong here, right? Because the syntax doesn't look right. For this to be a condition, it has to be something that evaluates to true or to false. And height equals 120 does not evaluate to either. So by changing it to this, we're saying if height is equal to 120, then we'll execute this line of code or any other lines which are in the same block of code. But if the height is not equal to 120, then we're going to execute this block of code. So if I write 120, then that works. But if I write 121, then it does not work. Similarly, you can also check for not equals to, which just flips it around. But in our case, it makes sense to say if the height is greater than or equals to 120, then you can ride the roller coaster, but otherwise you cannot ride the roller coaster. By using if and else statements, we can get our computer to do different things and respond differently depending on different conditions. So in the next lesson, I've got a coding exercise for you. I'll see you there. All right, in this lesson, we're going to learn about a new operator. So similar to the other mathematical operators and the conditional operators, an operator is just a symbol in programming that has a specific function. So what is the modulo operator? Well, it looks a bit like a percentage sign, but it's not just a percentage sign. Instead, it goes in between two numbers, so hence a binary operator, and it works out what is the remainder after the division. So 10 divided by 5 is equal to 2, and this division is clean because 5 goes into 10 two times, and there's no remainder. So therefore, 10 modulo 5, if we were to print this out, would give us the result of 0, no remainder in this division. So here's a challenge for you. What is 10 modulo 3? If 10 divided by 3 is 3.33333 recurring, because 10 does not divide cleanly into 3, what do you think would be the result of 10 modulo 3 on a computer? Pause and have a think about it. Okay, so let's go through the solution together. If 10 divided by 3 is equal to 3 with some decimal places, that means 10 does not divide cleanly into 3. 10 divided by 3 is equal to 3 with 1 as the remainder. So that means 10 modulo 3 is going to equal to 1, because all that the modulo does is it performs a division and then gives us how many is remaining after that division. So armed with that knowledge, you are now ready to tackle another coding challenge. And in this coding challenge, I want you to write some code to check whether the number inserted in the input area, so typed by a user, is odd or even. So you'll need to get hold of what they type in the input area, you'll need to convert it into an integer number, and then you'll need to use an if statement to check and see if you were to modulo that number, is it going to have a remainder? And remember that even numbers, when you use the modulo, so for example, let's take an even number, 12. If you use the modulo and you divide that number by 2, it's always going to be equal to 0, because any even number divided by 2 should divide cleanly. So if it divides cleanly with no remainder, then it is an even number. So have a think about this and see if you can complete this challenge. And then later on, in a minute, we will pause the video and then I will come back and explain the solution together. So give it a go now. Okay, so the first thing we need to do is to get hold of an input. Now, it doesn't matter what you ask. You could say, what is the number you want to check? And this is going to come out onto here. And then once the user types a number, that number needs to be stored and converted into an integer. So let's do the type conversion first, and then let's create a variable called number to check and set it equal to this right-hand side. So let's just confirm that that worked. Let's go ahead and hit run, type in a number, and it gets printed. So that's all working as expected. Now, the next thing we need to do is to actually check the number. So if we print the number to check modulo 2 to check if it's even, then we can try this out with some different inputs. So let's try 12. Modulo is 0. Now, what if we try a odd number? Let's try 3. Then we get modulo gives us an output of 1. So 3 modulo 2 has a remainder of 1, which means it's not even because it does not cleanly divide into 2. Let's try another odd number, 19. So you can see from this experiment or your knowledge of maths, whatever we take and we modulo it by 2, if it's equal to 0, if this result is equal to 0, then that means that this number is an even number. So instead of printing this, we can use an if statement. If number to check modulo 2 is equal to 0, colon. Now on a indented line of code, we can say print, well, this is obviously going to be an even number. And otherwise, so else, then we can print that this is an odd number. So let's just add one space here so that when I run this, my cursor just has one space beyond the question mark. Let's check some numbers. 45 is odd, which is true. 34 should be even. So this is reasonably simple, but it's also quite hard because it uses two things that you've learned and it combines them together. So hopefully you managed to get this to work and you managed to write the code yourself. If not, head back to your code and fix it so that it works after you have seen the solution. There's no shame in seeing the solution. It's all a part of the learning process. Don't worry if you didn't get it first time. There's a lot of things that I didn't get first time as well. But the important thing is you write down notes and you understand what is explained in the lessons so that you're ready to tackle the next challenge. In previous lessons, we learned about using the if and else statements to check whether if somebody is over 120 centimeters or not and allow them to actually purchase a ticket if they are over a certain height. Now, in addition to the height, there's another condition that we need to check for, namely their age. If somebody is over 18 years old, then they should be paying the adult price, which is, let's say, $12. But if they are 18 or under, then they should only be paying $7. So how can we represent this extra condition that we need to check for in our code? Well, we could use something called a nested if-else statement. We've seen our if-else statements look like this, where it's only got two choices. If this condition is true, do this, otherwise do that. But in a nested if statement, once the first condition has passed, we can check for another condition. And then we can have another if-else statement inside this if condition. In order for this thing to happen, this has to be true and this also has to be true. In order for this to happen, this condition has to be true, but this condition has to be false. So essentially, the computer first looks at the larger picture, which is this first condition, and decides on whether if it should go into the else block here, or if it should go into the nested block inside the if statement. So now this is what our flowchart looks like. In the first if statement, we check whether if their height is over 120 centimeters. If no, then the if statements all end. You can't ride, you can't buy a ticket. But if yes, we actually take them to yet another if statement where we check their age. If their age is 18 or under, then we give them a $7 ticket. If they're over 18, then they have to pay $12. So the place where we're going to nest our if statement is inside here. Notice how it's indented, so it's already inside this if block, and this already has to be true. Now here we're going to create another if and else statement, and the condition checks for their age. So we better ask them for an age. Let's say age equals, convert the input to an int, and what is your age? So now that we've gotten hold of their age, we can see if their age is less than or equal to 18, well, in this case, we're going to give them the $7 ticket. But else, namely, if this is not true, if their age is over 18, well, in that case, we're going to give them the $12 ticket. So now we have a nested if statement, because this if and else statement lives inside this if statement. So this condition will only be checked if this is already deemed to be true. Now let's say our situation got a little bit more complex. The boss comes over, checks our code, and says, wait, there's actually more price tiers than that. In fact, if you're less than 12 years old, you pay $5. If you're between 12 and 18, you pay $7. And if you're over 18, then you pay the full adult price, which is $12. Now, there are three possibilities. So how do we represent this in our if statement? Well, we could use something called the elif. Instead of having a simple if-else statement where there's only one condition, if it's true, do this, otherwise do that, you can add as many elif conditions as you want. So we can check for condition 1. If that's true, then do A. But if that's not true, then we can continue and check for condition 2. If condition 2 is true, well, then we can do B. And finally, if none of those conditions were true, we can do this final thing. Our flowchart now looks something like this. And this is the logic that we're trying to program. Once we're inside this nested if statement, we're going to check if their age is under 12, in which case they should pay $5. If they're between 12 and 18, then they should pay $7. And finally, if they're over 18, then they should pay $12. Now, the first thing I'm going to check is if the age is less than 12. Under this condition, they should pay $5. So let's change that to 5. Now the next condition should be created using an elif, which stands for else if. So it means if this is not true, else if, can you check if this is true? Well, in that case, then we should do this. For example, if the age is not less than 12, so they're over 12, then are they under 18? Well, then this condition basically catches everybody who's between 12 and 18. And finally, if they're not less than or equal to 18 and they're not less than 12, then that's everybody else who is over 18. Now, remember that we can use as many elif conditions between the if and else as we like. So I could add another elif that checks whether if the age is less than, say, 22. Well, in this case, do something else. And then I can keep going with these elifs until I'm done with all my conditions. So have a play around with this code, write it yourself, see if it makes sense, and then mess around with the elifs so that it does what you expect it to do. And then once you're ready, go ahead and head over to the next lesson where I've got a coding challenge for you. Now, in the last lesson, we saw how we could use if, elif, else to check for multiple conditions. But in this case, we're only checking one condition, even though we have multiple. Because if this first condition is true, then we would do whatever it is we need to do, and then we would bypass everything else. Now, what if you're in a situation where you need to check for multiple conditions, even if the previous one was already true? Coming back to our roller coaster ticketing problem, if you're going on a good roller coaster ride, you'd probably want to keep a picture for the memories, right? And our roller coaster is no exception. We want to be able to charge users an extra $3 if they want to purchase a ticket that includes a photo. Now, this is quite interesting because this is completely independent of their age or their height. Even if we've already gotten their age and height and determined their ticket price, this is an extra question. Do you want a photo or not? Yes or no? If you do, then we're going to add $3 to your existing ticket price. To do this, we would write multiple if conditions. If condition 1 is true, then do A, but then the code is going to go to the next case and check if condition 2 is also true, in which case it will do B, and if the final condition is also true, it's going to do C. Whereas on the example on the left here, only one of these things, A, B, or C, will be carried out. Comparing the example on the left, where we're using if, elif, else, only one of these things, A, B, or C, will be carried out. But on the right-hand side, all three conditions are checked. And if it so happens that all three conditions are true, then A, B, and C will all be executed. Currently, our code operates like this. We check for their height. If they're over 120 centimeters, we check their age. And depending on their age, we give them a different price ticket. What we now want is, even after we've checked for their ticket price, we want to ask them a question. Do you want photos with your ticket? And if the answer is yes, then we're going to add $3 to their bill, no matter which type of ticket they've got. And finally, we give them the total bill. If they say no, then we jump straight to the total bill and just tell them the price of their ticket. So how do we implement this in our code? Well, first, let's change these print statements. Instead of giving them the bill at each of these steps, I'm going to tell them which type of ticket they're eligible for. So the next thing to do is to ask them whether if they want a photo or not. So I'm going to need to use an input. But the question is, where do I put that? Now, the correct answer is that it has to be at the same indentation level as this if block. So you can imagine this whole thing with the if, elif, and else as sort of belonging together, because they all relate to one thing. What is their age and which type of ticket are they eligible for? Now, outside of that if statement, I'm going to create an input and ask the user, do you want a photo taken? Type Y for yes or N for no. And then I'm going to save their input inside a variable called wantsphoto. So now I'm going to use an if statement to check what their answer was. If it was true, then I'm going to add $3, and if it was false, I'm just going to skip to giving them their ticket price. So here is where I write my if statement. Notice how it's at the same indentation level as this previous set of if statements, but it's not at the same indentation level as this set of if statement. So essentially what's happening is, once I've checked their age, then I'm going to check whether if they want a photo or not. And this is going to apply to everybody, no matter their age. So if wantsphoto is equal to Y, well, in this case, I'm going to go and add $3 to their bill. But how can I add $3 to the bill when I don't have a variable to vary? So instead of using these print statements, I'm going to create a variable up here called bill, and I'm going to set it to equal 0. Now, in addition to printing to the user how much their ticket is, I'm going to set the bill to the price that they're supposed to pay. So if age is less than 12, bill is equal to 5. If age is less than 18, then bill is equal to 7. And finally, for everybody else, the bill is equal to 12. So now, depending on these conditions, the variable bill is going to be changed to a different number. But once we land in this if statement, I'm going to have to add $3 to their bill, no matter which value it is at the moment. So effectively, what I want to do is bill equals the current value of bill plus 3. So if bill was 7, then this new value of bill should be 10. If bill was 12, then it should now be 15. Now in Python, as well as many other languages, there's actually a slightly shorter way of writing this. When you want to increase the current value that's held in a variable and you want to save it back into the variable, you can simply write plus equals. So bill plus equals 3 is the same as bill equals bill plus 3. Now, no matter what the value of bill is before it reached this if statement, I'm still going to add $3 to it. Now, after this if statement is completed, I don't actually have to write a companion else statement, because in this case, if the answer is no, then we're simply going to do nothing. We're not going to do anything to the bill. Instead, I'm just going to skip ahead and print to the user their final bill. And I'm going to use fstrings to insert the value that the bill variable has into this print statement. Now, for your code to work, the indentation matters a huge deal, because the computer will think you want it to do different things depending on the indentation. So notice how this indentation shows that this bill plus 3 is to be executed when this condition is true. But this print statement is not indented to the same level. And effectively, it's going to happen after this if statement has been executed. So you can play around with indenting this print statement, unindenting it, and see what the difference is. But now I'm going to go ahead and run my code and try and get a ticket. So let's say that I am 21 years old. It tells me that adult tickets are $12. And then it asks me, do you want a photo taken? So yeah, I would love to have a photo taken. And it tells me that my final bill is 15. So I forgot a $sign here. But effectively, it's now added the $3 to the $12 because of this additional if statement. So if this concept is still a little bit confusing to you, then I want you to really study this flowchart and just look at the difference and visualize it. Because the if, elif, else statement is only ever going to be true in one of these arrows, right? You can't be less than 12 and 18 and over. And similarly, it doesn't make sense for you to have two different ticket prices. But with the want photos, this condition has to be asked no matter whichever branch they landed on. So it's completely separate from this if statement. And once you've had a look at this flowchart, then compare it against the code. And the way that the code works should be a lot more obvious. And once you're happy with the code and this concept, then I want you to head over to the next lesson where I've got a code challenge for you. So for all of that and more, I'll see you there.
Alright guys, in this lesson I have a small coding challenge for you. The goal is to create a Python pizza delivery program, and the program is going to automatically calculate the bill for the user based on a number of options. So the user is going to be asked 3 questions in the form of an input, and we can run through this program as it is just to see that in action.
So firstly, it says, welcome to Python Pizza Deliveries. What size pizza do you want? And I'm going to choose a large pizza. So it asks me S, M, or L. So L. Do you want pepperoni on your pizza? Yes, always. And then it asks, do you want extra cheese? I'll type N for no. So these are my inputs, which will get saved into these variables: size, pepperoni, and extra cheese. And what I want to happen is for us to be able to print out the final bill saying your final bill is this amount, and it should be $28 based on the pricing of Python Pizza. So you can see in the description box here, we've got all the prices for small, medium, large pizzas, as well as the modifiers. So if they want pepperoni on a small pizza, that's an extra $2. If they want pepperoni on a medium or large pizza, that's an extra $3. And finally, if they want extra cheese, that's $1 on top of their bill. So your goal is to use what you've learned about if statements, elif statements, else statements, nested if statements, multiple if statements, everything you've learned so far basically in today's lessons to be able to build this and get it to do what we expect it to do. So pause the video, have a think about how you might tackle this problem and work through each of the to-dos in order. Afterwards, come back and we'll go through the solution together. By the way, in this lesson, you can click on the check button once you think your code is doing what it's supposed to, and we'll run through the automatic test using various options that we've tried for size, pepperoni, and extra cheese to verify that your code works. So pause the video now. All right, so let's run through the solution together. The first thing we want to do is to work out how much they need to pay based on their size choice. So we've got all the prices here, and we're going to start off with a variable called bill that's going to start out at 0. And we're going to check the variable size. So if the size that they chose is equal to S, that means they wanted a small pizza. So then to the bill, we will simply add $15. Now at this point, because this is the very first if statement and we're simply setting the bill depending on the size that they chose, you might have done it differently. You might have done this. You might have said, let's set the bill to equal 15 instead of plus equals. Both of them work and both of them are acceptable solutions. Now I'm going to stick to using the plus equals because we're going to be using it a lot in this program. So hopefully you already understand that this is the same as saying plus 15 to the previous value of bill and set it to the new value. So the next thing we need to check is what if they chose a medium-sized pizza. So we're going to use elif and we're going to check the second condition. If size that they chose is equal to M, in this case we're going to add $20 to the bill. So we're going to say bill plus equals 20. And the final version, so the L, if they chose a large pizza, we need to set it to $25. Now, there's two options here. You might have done an else statement because we've already tackled S and M. The last one is just L. So we could simply set the bill is equal to plus equals 25. But you might have also added another elif statement. So again, both of these options work. We can say elif size equals L. Depends on what you want to choose, but both of these options will work just fine. Now, you might also want to add a final else statement if you are really careful, because what if they typed something wrong? What if they typed instead of S, M, and L, they typed some mumbo jumbo? Well, that would be tackled in the else statement, and you could print out you typed the wrong inputs just to catch that situation. Now I have a warning sign under my print statement, and it tells me that my indentation is not a multiple of 4. So just in case this happens to you, just make sure that every time you use an indent that you've got 4 spaces in there. So if I just add one more space and make sure that all of these are on the same indentation line, that warning goes away. So we're done with the first to do. We've worked out how much to add to the bill based on the user's size choice. The next thing to do is to figure out if they chose any pepperoni. So if pepperoni is equal to Y, then in that case, we need to add some money to their bill. But how much? Well, it depends on the size of their previous choice. So if they had a small pizza, it's $2. And if they had a large pizza, it's $3. So the easiest way to do this is to use a nested if statement. So inside the previous if statement, we've already checked to make sure that they chose Y for pepperoni, so yes to pepperoni. If we add another if statement here, this will only be checked if they already said they wanted pepperoni. So if the size is equal to S, then this is the case of a pepperoni on a small size pizza. So to the bill, we can add $2. Now else, so they chose yes to pepperoni, but they have a different size, then we can say the bill should add equal $3. And that solves the pepperoni problem with a nested if statement inside another if statement. So the final to do is to work out their final amount based on whether if they want extra cheese. So this is a situation where we have multiple if statements. So we have an if statement here that's being checked, we have an if statement here that's being checked, and finally we have an if statement that checks if they want extra cheese. So if this is equal to yes, then all we need to do is add the $1 to the bill, and that is all we need to do to complete this last addition. And now we can finally print out the value where we say your final bill is, and then colon, and then a $sign, and then we're going to use an F string to insert the amount for our bill right here. And finally, we need a full stop. Now, make sure that you've actually got everything written exactly as I have, because otherwise the checks are not going to pass. So now that I've made sure I've got all the right full stops and all the right wording, and hopefully my calculations are correct, I can now click on check. And if everything is correct, then it tells me, congratulations, everything's correct. So hopefully that wasn't too hard and you managed to figure it out by yourself. If not, this is the time to go back and fix your code based on what you've learned in the solutions. We all make mistakes and we all need help to figure out things. There is nothing wrong with learning from the solution walkthrough as long as you understand everything that's going on. So go ahead and do that if you need to. Otherwise, head over to the next lesson where we're going to learn about logical operators.
Now, up to this point, you've seen us use if statements, else statements, elif statements, multiple if statements, as well as nested if statements. But the thing that we haven't been able to do thus far is to check for multiple conditions in the same line of code. So how would we be able to combine different conditions and say, well, is the pizza large and the user wants pepperoni and extra cheese all in the same line of code? Well, to do this, we would need to learn about the logical operators. So there's 3 of them that are really useful: and, or, and not. So let's take a look at the first one. When you combine 2 different conditions using an and operator, they both have to be true, both A and B, for the entire line of code to be true. If just one of them is true, say A is true and B is false, or A is false and B is true, then the overall thing evaluates to false.
Now let's try out some of that in actual code. So let's go ahead and go into the Python console that you see right here. And here we can write Python code from scratch, so completely independent of everything else and independent of our code files.
So let's test out some Python code in here.
Let's say that a equals 12, right? Now, let's say that I wanted to check whether if is a greater than 15? Well, that is going to be false. Now, what about is a greater than 10? Well, that's going to be true. Now, if I combined this using an AND statement, I could say, well, is a greater than 10 and a is less than 13 and hit enter, then I would get true because both a is greater than 10 and a is less than 13 are true. So in this case, when both conditions are true, then this entire line gets evaluated to true. But see what happens when just one of them is false. So is a greater than 15 and a less than 13? A is greater than 15 is false, a is less than 13 is true, and now we get false. So that's what happens when you combine different conditions using AND.
So using the AND logical operator, it looks at two conditions and to see if they are both true. And if they are both true, it becomes true as the final outcome. But if either of these are false, so false and true becomes false, true and false also becomes false. And this is how the AND logical operator works.
Now, if you only needed one of the conditions to be true, then you could use the OR operator instead. So if C or D were true, or if they're both true, then it will evaluate to true. It's only when both C and D are false does this statement actually become false. Now, the final one is the NOT operator. And all that this does is it basically reverses a condition. So if the condition is false, then it becomes true. If it's true, then it becomes false.
So coming back to our code, we can refresh and restart the Python console and start with the same a equals 12. And we can use the OR statement by saying, well, is a greater than 10? That's true. Or is a less than 10, which is not true. So here we have a condition that is true and a condition that's not true, but because this time instead of using an AND, we have an OR between these two conditions, then this will actually evaluate to true. So in this case, using the OR, true or true will become true. True or false will become true. False or true becomes true, and it's only false or false when both of the conditions are false does it actually evaluate to false. So this is quite different from the AND operator. Now, finally, with the NOT operator, it only works when the condition that's being checked is false. So effectively, it flips the true to the false and false to true. Let me show you what I mean. So we know that a is 12. So is a less than 0? Well, it's not because it's 12. It's definitely not less than 0. But by putting the not in front of it, it reverses the condition. So a is less than 0. This will evaluate to false, but putting the not in front of it, it becomes true. So not false is true and not true is false.
Coming back to our roller coaster ticketing, let's say that the roller coaster company decided that for everybody who was having a midlife crisis, they would give them free tickets. And according to Wikipedia, midlife crises typically occur when you're 45 to 55 years old. Let's see if we can incorporate this into our code. So let's say that in addition to these existing price categories, what if you had to add a separate price category for those people who are aged between 45 and 55, and those people get to ride for free? Do you think you would be able to change the code using what you've learned about logical operators in order to incorporate this addition to our program? Pause the video and give that a go. So we've currently got 3 conditions: age less than 12, age between 12 and 18, and finally everybody else. Now, instead of just finishing up there, let's go ahead and add another elif. And here we're going to combine two conditions. We're going to say if the age is greater than or equal to 45 and the age is less than or equal to 55, then we get to catch that midlife crisis window. Well, in this case, we're going to print something like, we're going to say everything's going to be okay, have a free ride on us. And in fact, we don't need to modify the bill in any way because we know that with if, elif, and else statements is that once this condition matches, then everything that's inside this block, so everything that's indented inside this elif is going to be carried out, namely printing this out, and then it's going to skip the rest of this if-else block and continue on. Now, if they want a photo, they still have to pay $3, but at least their ticket is free. And we've been able to do this because we know about the AND logical operator. Now, for the keen-eyed amongst you, you might have noticed with this condition check, we have a warning underneath it. And this says that there's actually a simpler way of writing this expression. And it tells us that we can actually simplify it. Now, because we're checking two conditions and we have the AND logical operator in between, sometimes you might want to make this code less wordy. So if you hover over this warning and you click on Simplify Chain Comparison, it will give you a simpler way of doing this comparison using two of these checks either side of the age. And it does exactly the same thing, but in less words of code. But here is the big but. Looking at this, is this easier to understand and logic through versus this? Because to somebody who's just starting Python programming, I think this is easier to understand what's going on. Is age greater or equal to 45 and is age less than or equal to 55? So even though there is this warning in here, I'm going to leave it in this format because a lot of you are just starting out learning how to code, and this is a much easier way of reasoning about what's going on in this line of code. So the thing with warnings are that they're really helpful once you get going as a programmer, but in the learning stage, I wouldn't worry too much about all of it. Look at it, read it, see if you understand what it's trying to tell you, and then you decide which version you prefer. Hey, you've reached the final project. And as you've seen at the beginning of today's lessons, I showed you what we're going to be making, which is a sort of choose your own adventure game. I don't know if you've ever read those choose your own adventure books where you flip to a different page if you make a particular choice, and then the story kind of evolves as you make your choices. Now, we're going to make a very simple version of that using what we've learned about conditionals, if, else, elif statements, as well as everything we've done previously. So you've already seen what the final outcome should look like, and if you want to review it again, just head over to the link in the URL box or click in the course resources and it'll direct link you here. And here you'll see essentially the game in action. So it starts off asking you, you're at a crossroad, do you want to go left or right? And then you have to type your choice. If you selected left, then it's going to take you to a lake, and it asks you whether if you want to wait for a boat or swim across. So let's go ahead and wait for a boat. And then the final step is it asks you, which door would you like to go through, red, yellow, or blue? Now, depending on your choice, you'll either end up with game over or you'll end up with winning the game. So the basic setup for this game looks something like this. And I've included a link to the flowchart in the starting project right here. And of course, you'll find all the links in the course resources as always. Now, the first question you're going to ask the user is to make a choice between left and right. Now, you can use my wording if you want. You're at a crossroad. Where do you want to go? Type left or type right. But I think the fun part of this challenge is really creating your own story, right? But somehow get them to choose between left and right. If they choose right, or any other condition for that matter, tell them that they've lost, game over, for some sort of reason. In my case, if they had chosen right, the reason is because they fell into a hole, game over. But I think you're far more imaginative than I am, so go ahead and use all of those skills and make your game really fun. Now, if they've chosen left on the other hand, then we're going to take them to another question that asks them whether if they want to swim or whether if they want to wait for a boat. And if they swam, then it's going to be some form of game over. There's crocodiles, there's whatever it may be, but they can't continue. But if they chose wait, then we take them to the third and final question, which asks them to choose between 3 doors. And if they choose any door other than the yellow door, then they would lose. But if they chose the yellow door, then they somehow win. Now, notice how each of these just says game over, left or right. But, the idea is really to use your creativity and make this game really your own. Now, one thing to remember though is that when the user types in a answer, let's say left or right, they might type it like this with an uppercase R, or they might type it like this, all lowercase. Have a think about how you might make sure that no matter which version they typed, you're still going to be able to catch their command, essentially. So have a think about what you've learned in the previous lessons and take a look at this flowchart. Then head over to the starting project and you can get started writing your code. Now, ASCII-R is really cool because it basically just uses a bunch of characters that you know and love, like the comma and the equal sign and all of these things that together make up a picture. And you can find your own ASCII art if you just go to ascii.co.uk/art and you'll see a whole bunch of different topics and they've grouped a lot of things together into individual pages. So if you wanted a rhino ASCII art, then you can find a whole bunch of rhinos that people have drawn. But the easiest way is, of course, using Command F if you're on a Mac or Control F if you're on a Windows machine, and then just search for the thing that you want. So, for example, I went and searched for treasure, and down here I found this brilliant treasure box ASCII art, which is what I'm using to print inside this print statement. Now, notice how there's 3 single quotes that are at the start and there's 3 single quotes at the end. Basically, what the single quotes allow you to do is to create multiple lines of a string, essentially. So notice how if I go ahead and delete all of these single quotes and I only had a set of double quotes, then it actually doesn't quite work. It gets quite confused because it thinks that this is where the line ends, but in fact I wanted to print all of this out. So to do that, instead of using a double quote, I use 3 single quotes, and at the very bottom I tell it, well, this is the end of my multi-block string by using 3 single quotes as well. So have a go at running that and you should be able to see that in your console you get this little Treasure Island ASCII art being printed along with the 2 sentences that begin the game. So have a look at the flowchart, have a play around with the ASCII art, and also have a look at the final version of the app so that you can go ahead and create your own version to complete this challenge. Pause the video now and give that a go. Alright, so let's see if we can replicate the functionality or the logic that's shown in this diagram into our Treasure Island game. So the first thing it has to do is we have to ask the user whether if they want to turn left or right. And after we ask the user this question, we're going to want to capture their input, right? So let's go ahead and create an input function and ask our question. Now, notice how when I use my double quotes around my string, the double quotes that are inside the double quotes are interpreted as code because it actually thinks that this is the end of the first string, this is the second string, and this is the final string. This is how the computer is going to see it.
Now, there's a cool thing that we can do in Python when we have a string like this. We can enclose a string inside a set of double quotes, and let's say we have a string in here. Say the words, "She said hello." Now, if we want these double quotes to occur and to be viewed as a part of the text, one trick that we can do is, instead of using double quotes to enclose our string, we can actually use single quotes around it instead. And because now we have double quotes inside the single quotes, it will be interpreted as text. And you can see everything inside here is all green. Now, if we try to apply this trick to our input on this line here, there's one slight problem. So let me show you. I'm going to get rid of the final double quote of our string and the first double quote of our string. I'm going to highlight the entire string that I would like to be a part of the input prompt text, and I'm going to type the single quote button to wrap everything inside. Now, we've solved the problem with the double quotes, but we also have a single quote in our sentence. So now what the computer thinks you're trying to do is, here's a string, starting single quote, ending single quote. I've written a bunch of other code, and then I've got some other strings left and right. And at the end, I've somehow forgotten to close that quote. So how can we fix this? Well, a really simple thing is to simply use the / button, which is used as an escape symbol in programming. So what this says is, yes, this is a /, but if the / occurs in front of any other useful symbol, then it will mean that we're trying to escape this symbol. So don't interpret it as code. And instead, if we run our code, you'll see the input print out in its entirety. You're at a crossroad with the apostrophe. Where do you want to go? Type left or right. And it's exactly what we wanted to happen.
Now, of course, there's other ways that you could have gone around this. You could have just simply said you are at a crossroad rather than using the apostrophe. But more often than not, you'll need to use a symbol that you'll need to escape, and you can do that with the /. So that's just a quick tip. Now, at this point, the user is going to type a message left or right. So let's go ahead and save that to a variable. Let's call it choice1 equals their input. Now, remember how I said they could be typing the answer as right or as right. So how can we make sure that when we're doing our checks using the if statement, we ignore the casing? Well, one way of doing this is we can simply use the lower function to change their input. No matter how they wrote it, right, or right, it should all be converted into lowercase to this version. That way, we have one thing that we can consistently check for in our if statement, which is coming up next. So we can say if choice1 is equal to, remember the double equals is checking whether if left-hand side and right-hand side is equal, and the single equal sign is assigning the right-hand side to this particular variable name. Now, if choice1 equals the string right, then it's pretty much game over for our player. So let's go ahead and add our colon and print something like game over. Of course, we can elaborate this a little bit more as to why was it game over. Well, because you fell into a hole. This is like the E.T. game from the 80s. Lots of holes. So you fell into a hole, game over. But what if they had chosen left instead? Well, that takes them on to the next question. So that's the option that will allow them to continue along the game. Now, in this case, we could use an else statement and say, well, if they didn't choose right, then they probably chose left, right? But they could have also chosen like a option that was completely not listed. They could have just written something like this, and it would still trigger the else statement. So what we should actually do is to switch it around. So namely, we should say if choice1 is equal to left, well, in that case, then they continue in the game. But otherwise, namely if they chose right or anything else for that matter, then it's pretty much game over. So this format makes a lot more sense if you want to continue along the left side of the branch this way. Now, another thing that you might have realized because we learnt about combining different conditions is instead of using the dot lower to change the input to lowercase, you could have also said if choice is equal to left or if choice 1 is equal to left, spelled like this. That will both work. But I think in terms of succinctness and less code writing, I think this makes a lot more sense to me. So I'm going to continue with this version, but if you did it the other way, that's perfectly valid as well. Now, if their choice 1 was left, then they get taken to the next question. Do you want to swim or do you want to wait? So let's go ahead and continue the game and create another input. In this input, we're going to ask them a question and say, you've come to a lake. There is an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. Cool. So we've actually got the same problem as we had before, namely that this is being interpreted as code rather than as a continuous single string. So do you remember how we fixed this previously? And if you got stuck on this, I recommend having a go at this yourself before I show you the answer. Alright, so previously we said we were going to switch it to single quotes instead, so that these double quotes become interpreted as just normal strings. But of course we've got this you've. We could of course change it to you have instead of you've, but if we want to escape the string, we just add a backslash, which is exactly what we did previously. Now, one thing you might notice here is I'm getting a warning here saying PEP 8, so this is a style guidance, this line is too long. And you might have also felt a little bit annoyed having to scroll left and right constantly to be able to see the end of the line. So what can we do in this case? Well, we can actually very easily pick any point in our entirely long string and just hit enter, and it will automatically do the right thing and make it go on to the next line. Now, this doesn't actually change how it gets printed out, because if I go ahead and stop this and run this code again, you can see it's still typing everything on the same line. You're at a crossroad. Where do you want to go? Type left or right. It doesn't actually affect it at all. The only thing it does is it helps our code to be more readable. So we can go ahead and fix this one as well. So wherever you choose, just hit enter. I did it at the end of a sentence because that makes more sense, but you don't have to. You can actually even put it in the middle of a character if you really wanted to. Now here we're going to see a new warning, and it's basically unhappy with how our indentation looks for this separated second part of this string. So when you hover over some of these PEP 8 warnings, you can actually just click on this button for them to do whatever they think is best. You know, it's like, all right, you do it, you know, leave me alone and just fix it for me. So they fixed it for us, and as usual with AI and machines, it now looks like I have to scroll horizontally again. So let me just fix this so that I put each sentence on a new line so I can see everything in one go without having to scroll around. It's quite good for my sanity. Now, one thing you have to be really careful about is this indentation. Now, this indentation here doesn't really matter at all. It's just all for styling, and the computer was unhappy with having it unaligned with the start of the string, so that's why they asked us to fix it. But the thing that really matters is your code's indentation, because this choice 2, getting the input from the user for the second question, must be indented inside this if statement. because otherwise it's going to give you a indentation error. And this means that only when the choice for the first question was left do we actually prompt them for an input and let them continue the story. And then we get to check our choice 2. So if choice 2 is equal to wait, then it means that the game will continue. But else, so if they typed swim or anything else for that matter, then the game is going to end. So we're going to print and tell them that something terrible happened. You got attacked by an angry trout. Game over. Now we can continue along this path. So we're down to here now. And the final question we're going to ask the user is, which door do they want to choose? So here I'm going to use an input to send them the message that you arrive at the island unharmed. There is a house with 3 doors, 1 red, 1 yellow, 1 blue. Which color do you choose? Now I'm going to save their choice inside a variable called choice3, lowercase the answer that they provided, and finally I'm going to use if, elif, and else to check which one they chose. So if choice 3 is equal to red, elif, choice 3 is equal to yellow, elif, choice 3 is equal to blue. And then I've got a else. So here are 4 possible things that could happen. If they chose red, then I'm going to tell them that it's game over, but it's going to be some sort of creative version of game over. So maybe something like it's a room full of fire, game over. If they chose yellow, on the other hand, well, that's going to be the room where the treasure exists. So I'm going to print, you found the treasure, you win. If they chose blue, they also end up with game over, and I have to give them a different reason. Now, if you had decided that if they chose anything but yellow, the way that they're going to game over is the same. Say if you chose red, it's a room full of fire, game over. If you chose blue, it's a room full of fire, game over. Anything else, it's also going to be fire, game over. Well, then you could just use if and else. But if you wanted each choice or each door to have a different outcome for the user, say the red door has fire, the blue door has beasts, and if they chose the wrong door, then they're going to get something like, you chose a door that doesn't exist, game over. So can you see that depending on whether if you want to give the user a different print statement based on their choice, then you would use if, elif, else. But if you actually just wanted to give them the same feedback, which is game over, then you could just use if and else. Now let's run our game and just make sure that it works. So I'm going to go left because I know it continues, and then I'm going to wait for the boat, and that allows me to get to the final condition, and if I choose yellow, I know that I'll win. Now, if you want to change the formatting, because having the input at the end of the sentence doesn't look as good as letting the user type it on a new line, then you can simply, if you remember, just add the new line, which is \n, at the end of your inputs, like so. So how did you get on with this challenge? And if you didn't manage to do it right, or if you've done it right, go back and try and modify it. See if you can add some more conditions, or see if you can make the game over messages a little bit more interesting than what I've written. See if you can modify it and make it really your own. Have fun with that. And in the next lesson, I've got more exciting things coming up for you. So hopefully you've scheduled some time for tomorrow to complete the next day's lessons. But for now, it's good night from me.
Hey, I hope you had fun building the Treasure Island project. Now, remember that the most important thing when it comes to programming and learning this new skill is to really make the code your own. So with this project, really the sky's the limit. You can take your creativity and run with it. Make the story your own, change it up, change the game. Make it something that you imagine it to be. And I can't wait to play your game. So once you've created your own version, be sure to share it in the comments below so we can all play it and we can all admire your hard work. So have a go at that, and I'll see you tomorrow.
Hey guys, welcome back to 100 Days of Code. Today is day 4 and we're going to be focusing on randomization in Python, and we're going to be learning about Python lists. Now, randomization in any sort of programming language is really useful, because if we want to create a game, if we want our program to do something different each time, then we need to introduce a little bit of randomness, right? So we're going to be looking at using the random module in order to achieve this. And by the end of today, you will have learned enough to be able to build this rock, paper, scissors game. So it starts out asking you, the user, type 0 for rock, 1 for paper, or 2 for scissors. So I'm going to go for 0 for rock. And it shows me using ASCII art that this is what I chose, rock. And then the computer chose scissors, and rock beat scissors, so I win. Now you can run this as many times as you want. If I choose paper and the computer chooses rock, then I win. If I choose paper and the computer chooses paper, then it's a draw. But if I choose paper and the computer chooses scissors, then I lose. So this is a pretty simple game, but we're going to get the computer to play this game with us. And we're going to do that by learning about randomization, lists, and a whole lot more. I hope you're ready. And once you are, then head over to the next lesson and let's get started. One of the first things I want to talk about is randomization. And this is a concept that we're super familiar with. Randomization is really important when we want to create computer programs that have a degree of unpredictability. Now, the biggest category of that is, of course, games, right? Can you imagine if you had to play Tetris and every single time the block that fell down was like predictable? You always knew that it was going to be a T and then it was going to be an L. Like, there would be no fun in that, right? So how do we create this randomness for our programs? Now, in nature and in our everyday lives, it's really easy to create randomness. If you splash some paint on a canvas, that's going to be pretty random. If you take a look at the TV static from the analog TVs, that's also a whole bunch of randomness there. But when we're talking about computers, then these machines are what we would call deterministic. They will perform repeatable actions in a fully predictable way. So how do we wrangle these machines that operate basically on ones and zeros to get them to create some random numbers? Well, there's a whole bunch of maths that can be applied to create what are called pseudo-random number generators. And the one that Python uses is something called the Mersenne twister. And if you really want to read about it, then you can have a look on Wikipedia and take a look under the algorithmic detail. But to be honest, it's a little bit too much information for anybody, unless you're really interested in these types of number generators. But what I recommend, though, is a free video from the Khan Academy where they explain pseudo-random number generators. And it's really well produced, and it tells you a lot of different aspects of pseudo-random number generation. So have a look at that if you're interested to learn a little bit more about pseudo-random number generators. We've talked a lot about randomness, but let's see it in action. Let's write some code and produce some random numbers. We know that we want to get hold of some random numbers, but we don't really want to implement the Mersenne twister ourselves because it's horrendously complicated, using lots and lots of maths, and probably it'll take us months to write the code for. So how can we get random numbers? If you think about it, it's a little bit like searching for something in Google. The Google algorithm is horrendously complicated, and it's taken them years and years to refine and perfect to such an extent where I think Google knows me better than myself, because when I search for something, it always gives me the most relevant results. And if you're questioning the complexity of the Google algorithm, just go to Bing and try searching for something and see how relevant the results are. So they have this super complex algorithm, which we're never going to get a chance to see, let alone understand. And yet, every day we're able to search things on Google, and use this Google algorithm to get the things that we want, like the airspeed velocity of a laden swallow. Now we can do the same thing when we want to generate random numbers. Because this is such frequently needed functionality, the Python team have already created a random module. And you can get a direct link to this documentation just by clicking on the link in the description box here. And you can see that it contains a whole bunch of functions that you can use that allows you to generate random integers, so random whole numbers or random floating point numbers. So let's see how we can tap into this random module. We first have to import it. So we write import random. And now we're able to use this random module in our Python code. So we can look into the documentation to figure out how we can generate random whole numbers, so random integers, using this random module from Python. So if you scroll down on this documentation file and you go to the section functions for integers, then you can see a whole bunch of different things that we can do to generate random whole numbers. Now, the one that we're going to look into is random.randint. And this is going to generate a random integer between A and B. And these are the numbers that we have to provide to set that range. So the way that randint works is that it will generate a random number that is greater than or equal to A and less than or equal to B. So basically between this range A and B that we provide, but inclusive of both A and B. So let's give it a go. If we go into our code file and we use the random module, so we first write random. This refers to this module that we just imported, which contains all the code for generating random numbers. And then we write a full stop, which in programming is normally called a dot. So random dot, and then we're going to use the name of that function that we found, randint. So this randint needs some open parentheses. And you can see from the code hints, it's asking us for A, which is an integer, and B, which is an integer. And we already know this is the range that we want. So let's go ahead and give it a range. And I want a random whole number between 1 and 10. So in this case, I've got 1 as the first starting value. So it's going to give me a random number that could include 1. And then it goes up to 10 and including 10. So it means that we will get random numbers between 1 and 10. So let's go ahead and save this into a variable, which we'll call random integer. And now I'm going to print this random integer. And every single time I run it, you'll notice that I'll get a different number, or maybe sometimes the same, but it's a random number between the range that I've specified. Now, I've mentioned that the random module is a Python module. So what exactly is a module? Well, you've seen that we've mostly been writing our code all on the same page in a sort of script style, right? And everything just kind of gets executed from top to bottom. But sometimes your code will get so long because you're trying to create something complicated, and it's no longer possible to understand what's going on in such a large piece of code. What people will do in that case is to split the code up into individual modules, where each module is responsible for a different bit of functionality of your program. And if you have a complex project with many, many modules, then you could have collaboration on your project, right? Lots of people could be working on it, each person working on a different thing. Say if a factory was building a car, it wouldn't make sense for one person to build the entire car, from wheels to axles to the chassis. That's crazy. Instead, you have different people working on different modules, like the tire module, or the chassis module, or the engine module. And then once they put everything together, you end up with the final car, or in our case, the final program. So we know that the random module is a module that the Python team created to make it easier for us to generate our random numbers without needing to get into the complexities of all of the math that's required to generate pseudo-random numbers. But how can we create our own modules, and how do modules work anyways? Well, it's actually very simple. If you open up the file inspector over here and you go into today's task, random module, and you right click on it, you can go into new, and we're going to create a new Python file. Now we're going to create our Python file and call it my module so that I can show you how to create your very own module. Now let's say inside my module, I decide to create a variable called my favorite number, and it happens to be 3.1415. Now, if I want to use this number that I've created in my module, all I have to do is to go back into the task.py, which is the main entry point, at least in this course format. And normally when you're writing code in Python, it might be called something like main.py or app.py, but either way, there's usually a primary file that you use where you write most of your starting and core code. Now, if I want to use the code in my module, all I have to do is, same as the random module, I have to import it. So I'll import my module into this task.py file. And then I can use it by simply printing, for example, my module dot my favorite number. And you can see it's exactly the same way as the random module. We imported it and then we used a function inside it called randint. And now if I go ahead and print, you can see the my favorite number is printed by using and tapping into this module. Now, coming back to our main task of generating random numbers, let's take a look how we can generate random floating point numbers. So I'm going to go ahead and delete my module and all the related code. You can keep yours if you want, just for revision, but I want to keep everything as clean as possible. So I'm also going to comment out this section where we've got the random integer as well. So how do we create random floating point numbers? Well, let's take a look at the documentation. If you scroll down to this area called real valued distributions, you can see that one way of generating random floating point numbers is using the random.random function. And this is one of the core functions that we use a lot when we're dealing with random numbers in Python, because it is one of the most adaptive functions. It generates a random floating point number between 0 and 1. Now, if you look at these symbols, you'll see that the random number that's generated can be greater or equal to 0. So that means 0 is included in the possibility, but it is less than 1. So 1 is not in the generated random numbers. Now, let's try that out. So we will create a random number 0 to 1. And this is going to be set to random.random. And notice that it's actually exactly the same, spelt the same casing. But the first one refers to the module, and when you hover over it, it should show you it's the module random. And the second one refers to the function random. And this is something that doesn't take any inputs, and all you need to do is to add an empty set of parentheses to activate it. When we're looking at functions such as the randint, we always see a set of parentheses, and it's been used to put in inputs like what to print, or what is the prompt for input, or what is the range for a random integer. But remember that some functions don't take any inputs at all, but they still need the set of parentheses in order to carry out the action that the function is supposed to perform. So let's go ahead and print this new random number 0 to 1. And you'll see that every time I press the print button, it generates a new floating point number, and it's between 0 inclusive and up to 1 not inclusive. So you can use this random number generator, random.random, to expand it. So what do I mean by that? If we multiply this by 10, then you'll see that the numbers that are generated are going to be between 0 to 10 and not inclusive of 10, because we're basically multiplying the lower range 0 by 10, which is 0, and the upper range by 10. 1 times 10 is 10. So then we've shifted this random number generator to create floating point numbers between 0 and whatever it is that we desire. So you can have a play around with that, but you might also discover another function if you look through the documentation, which is a random floating point number generator. So I'm going to call this variable random float, and I'm going to use the random.uniform function. And this function will return a random floating point number such that the number is greater than or equal to the lower bound and less than or equal to the upper bound. So basically, it's going to generate numbers between A and B, inclusive of A and B. So to use that, we would say random.uniform, and then we can provide a number, say 1 to 10 again, and then let's print this random float, and let me comment out the other part. And now when I run this, you can see it almost does the same thing. The only difference is it's not entirely sure, depending on rounding, whether if you will get 10 or not in the random float. But if you want to be really sure of the range, so this is known as a semi-open range, where you have random.random that always includes 0, but may never include 1. And you can multiply it and do whatever you like with it reliably, knowing that. But because this one can vary depending on the rounding of the upper bound, then you may get the upper bound, you may not. So these are all really minute differences. I recommend to use random.random if you can and you understand how it works to extend the range. Now it's time to do some practice and see what you can actually do with random numbers. And I want you to create a heads or tail program. So the idea is that you should be able to comment out all the existing code if you have any, or delete it if you wish. And you're going to create a program that either prints out heads or it prints out tails. And whether if it prints out heads or tails will entirely depend on a random number that you generate. So think about how you can do that, pause the video and give this a go. All right, so how do we do this? Well, we need some conditions, right? We need to know that we can generate two random numbers. One will represent heads and one will represent tails. Now, if we want the numbers to occur at the same rate, then we could, for example, generate a random number that is either 1 or 0. So how can we do that? Well, we can use this randint function that we learned earlier. So making sure that we've already got import random written up here, and don't worry if it goes gray, it does that because it's not being used. We can now use it, and you can see it turns into normal syntax highlighting color. And then we can say random.randint, and we want a random number between 0 and 1. So therefore we're going to get 0 or we're going to get 1. And we're going to set this to equal our random heads or tails. Now you can of course call this whatever it is you wish, but essentially what we have here is a random number that is either 1 or 0, and we can verify this just by running this a few times, and you can see it's 1 or it's 0. So now instead of printing it out, let's use an if statement and check if the random heads or tails is equal to 0,
Well, in that case, let's go ahead and print heads, but otherwise, the only other option is tails. So let's go ahead and put print tails into the else statement. So when it's 0, it's going to print heads. For any other situation, which is only 1, then it's going to print tails. So now let's hit run. You can see we have now a random coin toss. So because it's random, you might see the same thing occur lots of times, but hopefully over 100 times, you will see it's roughly a 50-50 split. So I hope you had fun creating this program using your newfound knowledge. And once you're ready, head over to the next lesson and we'll continue the day's lessons. Hey guys, today I want to talk about something that is really, really important and you're going to use many, many times in the future. And this is the concept of the Python list. And the list is what you would call a data structure. What does that mean? Well, it's just a way of organizing and storing data in Python. Now, we've already seen ways of storing single pieces of data, and that was done through the simple variable, where we just said A is equal to 3 or B is equal to hello, but that's just storing one piece of data, right? Be it a number or a string. But sometimes you might want to store grouped pieces of data that has some sort of connection with each other. For example, if you wanted to store all of the names of the states in the US, then it doesn't really make sense to store them all individually because they kind of belong together, right? They have a relationship to each other. So it would be nice if you had a variable that was called states in the US, and then you would be able to store all of the names of the states together in one variable. Now, in other cases, you might also want to have order in your data. So, for example, if you were storing all of the people in a virtual queue, then you want to be able to keep hold of the order in which they join the queue. You don't want to let the last person somehow skip the queue because you don't have a good data structure, right? This is why we need to learn about lists. And lists look pretty simple. It's just a set of square brackets with many items stored inside. And those items can be any data type. They can even have mixed data types, like you could store strings together with numbers or a set of booleans. It doesn't really matter. But what does matter is the syntax. In Python, lists always start with an open square bracket like this and a closing square bracket like this. And then in between, you have your items separated by a comma. So pretty simple. In order to store it inside a variable, then it's the same way as we've done before. The only difference is the right-hand side of the equal sign. This is the list data structure. If we stored a bunch of fruits, for example, then it might look something like this. Cherry, apple, pear, separated by a comma inside a set of square brackets. Let's take a look at this using real code. Now, let's say that I wanted to store all of the names of the states of the US. Previously, without knowing about this list data structure, we might have written state 1 equals Delaware, state 2 equals Pennsylvania, and so on and so forth. And we would create as many variables as we have states. But now that we know about lists, then we can just create a single variable and we call it states of America. And now we can create a list by creating a set of square brackets. And inside those square brackets, we add our items. So again, the first item is the state of Delaware, which is going to be a string. And then we've got Pennsylvania, etc., etc. And we can continue this list just by adding commas, adding a piece of data, adding another comma, adding a piece of data, and this way we end up with a list data structure. Now, one of the interesting things about the United States is that the different states in the US actually joined the Union at different times. You can actually head over to Wikipedia and watch this little animation and see each state join the Union and at which time point they did so. The order of this data is now kind of pretty important because if we wanted a list of US states,
that are in the order that they joined the union, then the order in which they're stored in our data structure is now also immensely important. And this is another thing that you get with lists. You can use a list to store many pieces of related data, but they also have an order, and the order is determined by the order in the list. So this is the first piece of data, this is the second piece of data, and when you store it inside the variable, that order is not lost, and you'll be able to use it later on when you need the list. Here's a list of states of America ordered by the date that they joined the union. And you can see that if later on I decided that I wanted to know which was the state that joined first, then I can print this variable, states of America. I can add a set of square brackets, and then I type 0 as the index of the piece of data I want to pull out from my States of America list. So now if I go ahead and run this code, you can see it prints out Delaware. And if I keep increasing this number, you can see that it's going through my list in the order that it was saved. So you might be wondering, that's kind of weird that you typed 0 and you got Delaware, right? Surely Delaware should be the first item in the list. Well, this is a kind of peculiarity with computers and programming languages. You'll tend to find that programmers start counting from 0. So Delaware is at 0, Pennsylvania is at 1, New Jersey's at 2. And this idea might seem a little bit weird at first. Why is the first item at position 0? But if you think about that index number, that 0, 1, or 2, instead of being the position, actually being an offset or a shift from the start of the list. Well, then in this case, Cherry is right at the beginning of the list, so it has a offset or a shift of 0, but Apple is shifted from the beginning by 1, Pear is shifted from the beginning by 2, and so on and so forth. Then it kind of makes more sense that the first item in the list is at the beginning of the list, so it has no offset, so it's 0. And you'll find that in many programming languages, there are similar data structures to lists, and this is how they're usually ordered, starting from 0 and then adding by 1. Now you can see that when you want to get hold of a particular piece of data stored inside a list, what you do is you get the name of the list, and then you add another set of square brackets. So whenever you see square brackets, you should be thinking to yourself, oh, this might be related to a list. Because when you create the list, you use square brackets. And when you try to get items out of the list, you also use square brackets. And then inside the square brackets is where you put the index or the offset of the item that you want. So if we want a New Jersey, it's offset from the beginning by 1, 2. So now this part of the code is equal to New Jersey. Now, in addition to using the positive index, so say 0, 1, 2, 3, you can also use a negative index. So if I wrote -1 or -2, then it actually starts counting from the end of the list. So if I wrote States of America, square brackets, -1 as the index, then I get Hawaii. -1 is the last item in the list, because you can't really have -0. That's not actually a real thing in maths. Now, as I continue and I go to -2, then that's Alaska, -3 will be Arizona, and so on and so forth. So you can have positive indices and negative indices. But so far, we've only been pulling things out of our list by using our square brackets and the index. But you can also change the items in the list using very similar code. For example, if I decided that Pennsylvania is actually not spelled Pennsylvania, and I wanted to change it to Pennsylvania, then I can simply write my code like this. I get hold of my list, and then using the square brackets, I get hold of the item at index 1, which is this one. And then I set it equal to a new piece of data. So now if I go ahead and print my States of America list, you'll see that the list looks a little bit different now. Instead of Pennsylvania, it's now Pennsylvania. So you can alter any item inside the list pretty easily using this kind of syntax. You could also add to the list if you wanted to. So for example, if you wanted to add an item at the end of the list, which is what happens most commonly, right? If you had a list of people who are queuing in your shop, then every subsequent person usually gets added to the end. If you have a new state that joined America, then it's probably going to be added after Hawaii. How do we do that? Well, we can write the name of the list, and then we use a function called append. And append will add a single item to the end of the list. So let's say that Angela Land is joining the United States of America. So now, once I've appended Angela Land to the end of my States of America list, and I print the States of America, you can see there it is added right at the end. Now, there's actually a whole load of other functions that you can use in addition to append, and you'll find this on the documentation for Python. In addition to the append function that we saw just now, where we add an item to the end of the list, there's a whole load of other functions that you can use with lists. For example, you can use the extend, which adds a whole bunch of items to the end of the list. And in this case, what you're actually adding is going to be a list. So I would be creating the list using square brackets and then adding my items in here. And now what's happening is I'm extending this States of America list with this additional list. So now if we print the States of America, you can see that these two items that used to be inside a list have now been added to the previous list, and it's now extended it by two more items. But the important thing is you don't have to memorize these functions. That's the whole point of documentation and why we have Google, because there's too much information in the world for you to memorize, and it's a very inefficient way of learning. And if you tried to memorize every single method, it's not impossible, but it means that you don't have space in your brain for the important stuff, which is how things work. How do you actually use it to do what you want it to do? So what I recommend when you come across a new thing, such as the list data structure, is to just have a look through the documentation, read through it, and see what are the possible things you can do. And once you've got the idea of this is possible, then the next time when you need to use it inside your code, you'll know, I remember, this is possible. And all you have to do is just be able to use Google to find the exact bit of the documentation and then implement it. Programming is kind of like an open book exam. You shouldn't need to memorize anything. You should spend your time trying things out and try to get things to work instead. Now that I've introduced you to this new data structure, the mighty list, it's time for a code exercise to see if you can use it in practice. So head over to the next lesson and give the challenge a go. So the code challenge that you're about to do comes from a really interesting phenomenon that you might find in London. I live in London, and it's well known as a big financial district. So when you head over to the city or the financial area in London and you go into a restaurant, you might see a strange thing happen. You might see a whole bunch of people in suits who look very much like the financial banker types. At the time when they actually need to pay the bill, you see everybody pull out their business cards and put it into a bowl. So what's actually going on here? A friend of mine told me apparently there's this game that the rich banker types play where it's kind of like Russian roulette with the bill. So everybody puts their business card in, and the person's card who gets picked out has to pay for everybody's bill, which is kind of crazy, but then again, it's finance.
Finance. Trust fund. 6'5", blue eyes.
But you know what? We don't need anybody in finance because we are programmers and we can do everything they can do just by writing code. So here's the challenge. You are to look through this friends list
and you're going to write some code using what you've learned about randomization in Python and also lists in Python to be able to print out a random one of these names. So each time you run the code, it will print out a different name. So if I run the solution file, you can see that each time it prints out a different random name from this list of friends. So think about how you might solve this challenge. You can look through the list of hints in the description box here, but think back to what you've learned in today's lessons and see if you can solve this challenge. Pause the video now. All right, so what we want to do is to be able to tap into this list and get hold of a random item. Now, there's two ways of doing this, and it depends on which path you went down. So let's go through the first way, which is maybe you thought, let's go through the documentation. So if you look through the random documentation, which we saw earlier in today's lessons, you might scroll through all of this and think, there must be a way that Python has created for us to be able to randomly get items from lists. Now, it's not easy to find, but there is one. It's random.choice. Now, another way you might have arrived at this is simply using the Google search and saying, get random item from list and then adding the word Python at the end. And you might look through Stack Overflow and you might come across the same function. Then you can go in the documentation and see how it works and read about it. So this is probably the simplest way to do it. And we can simply print random. Now, in order to use this module, you can see we need to use the import statement. Otherwise, it doesn't know what random is. So let's import random first. And you can see that error goes away. And then within the random module, I'm going to use the choice function. And this function takes as its input a sequence. Now, the list is one such type of sequences in Python, and there are others which we will learn about in later lessons. But this is all that it takes to go ahead and pick out a random name from this list. Now, this is option number 1. And this is something that you might have thought of based on, thinking about documentation and thinking about how we can find out things from the internet. And this is a really, really key skill of programmers. But the other key skill is figuring out how to do something based on what we already know how to do. So the second option is to use what we already know, which is we know that we can use random.randint to get a random integer, and we can set the range of random numbers. So we know that lists start counting from 0, so Alice is at index 0. So we would need random numbers between 0, 1, 2, 3, and 4. So if we do randint 0, 4, then we will get a random number anywhere between 0 and 4, including 0 and 4. Now, if this is our random index, then we can use this random index to print out a random name from the friends list. So remember, we can tap into a list, add a set of square brackets, and then put in an index to fetch an item from that list. So if I go ahead and run this file, you'll see that the first name comes from the first random.choice, and the second one comes from using the random index. And you can see that they're both random and they both go through our list and they both do exactly the same function. And if you picked option 1 or if you picked option 2, it's totally the same. It's up to you how you decided to complete this challenge. Both ways are equally valid. Now, in reality, if you know that there is something called random.choice, you would probably go for this because it's less code and it's pretty readable, random choice from this list. But the second option is also equally valid. So if you didn't manage to complete the challenge, or if you had any bugs in your code, go back and fix that now. Otherwise, I'll see you in the next lesson. Now, when you're working with lists, one of the most common errors you'll come across is something called the index out of range error. In fact, by this point, you might have already seen it. Now, what does it mean though? Well, let's take our states of America. And you might remember that there are 50 states in America, but if you don't, because you're a programmer, it's as easy as writing len and then passing over the states of America, which will print 50. So now that we know that there are a total of 50 items in this list, and remember, because we start counting from 0, Hawaii is actually at index 49. So if we print States of America and then we try to get the item at 49, we hit print, you'll see that we get Hawaii printed. Now, what if we went one beyond that? What if we tried to get the one at index 50? What do we get instead? Well, we get an error. It's called an index error. And this is because it's beyond Hawaii and there's nothing there, as we can see with our own eyes. But when you're working with large lists and you're not always looking at the data, then these errors can be a little bit more confusing. Very frequently, when you're working with lists, you'll end up with an off by 1 error. So it's unusual that you'll try to get something at index number 90 because that's just way beyond your list size. But very frequently, you might end up in a situation where you have some sort of value, say number of states equals len, and then we pass over the states of America. So this is going to be equal to 50. And then we pass that inside here as the index num of states, and then we hit run, and we get the same error, right, in this list. It's again, list index out of range. And this is an off by 1 error because all we need to do is just simply -1 so that 1 becomes 0 and 50 becomes 49. And then we get rid of that error. Now, it might be easier if we work with something a little bit simpler. Recently, I was reading online and I came across the so-called dirty dozen, where the environmental working group, a bunch of people, crunched through a whole lot of data, probably using Python, and they released their dirty dozen, a list of the fruits and vegetables that have the most pesticides. And it's kind of crazy that they actually washed and peeled all of these foods and then tested them for pesticides. And the list looks something like this, where strawberries are apparently one of the worst offenders for pesticides. So let's create a list of the dirty dozen. But you'll notice that some of these are fruits like strawberries, apples, and other ones are vegetables. So how can we use our lists to still keep them inside the same sort of container, the dirty dozen, but somehow separate them out into fruits and vegetables? Well, we could just simply create 2 lists, fruits and vegetables. But these 2 lists kind of have a relationship, right? They're kind of related because they're all on the list of high pesticide foods. So how can we have lists within a list? Well, that's what's called a nested list. Instead of our original dirty dozen, we could create a new list called dirty dozen, and we set it equal to a list that contains 2 lists. It contains fruits and it contains vegetables. So now what effectively has happened is we've inserted this list inside here, and then we've inserted this list inside here. So we now have a list that contains 2 lists. And if I go ahead and print out this list, you'll be able to see its structure. And it looks like this. You'll notice that there's 2 brackets at the beginning and at the end. And the reason is because this is one list, this is another list, and this is also a list. So this is yet another way of using lists and just showing you the flexibility of this particular data structure. It's something that you're going to use a lot when you're writing Python code. Alright guys, so now that we've loaded up all the knowledge that we need into our brains, it's time to tackle the final project of the day. And as I showed you in the beginning of the day, it's a rock, paper, scissors game that we can play with the computer. So the game starts out by asking you to type 0 for rock, 1 for paper, or 2 for scissors. So let's go ahead and type 2 for scissors. And then it's going to show you a graphic of your choice, scissors, and then the choice the computer made, which is rock. And of course, rock beats scissors, so you lose. What this game boils down to is some way of randomly making a choice between rock, paper, or scissors, and then comparing that choice that the computer randomly generated against your choice, and then based on the rules of rock, paper, and scissors, determining whether if you won, you lost, or whether if you had a draw. While I was looking around, I actually came across the World Rock, Paper, Scissors Association. And they have the official rules listed of rock, paper, and scissors. If you're not familiar with this game, it might be worth checking out this website. Here are the 3 shapes of rock, paper, and scissors. And then the rules are that rock wins against scissors, scissors wins against paper, and paper wins against rock. Now, you'll notice that in the starting project, I've already got the ASCII art for rock, paper, and scissors in here, and they're each saved to a variable. So what that means is that you can start out by just having a go at printing out, let's say, rock. And remember that these are variable names. They're not strings, so they don't need the double quotes around them. So let's run that, and you can see what we get printed is the particular ASCII art that I chose in my print statement. So this is already yours, but as you'll notice, there's no other logic that I've provided you. And you are going to rely on what you learned in the previous days, and most importantly, what you've learned in today's lessons to be able to complete this challenge. And it's worth comparing the outcome against the game of rock, paper, scissors that I'll link to. There's a couple of things to think about, namely, how are you going to decide who won or who lost? How are you going to get the computer to choose a random shape, rock, paper, or scissors? And how you actually get this game to work in the same way that is demoed in this final version. I'm going to go quiet now, and I'm going to let you pause the video, and I want you to spend at least 10 or 15 minutes working on this. And if you get stuck, just try some things out, or maybe watch some of the previous videos in the day and just try to give it your best go and do a lot of struggling. Hopefully you're going to succeed, and once you're done, head back over here and I'll go through the solution with you. So pause the video now. Alright, so we know that we've got all of this ASCII art, but for the moment, I'm just going to start off by pinning down the basic logic of this game. And it's really helpful for you as well if you start thinking about breaking down the larger problem, which is making the rock, paper, scissors game, into smaller problems that you can solve, like generating a random number between 1 and 3. So we have some sort of proxy for rock, paper, and scissors. And then maybe thinking about putting down the logic. Well, if the computer chose scissors and I chose paper, then I'm going to lose. Or if the computer chose rock and I chose paper, then I'm going to win. And putting that down on a flowchart using draw.io or something like that can make this challenge a lot easier as well. But without further ado, the first thing I need to do is to produce a user choice. Now, this is going to be the one that the user chose when they typed in a value. And in order to get the value from them, I'm going to need to use a input. And inside the input, I'm going to put the following prompt, asking the user, what do you choose? Type 0 for rock, 1 for paper, or 2 for scissors. Now, once I get hold of this input, hopefully, if the user is following my instructions, they're going to type some sort of number, either 0 or 1 or 2. Now that I've gotten hold of what the user wants to choose, the next thing to do is figure out what the computer is going to choose. So I'm going to make another variable called computer choice, and I'm going to generate a random number. So to do that, remember we have to import the random module, and then we can start using it to generate random whole numbers by using random.randint, and then the range is going to be between 0 and 2. Because this is what I asked the user to do. Type 0 for rock, 1 for paper, 2 for scissors. So the computer is also going to choose between 0, 1, or 2. Now that I've got the computer choice, I'm actually going to just print it out for now. Instead of printing out the actual shape, I'm just going to print out the number. So computer chose, and then let's go ahead and add a f string. And of course that requires the F in front of the string. So now if we just play the game as it is, remember that testing your app while you're developing it is really, really good practice. It picks up on the bugs that you make along the way, instead of waiting until the end when you've done everything and then it doesn't work and you have to untangle all of the lines of code. At this point, I've already realized that it's actually not so great getting the user to type on this line. What I would much rather is to start a new line for them to type their answer on. So if I run the code again, then it should look a bit like this. My prompt is now here. So I'm going to choose 0 for rock, and then it tells me that computer also chose 0. So in this case, this would be a draw. But if I play this game again, you can see that the computer is probably going to choose something different. So I chose rock again, the computer chose 1, which is paper. So now we can start thinking about how do we compare these two choices and how can we define the logic of rock, paper, scissors. So I know that paper beats rock, scissors beats paper, and rock will beat scissors. So if 0 is rock, 1 is paper, and 2 is scissors, then 2 beats 1 and 1 beats 0. So that's very simple for us to check in terms of using if statements, right? We could simply just check, well, if the computer choice is greater than the user choice, well, then this probably means that the computer wins. But this is not true in all cases, right? Because if the computer chose 2 for scissors and the user chose 0 for rock, then the user should win rather than the computer winning. So we actually have some exceptions to this rule. How can we catch the exceptions before we go down to this level of generalization? Well, we could, instead of using this as an if, we use this as an elif, and we create another if statement which says, well, if the user choice is equal to 0, so if the user chose rock and the computer choice was 2, well then this means that in this case the user actually wins. Now if we're thinking from the perspective of the user when they're playing this game, then they don't really care if the computer won or the user won. They want to know, did they win or did they lose? So let's change this wording a little bit. We'll say, instead of user wins, we'll say you win. And if the computer wins, then we'll say you lose. So now if we run our program and test it out, so let's say I'm going to type 0 for rock, but we actually get an error. It tells us that the greater than comparison is not supported between instances of int and string. What's going on here? Well, remember that we get our inputs as a number, but the input is always going to be a string. So we want this to be a number, then we're going to have to wrap it inside an int. So now we turn it into a whole number. Now, this might be a good point to address, well, what should happen if they typed something that wasn't 0, 1, or 2? What if they typed 34? Well, then naturally they should probably lose, right? So we can add an else statement addressing this situation. So we could say else, we just print you typed an invalid number, you lose. Cool, so that sorts that out. now let's run our code again and see if it works. What do you choose? Type 0 for rock. I'm going to choose rock again. Computer chose 0, and it tells me that you typed an invalid number. Well, actually, 0 is not an invalid number. So what's going on here? Well, it's because it didn't fit this criteria. So I had 0, computer had 0, and it didn't fit this criteria because 0 is not greater than 0. So it basically defaulted to the final else statement. But what's actually happening here is that that was a draw. Computer chose rock, I chose rock. That's a draw in the official rules of rock, paper, scissors. So how do I catch that? Well, I could create another elif statement which says, well, if the computer choice is equal to the user choice, well, then we're going to print it's a draw. Now let's test our app again and see if there are any other situations where our code is not behaving properly. I'm going to choose rock again. Computer chose rock as well, and I get it's a draw. So that's pretty good. Now, if I choose 0 and the computer chose 2, then this is going to be the statement that gets triggered and I win. So that's pretty good. Now, what if I chose 2 for scissors and the computer chose 0? Well, in this case, rock beats scissors, so it should actually say I lose. But instead, it says you typed an invalid number. So it defaulted to the else statement again, because this particular situation is not caught by any of these statements. So what do we have to do instead? Well, we actually need another elif to say, well, if the computer choice was equal to 0 and the user choice was equal to 2, well, this means that rock beats scissors, so I lose and the computer wins. Now, the final one that we need to catch is this case. If I type 1 for paper and computer chooses 0 for rock, it again defaults to the else statement. Whereas in fact, in this case, it should tell me that I won. So what's missing here? Well, it's the partner to this particular statement. If computer choice is greater than user choice, then I lose. But on the other hand, if the user choice was greater than the computer choice, then I actually should win. So now the final thing we might have to fix is this else statement now actually never gets called, because this is what happens. So let's say that I choose 456. It tells me that computer chose 2. I win. What's happening here? Well, it's actually this particular line that's being carried out. User choice is greater than computer choice. This is not what we want. We want it to default to you typed an invalid number, you lose. So we can't actually just use else in this situation. We actually need to provide a condition. We're going to use elif to check if the user choice is greater or equal to 3. Now, the computer will never choose anything other than 0, 1, and 2, so we don't have to check that one. But the user could choose something above 3 or below 0. So we can use an or statement to catch this. Or if the user choice is less than 0, well, in this case, you typed an invalid number, you lose. But that's not all that we have to do. If we hit run and we again type some extraordinarily large number, you'll see that it still says computer chose 1, you win. What's going on? We have this statement that should catch this situation, but it's right at the bottom. So it's not going to be checked until one of the previous ones are checked. Namely, it's one of these that's going to be the problem. So what we have to do is we have to move this statement above all the lines so that we first check if the user choice is greater than 3 or less than 0. And if that's not true, do we actually continue checking to see who won the game? Now, finally, we can run our code, type an invalid number, and get you typed an invalid number, you lose. So now that we've actually got our logic all sorted out, the next step is to include our images. And to do that, we have to somehow match it up with these numbers we have, right? 0, 1, and 2. Now, there's many ways that you could do this and you could solve this project, but the easiest way is probably putting the game images into a list where we have rock as the first one, paper as the second one, and scissors as the last one. So we're using the fact that lists have a order that is always going to be followed. So we can now get hold of the rock picture by getting game images 0. We can get scissors by doing game images 2, and so on and so forth. And we can match those up to our choices, the user choice and the computer choice. So when the user chooses a number, then we're going to print from the game images, and we're going to use our little square brackets to select the image we want from this list. And the one that we want is going to be based on the user's choice, right? 0 for rock, 1 for paper, 2 for scissors. So we're going to put user choice as the index to pick out an image from game images. The index can only be 0, 1, or 2. So we should only print the image if our user picked a number that's greater or equal to 0 and less than or equal to 2. Otherwise, our program will crash before we reach our checking code down here, where we tell our user that they've typed in an invalid number. Now, down here for the computer choice, instead of printing the number that the computer chose, I'm going to delete that and add a little colon. So that way it's going to show computer chose, and then I'm going to print the image of the choice that the computer made. So I'm going to add another print statement. I'm going to tap into the game images, and then inside some square brackets, I'm going to use the computer choice, which is going to be between 0, 1, and 2, as the index to pick out the corresponding image from my list game images. So now we're finally ready to run our code, and I'm going to choose 0 for rock, and the computer chose paper. So paper beats rock, I lose. Let's try this again. I'm going to choose scissors, and computer chose scissors, it's a draw. Now we have completed the project by using everything from lists to randomization to variables to if statements and a whole lot of logic. So how did you get on with this project? If you struggled, this is the time again to go back to it and maybe map things out using a flow diagram. But the important thing is that you got to write your own code and you got to make it work. And this is the only way that you'll understand what's going on so that you can continue on. And as things get harder, you'll be able to learn more because you've already understood all of the previous knowledge. So I hope you had fun with me today, learning and building, and hopefully I will see you tomorrow, bright and early. So that's good night from me for today.
Hey, well done for completing day 4. I can see that you're really putting in the repetitions, putting in the practice, and this is what's going to take you really far. Because we all know that programming is not something that you can just learn passively. You can't sit in front of a TV, watch somebody talk about programming, and all of a sudden become a programmer. You have to put in the hours and the effort. It's a little bit like going to the gym, really. You're never going to become muscular and strong if you just watch a bodybuilding show, right? Even, if you watch Arnold Schwarzenegger every day, 8 hours a day, you will never develop those muscles that he has unless you actually hit the gym. So our version of the gym is coding. We're going to hit the coding editor and we're going to type every day until we get it. So have a break, have a rest, and come back tomorrow refreshed, and we're going to put in some more reps and we're going to train you up to become a great programmer.
All right, guys, well done for sticking it through. You are now on day 5 of 100 Days of Code. And today I've got a fun project for you. And the inspiration for the project comes from the fact that all sorts of companies seem to be getting hacked these days. Everything from Ashley Madison to Verizon, everybody seems to be really bad at keeping your password safe. So how can we make sure that these hackers who are in hoodies and wearing face masks don't get to you and your account? I also don't know why hackers are always portrayed like this. I mean, they're in their own house. They don't have to hide their face. But at least they're conscious of not spreading germs and staying warm, so that's good. But how do these hackers get into your account anyways? Well, one of the most common reasons is password reuse, using the same password on 20 different sites, from Google to Facebook to Skype to Spotify to all the random services that we sign up to. The problem is that when one of these sites get hacked, then the email and password combination you used to sign up is compromised. So all the hacker has to do is try out those credentials on a bunch of other websites and see if they work. So how would you know if your email and password is on a database somewhere? You can head over to haveibeenpwned.com, notice the spelling there, and type in your email to see if it was involved in a website that had been hacked. So let's try an email here, elon@tesla.com. And it tells us, oh no, it seems like this email has been pawned. And these were the websites which got hacked, potentially leaking this email and its associated password. I actually recommend you to try out your own email addresses right now and see which services you signed up to have been compromised. But if you want better security, then you'll actually need unique passwords for each and every website. And they should really be strong passwords, not 123456 or QWERTY. If I just called out your password, please change it. Now, what we're going to be building is exactly that. We're going to be building a password generator, something that's going to generate strong passwords with letters and symbols and numbers. First, it asks us how many letters would you like in your password? I would like 12. How many symbols would you like? I would like 2. And I would also like 2 numbers in my password. And then I hit enter and it gives me the password that it has generated with 2 symbols, 2 numbers, and 12 letters. So that's a pretty strong looking password, if you ask me. Now I can use this and update my passwords to something very strong and very secure. So this is what we'll be building by the end of today. But in order to do it, we first need to learn some new skills and new concepts. So head over to the next lesson and let's get started. The first topic I want to talk about today is the concept of loops, things that have to happen over and over and over again. The first type of loop I want to introduce you to is something called the for loop, and it can be used really easily in combination with something we learned in yesterday's lessons, which is lists. By using a for loop like this, we can go through each item in a list and perform some action with each individual item. So let's try it out in practice. First, let's say we had a list called fruits and it contained 3 items, apple, peach, and pear. If we wanted to access each item in this list individually and print it out one by one, then we would use a for loop. So we start out with the keyword for, and then we give a name to a single item. So in this case, we might call it fruit. And then we use the in keyword, and finally the list that we want to loop through, which is our fruits here. Now we cap it off with a colon, and we go on to the next line, and notice how it's indented there. Now I'm going to go ahead and print the value of each of the fruit variables. And if I run this code, you'll see that it loops through my list of fruits, and for each of the fruits inside the list, it prints it out into the console, apple, peach, pear, in that order. Now, the important thing to realize here is that basically you can imagine that behind the scenes, what this code is doing is it's taking this list of fruits and it's assigning a variable name, fruit, to each of them. So the first time this runs, fruit is equal to apple. The second time this runs, fruit is equal to peach. And we can see this even more clearly if you run it through the Thonny IDE, which I told you about at the beginning of the course. Now, if I go ahead and click on the debug icon and I step into each of the steps, you can see first it establishes that we have a list of 3 strings, apple, peach, pear, and then we go into the for loop. Now, notice on the right here, I've got all the variables being accounted for. And the first one it's noticed is the variable fruits, which holds a list of strings. Now, as I continue into the for loop, notice how it's going to look through this list of fruits, and it's going to assign the variable name fruit to each of the items, starting from the first one, apple. So now, by the time it's reached line 3, we've already got this variable called fruit that's been assigned to the value of apple. And so at this point, printing out the value of this fruit, it's obviously going to print out apple, as you'll see in the next step. There we go. Now, once I'm done here, then it's going to loop back to the start of the for loop. And now this variable fruit is going to be assigned to the next value inside the list of fruits. So now notice how the variable fruit is attached to the value peach. And then it continues this and so on and so forth until it prints out each one of the fruits. And this really emphasizes the most important aspect of loops. The loop allows us to execute the same line of code multiple times. In this case, we're executing the print statement 3 times, but our for loop isn't limited to just executing a single statement. We don't just have to print out the name of an item in the list. We can execute a whole block of statements multiple times, and we can do many things inside this for loop, and by inside, I mean indented. So let's say that in addition to printing out the fruit, I'm going to write another print statement, and I'm going to not only print out the name of the fruit, but I'm also going to say fruit plus space plus pie. So when I run this code, what do you think will happen? Well, it prints out apple, and then it prints out apple plus pie. And then it goes back to the start and it assigns the variable fruit to the next item, peach, peach pie, pear, pear pie. So this is how we can implement a simple for loop that loops through a list and assigns a variable name to each of the items in the list in order. And then inside the for loop, after the colon, after some indentation, we can do something with that temporary variable for each of the items. Now, I've been talking a lot about the concept of being inside a for loop versus being outside a for loop. And this is really, really important. Whenever you see a colon, say in our if statements that we saw previously, or the for loop that we're using here, the indentation is really, really important, because if it's indented, then it means that it's inside the for loop, and these instructions will get carried out for as many times as the for loop will need to repeat. Now, if I decided that I wanted to, say, print my fruits, so my list of fruits up here, and I put it inside my for loop, so indented after the for loop, then as you can imagine, it's going to print that for as many times as the loop runs, which is going to be 3 because there's 3 items in our list. Now, if I had indented that back to the beginning, so now it's no longer inside the for loop, then it's only going to print once, and it's going to print it after the for loop is done. So notice how it's doing the whole apple, apple pie, etc. And then once the loop is finished, then it jumps to the next line and carries out this instruction. So the indentation is really, really important, and you have to be really careful with this. Have a play around with this code, and if you're still struggling to see how it works, then move the code over to Thonny and step through each step one at a time and see how it works. But I hope you're starting to see how loops are really handy at executing an instruction over and over and over again, getting the computer to save us time and energy. A really good example of when loops would come in really handy is, you know how Bart Simpson gets punished and has to write out a sentence over and over again on the blackboard? Well, if only Bart was a programmer, then he would be able to use loops to do this, and he would be able to chill in the corner. Now, once you're happy with this type of for loop, then head over to the next lesson where I've got a coding exercise that's going to put your knowledge to the test. All right, so I'll see you there. Now, one of the things that you'll start to realize about the Python programming language, especially if you have experience of other programming languages, is that Python is extremely number friendly. It has a lot of built-in functions to help us work with numbers. For example, if I had a class of students and I list each of their exam scores inside this giant list, and I wanted to work out, well, what is the total exam score? So what if I added each of these numbers up together? What would I get? Well, Python has something called the sum, which allows us to put in any iterable data type, including lists. So I can put these student scores into here, and I can set this, let's say, to the total exam score. And then if I print this, you'll see that it has added up each of those numbers in the list, and it equals 2068. Now, if I wanted to do this manually, though, I could, because at the end of the day, all that's happened is the Python team, when they developed the programming language, they created each of these helpful functions. So we could create some ourselves as well, given that we understand how for loops work. So we could say for score in student scores, colon, and then in the indented block, we could say, well, we need to add each of these scores to each other, right? And then we need some sort of variable to keep hold of it. So let's create a variable called sum and set it to start off as equal to 0. And then we could say sum plus equals score. And every time this for loop runs, it's going to go to the next score and the next score. And each time that score is added to the previous value of sum. So then it accumulates in that variable. So now what we can do is go ahead and print the sum and go ahead and hit run. And you can see that it's exactly the same number as before. So this is a way that we can use the primitive parts of Python, so the building blocks of Python, to build out functionality for various use cases, such as summarizing each of the numbers in a list and adding them together. So here is your challenge. You're going to do the same, but in your case, you're going to try and replicate the max functionality. So this is a built-in function that allows us to pass in a list, for example, student scores, and if we print it, you can see it will pick out the largest number in this list, which happens to be 199. Now, your job is to replicate this functionality, but using what you have learned about for loops, about lists, about conditionals, and see if you can figure out how to achieve this. So pause the video now and give this challenge a go. So similar to previously, we will use a for loop to loop through each of the scores in the list of student scores. And if you want to verify it as you go along while you're writing your code, it's always a good idea just to make sure that your code is doing what you expect it to do. So in this case, we're going through each of the scores. Now, instead of printing it, we want to check it against the number which we want to set as maximum. So similar to sum, we need a variable to hold all of the intermediate values until we reach the maximum. So let's create a variable called max score, and let's just set it to equal 0. Now, when we loop through each of the scores, we're going to compare the current score that the loop is going through. So the first time it will be looking at 150. And we're going to say, well, if the score that we're currently looking at, let's say 150, is greater than the max score, well, in that case, we're going to set the max score to this current score that we're looking at. And what this loop is going to do is it's going through each of these numbers. So let's go through the first 3 in order, just so that we can make this process a bit more clear in your mind. The first score is equal to 150. Is 150 greater than 0? Well, yes. So then this bit of code carries out, and now the max score is equal to 150. So for the next score, it's 142. So is 142 greater than 150? No, so we're not going to do anything at all. You could, of course, have an else statement that just prints something, but in this case, it's unnecessary. We only need to check for one thing, and that one thing is each time we loop through each of the scores, is it greater than the previous maximum? And now, if I go ahead and exit the indentation levels and go to the very start, so I'm outside of the for loop, and I print out the max score, you'll see that it will give me the same result as using the max function, which is 199. So if this code doesn't make any sense to you, I recommend going back to the previous lesson and revising what we learned about for loops. Alternatively, maybe you need to do some revision on how if statements and conditionals work. But either way, make sure that all of this code makes perfect sense to you and you can write it from scratch without having to look at the answer code. Because it's really, really important as we progress that I'm going to assume that all of this makes sense to you so that we can build upon our knowledge. And then once you're ready, I'll see you over in the next lesson.
Now, up to this point, we've only been using for loops in association with lists. So we've been looping through the list and getting hold of each of the items in the list and then doing something with it, right? But we're not always going to be working with lists and using for loops. Sometimes we might want to use a loop completely independent of a list. And a good example of this is when Carl Gauss, the German mathematician, was just a child. When he was 10 years old, his math teacher gave him an exercise that she probably thought would tie him up for a little while. And the idea was to get him to add all of the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4 plus 5, etc. all the way until 100. And even though she thought this would keep him busy for an hour or so, getting this young child to add up these numbers and I can have some peace and quiet scrolling on Facebook, but unfortunately he came back to her within 2 minutes and gave her the answer. So how did he work it out? Well, he was actually a really smart kid, and he figured out that if you flip the numbers around, so 100 plus 99 plus 98, and you look at both of these two lines, you can see that 1 plus 100 equals 101, 2 plus 99 equals 101, 3 plus 98 equals 101. Basically, if you tie all of these numbers together, there's actually 50 pairs of 101. So he could simply just do 50 multiplied by 101, which is 5,050. And that's how he figured out the answer. But we can actually outshine Gauss because we can do this calculation in less than a minute just by writing a few lines of code. But in order to do this, we first have to learn about using for loops with the range function. Now, the range function is something that is really, really helpful if you want to generate a range of numbers to loop through. And the syntax looks something like this. So we've still got our for and our in keywords highlighted in blue. But instead of looping through a list, we define how our loop is going to work by creating a range. So in this case, I'm creating a range between A and B, and then I'm going to get hold of each number in that range and do something with that number.
Now, it's important to remember that the range function doesn't actually do anything by itself.
So if we create a range between 1 and 10 and we say just try to print this and we run, you can see it doesn't actually do anything. It doesn't print out the numbers 1 through to 10 at all. This function has to be used in conjunction with another function. And in our case, it's going to be with the for loop. So for example, if I wrote for number in range, and then my range is going to be 1, 10. So this is going to be the range that I'm going to create between 1 and 10. And then I want to get hold of each of the numbers inside that range. And this is going to be between 1 and 10 and not including 10. So if I go ahead and print out the number that I create from my for loop, then you'll see that what happens is it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, but not the last digit, which I've included here. So if I wanted all of the numbers from 1 to 10, I actually have to set a range between 1 and 11. And now when you run the code, you can see that it goes from 1 all the way up to 10. Now, by default, the range function will step through all the numbers from the start to the end, and it will increase by 1. Now, if you want it to increase by any other number, then you have to add another comma to the end of it and specify how large you want the step to be. So let's say we change the step size to 3. Now, if I rerun the same code, you'll see that it goes from 1, and then it steps by 3 to 4, and then it steps by 3, and then it steps by 3, finally to 10. Now let's come back to the problem that I mentioned at the beginning of this lesson. How can we add up all of the numbers from 1 to 100 by using code? So I want you to pause the video and see if you can solve the Gauss challenge. Have a go now. All right, so how do we solve this? Well, it's going to involve the for loop and it's going to involve the range function, because we're going to get hold of every number in the range between 1 and 100. So we need to write 101. Once we've got hold of all of these numbers, it's as simple as using an accumulator. So let's say total equals 0. And then inside the for loop, so that means indented, we're going to say total plus equals number. So now it's going to add every number in this range to the total starting from 0. And this is basically going to give us the sum of every number from 1 to 100. So let's go ahead and print it out and see if it matches Gauss's value. And there you have it, 5050. So now that we've beaten Gauss at his own game of math using programming, let's head over to the next lesson and try to complete a challenge using the range function to see if you manage to internalize and understand everything we talked about in this lesson. So for all of that and more, I'll see you there. Now that we've learned all about loops in Python, we're finally ready to tackle our final project of the day, which is the password generator. Our program will ask us, how many letters would you like in your password? So I will say, I would like a long password, let's say 14. How many symbols? 3. How many numbers? 4. And it's going to generate me a password that is almost completely impossible to crack by any hacker, no matter how talented they are. So the project of today is to build this password generator. Then you'll see that here I've already included for you a list of all the letters in the alphabet from A to Z, including the uppercase and lowercase letters. I've got a bunch of numbers and a bunch of symbols that are usually accepted by websites in the passwords. Now, there's 2 levels to this project. You can either go for the easy version, where all you have to do is generate your password in sequence. So for example, if the user wanted 4 letters, 2 symbols, and 2 numbers, then it might just look like this: 4 letters, and then 2 symbols, and then 2 numbers. So they're in sequence, right? First you've got the letters, then you've got the number of required symbols, and then you've got the required numbers. So this is the easy level. And then there is the hard level. And the hard level requires you to generate the password
in a completely random order. So instead of having it being letter, symbol, number, it should be maybe letter and then a symbol and then a number, then a letter, then a symbol, and then a number. But notice how this is completely random. Every single time you generate it, the order of where the symbols and where the numbers appear in your password are completely random. So for example, if you look at the demo version and I do the same thing, 4 letters, 2 symbols, 2 numbers, where the numbers and where the symbols occur are completely unpredictable. So that's the hard level. I recommend trying the easy level first, and then once you've managed to do it, then take yourself up to the hard level if you think you're up to it. Pause the video now and try to complete the final project. Alright, so let's first tackle the easy level, where we're just generating a password with the required number of letters, and then the required number of symbols, and then the required number of numbers. So let's go ahead and tackle this one first. Now, we know that we've got these lists which we can draw from, and we know that we can use the random module to get hold of a random item from the list. So all we have to do is first get 4 random letters. So let's say that we had a password which just started out as an empty string. Then we can use a for loop to loop through all of the characters that we need to create for our password. For example, I might say for car, short for character, in the range of from 1 to the number of letters that the user wanted. So in this case, if the user wanted 4 letters, then it will be a range from 1 to 4, but not including 4. So it's actually from 1 to 3, which is only 3 characters. In order to modify this, we have to do what we did always before, which is just to add 1 to the end of our range. So now we're going to create a range based on the number of letters that the user wanted. And I'm just going to go along with the assumption that the number of letters equals 4. Let's just pretend that's what the user will enter. So then this range becomes 1 to 4 plus 1, which is 5. So the range is in fact going to be 1 to 4. For every single number in that range, from 1 to 2 to 3 to 4, I'm going to generate them a random letter, and I'm going to pick it out of this list of letters. To do that, I can either generate a random number and use it as the index, or you might have seen previously, I showed you the random.choice function. And inside this random.choice, we can pass a sequence, which in our case is the letters list. Then it will look through this list of letters and it will give us a random item from that list. So now that random letter is going to be something that we're going to need to add to our password, right? So we can set this equal to a random character. And now let's go ahead and just print it out. So let's say we want 4 letters in our password and we can type anything for the other ones. But notice how when the for loop runs, it's given us some random characters that it's picked out of our letters list. How can we add each of those letters to our password? Well, we can use the string concatenation that we learned very early on in day 1. We can say password equals the previous password plus the random character. Of course, the shortened version of this is just password plus equals random character. And now let's go ahead and instead of printing the random character, let's print the password at each stage of the loop. And again, I'm going to choose 4 letters. So you can see the first time the for loop runs, I get a capital H as the random character. And then the next time the loop runs, I get an A, and the A is tagged to the end of the H. So I get HA, and so on and so forth until I get these 4 characters in the beginning of what seems to be my random password that's going to be generated. Now, if you wanted to, you can actually simplify this down to just one step, because instead of having this intermediary, which is the random character variable, we can simply just replace it with the code, like this. So in this case, we're getting a random choice from our letters list. So we get a random letter, and then we add that to our password. Now that we've done that for the letter, then it's pretty easy to see how we can continue doing this for the symbol and the numbers. We just have to keep adding it to the end of our password. So let me quickly write out the code for this. So now, when the user requests that they want 4 letters in their password, then we generate a range from 1 to 5. And then for each of those positions, we generate a random letter in order to fill the password. And then we add on the required number of symbols and the required number of numbers. And finally, we print out the final password.
Now, there's a way to simplify our code even more. Previously, we always used the range by starting from 1 and then going up to 1 over the number that we want. For example, when we wanted 1 to 100, we created a range of 1 to 101. Now, in this case, because all that we want is a range that covers all the letters, symbols, and numbers that the user wants. So if the user wanted 4 letters, then what we need the range to be is 1, 2, 3, and 4, which in this case is a range of 1, 5, because of the way that the range doesn't include the upper limit. Now, if we think about this logically, we can also change this to 0, 1, 2, 3. So then we can have a range of 0 to 4. So that means we can actually use the number of letters as the upper limit and then simply change this to 0 so that we don't have to add 1 to our number of letters. And I think this will make our code even simpler and hopefully simpler to understand as well. Now, if you prefer the previous version, which we've seen throughout the course, then feel free to keep it as it is. But this way, we get rid of all of these +1s, and you can see it's a lot tidier.
Let's go ahead and run this code. And again, I'm going to choose 4 letters, 2 numbers, and 2 symbols. And I end up with my final password, which fits exactly that criteria, and it looks pretty random. But the only problem is that if a hacker knew that you always have 2 symbols at this position and 2 numbers at this position, then it's very easy to crack that password, because in order to get the last digit, for example, they only have to try 9 different variations, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this just limits the strength of your password. In order to tackle that, you would have to tackle it at the hard level, which is how do you get a password that has all of these letters and numbers in a completely random order? To do that, we mentioned that you have to do a bit of Googling because it might require something that you haven't done before. But in essence, you've got access to everything you need to perform the logic. So if you haven't given that a go, then this might be a good time to pause and have a think about how you might structure the logic, or how you might create a flowchart to express this logic that you would want. And once you've done that, and if you want to see the solution and walk through it with me, then come back here and I'll show you how to do it. But first, give it a go. All right, in order to tackle the hard level, what we essentially need to do is, instead of adding each of these letters into a string, we actually want to add it into a list. So I'm going to copy all of this that's here, and I'm just going to comment it out, and I'm going to paste it under my hard level and work on it here. So instead of using a password string, I'm going to create a list, and to better describe it, I'll change my variable name to password list. So now, instead of using password to add each of these letters and numbers and symbols, I'm going to be adding it to my list. Now, to add things to a list, you can use the same syntax that you did with strings, which is to add the new item into the list and to update the old list. You might be more familiar though with the syntax which is append. And both of these work. You can use either of them if you want, but they'll end up doing the same thing, which is to add each of those things you've generated in the order that you've generated to your password. So we end up now with a list with 4 letters, 2 symbols, and 2 numbers, all stored as strings because of the quotation marks around them. So now that we've got a list, well, then we have to think about, well, how can we shuffle our list? How can we mess up the order of the items in our list? And that might take you to Google, and you might search for something like how to change the order of items in a list. And then we also have to add our keyword, which is Python, because there's obviously a lot of other programming languages. And we come up against our first Stack Overflow question. How can I reorder a list? Well, that sounds kind of like what I want to do, right? So if we scroll down, you can see that the way to do it is either using a for loop like so, or to simply use the shuffle function. This is a much simpler way because it allows us to update the existing list just by calling the shuffle function on it. And this one actually requires us to create a new list, and we have to create a bunch of random numbers for the order and then to reorder them using a for loop. So I'm going to go with this version, and let's try it out. Let's print the password list before the shuffle, and then let's use the random.shuffle and pass in the password list, and then let's print the outcome of that shuffle. So let's print the password list again. So now you can see that we've got a version before and then we've got a version after. So if I run my code and I write again 4 letters, 2 symbols, 2 numbers, you can see that previously it was ordered in the order that we added each of the characters. After the shuffle, they're now pretty much random. There's letters in random places, there's symbols in random places. So if only we could turn this back into a string, then we've got our password that's nicely shuffled. So how can we turn it back into a string? Well, we could simply use a for loop, right? We could say for each character in the password list, we're going to add it to a variable called password, which is going to start off again as an empty string, and then we're going to add to it. So we're going to say password plus equals each character in our password list. And now if I go ahead and just print my final password, I'm going to add a F string as well. Let's say your password is, and then let's insert the password. And now if I run my code and let's say I want 12 letters, 3 symbols and 4 numbers, then it's going to generate me an entire password that's completely randomized in terms of the orders of the symbols and the numbers. And I've now solved the hard part of this challenge project. Did that make sense to you? Did you manage to get it to do what you wanted to do? If you're at all confused about the code that we've covered here, then be sure to check out the final project and take a look at how the easy level is implemented, how the hard level is implemented, and try switching it around so that you really get to understand it. Try, instead of maybe getting the user to tell you how many letters, how many symbols, how many numbers, instead just define those yourself or use a random number of letters, numbers, and symbols. Play around with the code until it starts doing what you want it to do and it starts making sense. But I hope you had fun building this project with me today and learning all about loops. On the next lesson, we're going to be learning more about these things that we've been using a lot, which is Python functions. So I'm going to bid you good night for today, and hopefully I'll see you bright and early tomorrow, and we'll learn some new skills and work on some new projects. So that's all from me. Good night from Angela.
Hey, well done for completing day 5. Now I know that day 5 had a really difficult challenge at the end, so it must have taken some perseverance that you had to draw out of yourself in order to actually do it. Now, at this point in time, you might be feeling a lot of the same feelings that I had when I first started learning how to code, which is this overwhelming sense of like, maybe this is not for me because everything is so overwhelming and I don't understand it and it's just not clicking. Maybe I'm not meant for this. Maybe I was born to be a lobster, instead of a programmer. But you know what happened? I continued, I persevered, and at some point it actually all started clicking. It started making more sense. So just trust in the process, keep showing up and just put in those reps every day. And I promise that by the end of the course, you will not feel like this. You will feel like you're on top of this and you got it. This is going to happen. So keep going, keep doing what you're doing. You're doing a great job.
Hey guys, welcome to day 6 of 100 Days of Code. And well done for making it this far. So today we're going to talk about code blocks and indentation, as well as functions, and also a different flavor from the for loops that we saw yesterday. Today we're going to talk about while loops as well. And to learn all of these things, we're going to use the help of something that's very similar to Carol the robot. And this is something I used when I first learned how to code. And it's one of my favorite tools for learning programming, especially as we get into more difficult concepts like functions and while loops, etc. And by the end of the day, we're going to be writing the code that's required to instruct our little robot to be able to complete any randomly generated maze. So that's the goal. And if you head over to the next lesson, let's get started and let's start learning about some of these things. The first concept I want to introduce you to is something called functions. And just as we perform many different functions, it could be mother, father, son, daughter, we can also get our code to perform different pieces of functionality. Now, if we think back, we've actually already come across functions, and I've been referring to them every time we've needed to use one. If you take a look at this link in the course resources, which takes you to the Python documentation, then you can see that Python has a whole bunch of built-in functions that we've been using. For example, the len function, which gives us the number of items in a collection, or the int function, which turns something into an integer, or the print function, the range function, and other ones that we haven't seen yet. We can start typing one of the functions that we've been using a lot, which is the print function. And the reason why we know it's a function is because it's the name of a function followed by a set of parentheses. Now we know that if we put something inside these parentheses, say for example hello, then when I run the code, whatever is inside those parentheses will get outputted over here in the console. Now, all the functions work pretty much the same. So if I wanted to use the len function to see, well, how many characters are there in this word hello, I again put my hello inside the parentheses, and because of the parentheses, we know that this is a function, and then I can save the outcome of this length function to a variable, say, let's call it number of characters, numchar, and then I can go ahead and print it in order to view it inside the console. So let's print the num underscore char, and now you can see that this len function gets to work, calculates the number of characters, it's 5, and then it gets printed. So all of this functionality has been achieved by these built-in functions from Python, like print and len. Now, what if we wanted to make our own functions? How would we do that? Well, if we want to make our own function, we first start out with a keyword, which is called def. And this is because we're creating or defining our function. Now, after the def keyword, we can give our function a name. And I'm just going to call it my function. Now, the thing that differentiates a function from a variable, however, is the parentheses. So after the name comes the parentheses, and now the final thing, the finishing touch to our function definition, is a colon, because that says everything that comes after that line and is indented belongs with the function. Let's make a really simple function that just has 2 lines of code. Maybe it prints hello and then it prints bye. So now I've created my function. I've placed the lines of code that are associated with this function all indented after the definition. But notice how if I go ahead and run my code, actually nothing will happen. And the reason is because we haven't yet executed the function. Now we can define lots and lots of functions ahead of time, and it's only when we actually need it do we go ahead and trigger it. And to trigger it, or in programming lingo, we would say to call the function, all we have to do is type the name of the function, which is my function, and then to add the parentheses and any necessary inputs. In our case, our function doesn't require any inputs, so we can leave the parentheses blank again. And now if I go ahead and run my code once more, then you'll see that by the time the computer reaches line 5, it's going to search for this thing called my function. It sees that it was defined right here on line 1, and it goes through all of the content and executes them in turn, line by line. And that's why we get hello and bye being printed here. So just to recap, this is how we create a function in Python. There's 2 steps to it. The first step is to actually define the function, to specify what it should do. And we do that by first using the def keyword, and then we give our function a name. So for example, in this case, I called it my function. And then comes a set of parentheses and a colon. And then after that, we get to put the lines of code which will be included in this function. And remember that these lines of code which goes into the function, which will be carried out when this function is triggered, must be indented like this. So once you've defined the function, you've created the recipe, the next step is to actually use it, which in programming lingo, we would say calling the function. And we call the function just by specifying the name and a set of parentheses. And once the computer sees this line of code, it'll know to go and carry out all the instructions inside where we defined our function. And to learn about functions, I'm going to introduce you to something that's very similar to Carol the robot. The robot is going to be something that is just going to perform the tasks that we want it to, and no more and no less. So for example, if we wanted a robot to go to the store and pick up some milk for us, we can't simply just tell it, oh yeah, just go and buy some milk, because it won't know how to do that unless we give it specific instructions, such as leave the house, walk 2 blocks to the right, walk 4 blocks back, and then 2 blocks to the right. When you go to the store, give them some money, and then take the milk and come back. We have to program each and every step. But say if this functionality of getting the robot to go and pick up some milk for us is needed every single day, then we have to write out all of those instructions day after day, day after day. And at some point, our fingers are going to hurt, right? We're typing so much code that's repeated because we don't have a way of bundling all those instructions together. And that's where functions come in. Functions will give us a way of referring to all those instructions at the same time. That way, we can give our robot a single instruction and it will carry out all of those little steps for us and get us some milk. Now, to try this out yourself, I want you to head over to the course resources and click on the link that takes you to Reborg's world. Now, Reborg's world is very similar to Carol the robot that I showed you earlier on, but it allows us to write Python code. And it's very easy to get started. Now, we've got this area here, which we're going to use to write our Python code. And then once we're done, we can click on play to run the Python code. and see the instructions carried out by our robot. If you click on Reborg's keyboard, you can see all of the functions that we can use to command our robot, like move or turn left or build a wall, etc. Let's see if we go ahead and run this line of code here, move, what happens. When I click play, you can see that our robot moves forward in the direction that it's facing by 1 step. So if we wanted it to move, say for example, 3 steps, all we have to do is to call the move function 3 times. Now let's reset by clicking the return button to return our robot back to the starting position. Now let's click play again in order for our robot to carry out the new instructions. Notice how all the instructions were carried out very quickly. To execute each instruction 1 step at a time, line by line, we can use this step through button. This button allows us to see how each instruction is executed. And after each instruction, it pauses and highlights the next instruction. This is very helpful for debugging. So notice how we're highlighting line 2. So if I click on step again, it's going to carry out that function, and then it's going to carry out line 3. And finally, it reaches the end, and that's the end of our code. Now, in addition, we can use some of the other commands in the keyboard. For example, turn left. If I decide to say move 3 times and then turn left, and then maybe move 3 times again, can you predict which square the robot is going to end up in? Are you ready? Let's go ahead and run the code. There we go. We end up on the square 4, 4. It moves 3 forwards, turns left, and then moves 3 steps again, because that's what we told it to do with our Python code. So now here's a question. If you take a look inside the set of commands, you'll notice that there is move and there is turn left, but there is no turn right and there is no turn around. So how could we use a function to create those commands? Because of course we could just simply write turn left and then turn left again. And this would effectively turn the robot around, right? But if we want to do that many times, say for example, if we wanted to go to 3, turn around, go back to 1, turn around, go back to 3, then we would have to write code that looks a bit like this. We would have to say move 2 times to get to square 3, turn left, and then move 2 times again to get to 1, and then turn left again in order to turn around. This is all the code we would have to write to achieve this kind of effect. But instead of all of this, we could just define a new function. So we use the def keyword to say that this code is defining a new function called turn around. And this function is simply going to be turn left twice. And remember, all the code that's going to go inside the function has to be indented. And now, instead of writing turn left, we can simplify our code by telling it to call the function turn around. And we can do that here, and we can do that here. So now, when we run the code, you'll see that it does exactly the same thing as before, but this time we've cut down 2 lines of code. So instead of 8 lines of code for our instructions, we only now need 6 lines. And you can see that the more that you need to use this function, the more typing it will save you. But more important than reducing the number of lines of code is that our code has also become a lot more readable. So the turnaround function is much more clear than having turn left twice. Now let's see what happens when we use the step through button. Look closely at how each line in our code is executed. So now we're going to carry out the move by 1, and now it's going to call turn around, that function. And it jumps over to find this function and carries out the code inside, in turn, from the top to the bottom. So turn left, and now once that function's done, it goes back to where it was before and continues running. Move, and then turn around again. So here's your challenge. Try and create a separate function that turns our robot to the right. Pause the video, head over to the course resources, and click on the link that takes you to Reborg's world, and then go ahead and create your own function called turnRight. All right, so this should be pretty simple because all we have to do is to define a new function called turnRight, and this function is going to simply be turn left 3 times. Because turning left 3 times is going to effectively turn our robot right. So even though we only have this one way of turning our robot, we can define our own functions to give it many other commands that it could use. So now, using this turn right function, see if you can write some code that makes our robot draw a little square going from here to here, then to here, and back to the beginning. Once you're done and you hit play, this is what should happen. So pause the video now and see if you can complete that challenge. All right, so let's go from the beginning. We start out facing right at the position 1, 1. In order to draw the square starting from this way, we have to first turn left. And then we have to move 1 step, and that should take us to here. And now we have to turn right, move 1 more step, turn right again, move 1 more step, and finally turn right for the last time and move 1 more step. So using our awesome function means that we don't have to write out turn left 3 times each time we need to turn right. So our code can just be 8 lines long instead of 14 lines long. And we're using our function to cut down on a lot of typing. But not only are there fewer lines of code, look at how much more readable our code has become thanks to our turn right function. It's now so much easier to read, turn right, and understand what it needs to do rather than seeing turn left 3 times in the code. So now it's easier to read and it's easier to follow the logic in our code. In the next lesson, I've got a challenge for you. Head over there and apply what you've learned about functions to try and solve it. I'll see you there. All right, so now that you've learned about functions, I have a coding challenge for you. If you head over to this link, which is in the course resources, and head over to this challenge, which is called Hurdle 1. The idea is that we've got a robot here, which needs to do a number of hurdles to jump over each of these barriers to get to the final goal here. Now, you need to use your knowledge of functions as well as some of the things you've learned before, such as the for loop or the range function, to be able to achieve this. Now remember that you can tell the robot to move by typing move parentheses, and when that's run, it will move by 1 space. And you can also use, say, turn left to get the robot to turn left. And in this case, when I run the code, it's going to move 1 space and face to the left. In order to complete this entire challenge, you can see there's a number of steps that the robot has to go through before it can get to this final goal. And if you were to write out each of these steps, like I have done here, one after the other, it would take many tens of lines of code. And that's not what we're about. We're programmers, so we're born to be lazy. Try and see if you can minimize the number of lines of code while still keeping your code readable and understandable by somebody else, and be able to get your robot to complete these instructions and take the robot to the final goalpost. And once you've completed the challenge successfully, you should get a green pop-up that says you're at the correct X and Y position. So pause the video now, head over to this link, and give this challenge a go. All right, so how did you get on with this challenge? How many lines of code did it take you to tell this robot to get to the goal? All right, let's have a think about how we might tackle this. We know that out of the things that we can tell the robot to do, the most useful things are to move and to turn left. But because the robot doesn't have a built-in turn right function, then we have to define that ourselves. And the reason why we need to do that is because you can see it at several points during the hurdle, we'll have to turn right. For example, when the robot is here at 2, 2, it will have to turn right and then move, and then turn right again and then move. So let's create a new function called turn right. So we start out with the def keyword and then give our function a name, which is going to be turn right. And then we add the parentheses with nothing inside because we're not passing any inputs to this function. We're just going to use this function as a way of defining turn left 3 times. So when you turn left 3 times, of course, you turn right. And now we have the ability to turn right. So notice how this is the code block for our turn right function. And it ends at the last line, which is indented, which is line 4. So every subsequent line which starts at the very beginning of the code file next to the left margin is outside this code block and it will act independently. So in fact, the first line of code that actually runs in our file is going to be this line 6. And you can see that when I press run, you can see that's the first thing that gets highlighted. And if I go through this stepwise, you can see the first line is going to be line 6. And it tells the computer to go and find this function called turn right. So if I skip to the next step, it's found that, and it's going to start going through lines 2, 3, and 4, turning our robot 3 times until it has turned right. Now that we have the ability to turn right, let's have a think about how we might be able to get our robot to make one jump. Let's see. The first thing we'd probably want our robot to do is to move forwards by 1 step, which should take it here. And then the next thing we want it to do is to turn left so that it faces the top. And once it's in this position, then we want to get it to move forwards 1 step. And then we'll probably want it to turn right. Now, notice how I'm actually testing my code at pretty much every other line that I write. And this means that you don't end up in a situation where you get to the end and you've written lots and lots of lines of code and it doesn't work. In which case you have to comb through all of the code you've written and find out where the problem is. So in this case, we've only got 4 lines and we've been testing it stepwise. So we can see that we're on track. And our robot is now turned to the right, ready to move 1 more step. And then once it gets to here, we have to turn right again and move 1 more step. And now it should end up here, but let's just check it out. So our robot turns left, turns right again, and it ends up here facing the bottom. So the final thing we need to do is to get it to turn left once more so that it will face the forward direction. So once you've confirmed that your code is working, then you should really think about what is the next step, because we've managed to make 1 hurdle. And notice how when we're at this position, 3, 1, this particular square, it's almost the same as if we were at 1, 1. Because we have to move 1 step again, turn left, move, turn right, move, turn right, move, turn left. So it's basically repeating all of these instructions. Rather than executing these instructions 6 times, because there are 6 hurdles. So if I go back and I start, then you'll see that this code actually will complete the challenge. It says, I'm done, and we're at the correct position. But notice how many lines of code we've got. We've got something like 58 lines of code. I know I've left some spaces in there so that you can see which parts are repeating, but still, that's a massive amount of code for something very simple. Now we know that we can use functions to package a set of instructions together under one name, just like what we've done here with the turn right. We've packaged the 3 lines of code, turn left, turn left, turn left, into a single function called turn right, so that when we need that functionality, all we need to do is just to call the function and add the parentheses at the end. So we can do exactly the same thing with this set of instructions, which basically gets our robot to perform a single jump. So let's create a def and let's call this function jump. And then let's add the parentheses and the colon. And very importantly, all of these lines of code must be indented. So to indent a whole block of code together, you hold down the command key and click the left square bracket or the right square bracket. On Windows, it's holding down the control key and again the left square bracket or the right square bracket. So now this basically says that all of these instructions live inside this block of code called jump. And when we call jump, then it will carry out all of these lines of code. So now what we could do to complete the challenge is to simply call this function jump 6 times. And so now we could again solve this entire problem using just 21 lines of code. And we managed to complete this challenge using 2 functions that have repeated instructions and then calling the jump function 6 times. But because we've learned about loops and the range function, we know that we can actually cut this down even shorter. So instead of calling jump 6 times, we could actually write a for loop that loops through and calls this jump function 6 times. We could say something like for step in, and remember that these 2 keywords come from the for in loop and they always have to stay the same. And then after the in keyword, we define the rules for how many times we want our loop to repeat. In my case, I'm going to use a range function, and I'm going to say from 0 to 6, but not including 6. So in this case, it will be 0, 1, 2, 3, 4, 5. So that's actually going to happen 6 times. And now I'm going to add the colon, and finally inside this for loop, I'm going to call jump just once. Now watch what happens. First, it starts off at the for loop, it calls jump, and it goes through this once, and then it comes back, loops again, calls it the next time, and then again, the 3rd time in the loop, 4th time in the loop, 5th time in the loop, and 6th time in the loop. How far did you manage to get? Did you get stuck on this section where we needed to create the for loop? Well, in that case, I recommend going back to the lesson where we covered for loops and reviewing the for loop and the range function in detail before you come back and try to solve this challenge again. It's really, really important at this stage that you've understood and you've mastered some of these ideas, because we're going to be using them more and more in the future. Really make sure that you've understood things before you keep going. In previous lessons, I've already mentioned how important it is in Python to be aware of your indentation. So we know that when we create a function like this, that every line that comes after this definition that is indented is going to be inside this function. So by indented, I mean it's shifted to the right by 4 spaces, like this. So if you imagine each dot as a space, then this is a single block of code. And if we want to continue adding to this block of code inside my function, then we would continue adding lines of code which are indented. So you have to almost visualize for yourself this invisible line around these blocks of code which are indented. Now, if my code was written like this, on the other hand, then the block of code is in fact only this part. And this print statement will not get triggered when this function gets triggered, because it's independent from this function, because it's not indented. Now, a simple way I like to think about this kind of indentation is kind of like the file structure you see when you go into Finder on the Mac or when you go into Explorer on Windows. If we have a function, it's kind of like a folder, and anything that goes inside the function, for example, if I throw this file inside the function, then you notice that it gets indented, right? And this way it shows to you very, very clearly that these two files, print hello and print world, are living inside this folder, my function. And this is the equivalent of this code. We have this folder, say my function, and it contains these two lines of code. Now, on the other hand, if I take this print world and I put it outside of the function folder, then you can see that this is completely independent from that folder, and it's now indented at the same level as the function. So this is the equivalent of this code, where we've got this print hello being inside the my function and this print world being outside and at the same indentation level as this function definition. Now, the indentation gets a little bit more complicated when we have other blocks of code. So, for example, the if, elif, else statements, they have blocks of code which need to be indented to be inside the block. For loops need to be indented to be inside the loop. And it's very important that you get used to looking at blocks of code like this. So, for example, if we were to expand our simple my function and add a whole bunch of code into it, then we would have to indent all of those lines of code by 4 spaces, represented by the 4 dots here. Now, if we wanted to have another block of code inside this if statement, then this line has to be indented a further 4 spaces. So this is the function block. This is the if block. This is the elif block. And you have to be able to see all of this while just looking at the indentation. If we wanted to represent this, then it's almost like creating a new folder. Let's call it the if sky is equal to clear. And this if block goes inside my function, so it's indented. Now, if I wanted to have a print statement, let's call it print blue, inside this if statement, so this is what should be executed if this function gets called and if the sky is equal to clear, well then this line is indented twice. And that is the equivalent of 4 spaces in our code, like this. Now, every time I've talked about indentation, I've been talking about spaces. And actually, there's 2 ways of creating indentation. You don't have to just use spaces. You can also use tabs. And that's created using the tab key on your keyboard, which can look a little bit like this. Now, there's a lot of debate around spaces and tabs, where some people prefer using spaces to indent, other people prefer tabs to indent, and there's a lot of people arguing in the coding community. And I think this excerpt from one of my favorite shows really demonstrates this.
Richard, what's wrong?
Nothing. Literally, it's all good. Come on.
Oh my god.
I'm sorry.
Your roommates were right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world with that over the heads? That's not really fair to them, don't you think?
Kids? We haven't even slept together.
And guess what? It's never gonna happen now because there's no way I'm gonna be with someone who uses spaces over tabs.
So should you be using spaces or should you be using tabs? The age-old question. And the extent to which people obsess over this question really shows in this 2017 Stack Overflow developer survey, where they asked the developers, do you use spaces or do you use tabs? And then they compared it against their annual salary and somehow have managed to show that the people who use spaces seem to earn a lot more than the people who use tabs. Now, the official guide from the Python community is in fact to use spaces. So if you click on this section, tabs or spaces, they tell you in no uncertain words that spaces are the preferred indentation method. And in fact, in Python 3, you can't mix a code file that uses tabs and spaces for indentation in the same file. And it also tells you that in order to indent a line of code, it should be indented using 4 spaces. So 4 hits of the spacebar. Now, for a lot of people, that may seem quite inefficient because I have to hit my spacebar 4 times in order to achieve a single indent. And you've seen how much we indent throughout our code. So it seems very, very inefficient. But luckily, in most code editors, they actually have a setting that allows you to indent using spaces, changing the indent size to 4. And when you hit the tab key, it will automatically insert 4 spaces, which you can tell when you're trying to highlight this space. You can see the cursor is jumping 4 times. This means that you get to hit tab once and that your code is in line with the guidance, because behind the scenes, your code editor is inserting 4 spaces. So I hope that clears up a little bit on tabs versus spaces, and I highly recommend you to head over to the course resources and click on the link to go to the style guide for Python code and take a look through the parts about indentation. Now, in the next lesson, I've got a quick quiz for you to test your knowledge on indentation. So for all of that and more, I'll see you in the next lesson. All right, guys, in this lesson, I want to talk about the while loop, the loop that will continue going while a particular condition is true. This is a really simple version of a robot that's using a while loop. So in this case, the instruction would be while you are plugged into the wall and you have electricity, move forwards. So this is what happens. It will stop once it pulls the socket out of the wall and it stops receiving electricity. Let's compare this against the for loop that we've seen before. So we've seen sort of 2 flavors of the for loop. One where we're looping through a list of items to do something with each item in the list. And the other is using a range function where we create a range between A and B, and then we use every number in that range to do something. For example, in this case, would be to print it out. The while loop looks something like this. And in this case, while this particular condition is true, then we go inside the loop and we do something repeatedly. And it's only when this something becomes false does the loop stop. So let's take a look at what the code would look like in real life. So here I have the hurdle 1 challenge that you did previously. And for this, we created a for loop in order to get our robot to jump over the hurdles 6 times to get to the final destination. Now, we could also do the same thing, but using a while loop. And this is how we would do it. Let's say we create a variable called number of hurdles, and we set that equal to 6 because there are 6 hurdles. And then we use a while loop to loop through these hurdles until this goes down to 0. So we could say while number of hurdles is greater than 0, colon, and then we get it to do something. Well, in this case, what we need it to do is to perform the jump function. And at the end of the loop, just before we go back to the beginning, we're going to decrease the number of hurdles by 1. So minus equal 1. So now let's go ahead and delete this version using the for loop. And in order to better visualize what's happening here, I'm actually also going to add a print statement to print that variable. So now let's step through this. And the first time we enter the while loop, number of hurdles equals 6, 6 is greater than 0, then that is a go-ahead to jump into the loop and execute these 3 lines of code. So now we go in and it performs the jump function. And then once that's done, it comes back, goes on to the next line. Number of hurdles minus equals 1, so 6 should become 5. So now when it executes this print function, we should see 5 printed. So let's move this little pop-up away on the side. And let's keep going. So now it's gone back to the beginning of the while loop and it's testing this condition once more. Is the number of hurdles, 5, still greater than 0? Well, so if it's true, then it goes into the while loop again and performs all of those lines of code. So now it's minus 1 and it should now be 4. And it keeps on going until the point where this condition, number of hurdles greater than 0, becomes false. So now, this is the moment where we're going to subtract a further 1 from our number of hurdles, which is currently 1. So that should take it down to 0. And once that's done, this condition is no longer true. 0 is not greater than 0. 0 is equal to 0, but it's not greater. So now this is false, and we exit out of the while loop and we end our program. This is what the syntax for the while loop looks like. First, we have the while keyword, and then we have some sort of condition that we're going to test. So previously you saw it was number of hurdles being greater than 0. And whenever that condition is true, then it's going to look inside the while loop at the indented lines of code to carry out those instructions, to do this, then do this, then do this. And finally, when it gets to the end of the while loop, it comes back to the beginning and tests this condition again. And if it's still true, then it's going to go through and loop and loop and loop until this condition becomes false, at which point it ends and exits the while loop. So now coming back to our Reborg's world, I want you to click on this drop down and go to hurdle number 2. Now this is a little bit different, and if you want to see the explanation for this exercise, then simply just click on this world info and you'll see the explanation. So essentially, this hurdles race is a little bit different from the last one. Whereas the last one, we knew that we had to always complete 6 hurdles to get to the goalpost. In this case, we no longer know where the flag is going to be. So it could be here, could be here, could be here, etc. And it's going to be set randomly to one of these positions. But what we now get is some sort of condition called at goal. And if this at goal is true, then it means our robot has landed on a flag. But if this at goal is not true, then it means that it's not yet reached the flag. So we can use our knowledge of while loops as well as this condition to use our code that we had from previously to get our robot to complete this hurdle race. So you should still have the code from the previous challenge up, and all you have to do is to think about how you would create a while loop so that when you run this program and the flag is set randomly, so this time it was set to be here, but the next time I run it, you can see it's now set here. It doesn't matter where the flag is, your robot should be able to detect if it's at a flag, if it's at the goal, and if it's not, then it should continue jumping. Pause the video quickly and see if you can complete this challenge, and then come back and we'll walk through the solution together. All right, so first things first, we know that we're going to need to use a while loop. And the condition that we're going to be testing for is this one, at goal. This condition can be true or it can be false. And basically, we're looking to see while at goal is not equal to true. So while our robot is not at the goal, then we want to perform the jump function. So we're going to jump for as many times as is required until this at goal becomes true. Another way of expressing this at goal is not true is to say while not at goal. So this is what they mean by the negation of this condition. Either way of testing this will work. And now if I hit run, you can see that even though we only need to perform one hurdle, as soon as our robot gets here and it checks that at goal is true, then it will stop this loop. But if our loop goes on for much longer, say the goal is over here, then once it reaches here and at goal is still false, then it's going to continue jumping until at goal becomes true. So that required a little bit of mental jujitsu, I think, because this entire condition has to be true, but this at goal is actually going to be false until the moment where we reach the goal. So by adding this not, we effectively flip this at goal. So if it was true, it becomes false. If it's false, it becomes true, in order to continue jumping while we're not at the goal. I prefer this particular type of syntax because it reads more like English. While not at goal, then perform jump. And if it is at goal, then it will stop. And one of the things you might be wondering right now is, so I've learned about the for loop and I've learned about a while loop. And if I can use both of them, why would I choose one over the other? When would I use a for loop and when would I use a while loop? Well, what I would tend to say is that for loops are really great when you want to iterate over something and you need to do something with each thing that you're iterating over. So, for example, if you're iterating through a list and you're saying for each fruit in our list of fruits, and you want to be able to say, I don't know, do something with each of these items in here. For instance, it can be as simple as just printing it. Well, then this will require for loop. You can't do this very easily using a while loop. Now, similarly, we've used the range function, right? So for range from 1 to 6, print each number in the range. Well, this, it's also easier to do with a for loop. Now, you want to be using a while loop when you don't really care what number in a sequence you're in, which item you're iterating through in a list, and you just simply want to carry out some sort of functionality many, many times until some sort of condition that you set. And this is also a good point to mention that while loops are a little bit more dangerous than for loops. Because in for loops, you're setting ahead of time how many times something is going to run. It's going to stop once it reaches the end of the list of items in this case, and it's going to stop once it reaches the upper bound of the range in this case. But for while loops, they will continue running until this particular condition switches to false. So if you have some sort of condition that actually never becomes false, well then your while loop becomes something known as an infinite loop. Because let's say that our while loop tested while 5 is greater than 3, then carry out these 3 lines of code. Well, 5 is always going to be larger than 3. Until the end of time. And so that means your code is also going to run until the end of time, which is probably not what you want in most cases. If instead of saying while not at goal, I said while 5 is greater than 3, then you're going to see this robot perform this jump until eternity. And it's basically going to stop only once it's crashed and it's timed out. Now, every single programmer at some point in their lives will create an infinite loop. Don't worry about it. Just quit the program, restart, and try to prevent this from happening in the future. And very often, I find that it's really helpful when you don't know why you're getting an infinite loop to simply just print out your condition. So in this case, if I printed out 5 greater than 3, then it's always going to print true. And it's never going to become false, basically. In the next lesson, I've got more exercises coming up for you, namely hurdles 3 and 4. So head over there and put what you've learned about while loops into practice. All right, guys, it's time for yet another coding challenge. And this coding challenge is going to put into use what you've learned about while loops, while also testing some of the previous knowledge you got on functions. So I want you to head back to Reborg's world and change to hurdle number 3. And take a look at the premise for this particular race. Essentially, what's happened this time is that the wall placement has become random. So let's say we restart this game. You can see that in this case, there's a wall here, one here, one here, one here. There's 4 in total. But if we try a different version, then you can see that there is different wall placement each time. Not only do we know where the wall is going to be, we also don't know how many walls there will be. So code such as what we did before using a for loop telling our robot to jump 6 times is not going to work. And instead, we're going to have to use the conditions, whether if front is clear, or whether if there's a wall in front, or whether if we're at the goal, and also their negations. So not front is clear, not wall in front, not at goal. See if you can use what you've learned about while loops, as well as your previous knowledge on if statements and functions to complete this challenge. When you have written the correct code, no matter what kind of wall situation or hurdle setup they have, it should always be able to get to the goal. And while I've been looking at this challenge, I know there is a very, very simple way of bypassing this challenge, which is simply to get the robot to go up here and all the way down here, going past all the hurdles. But that's not the point of the challenge. In order to complete this challenge, you must get your robot to follow the path that's set out in the dotted lines, instead of bypassing it and doing something completely different just to get to the final goal. Pause the video, have a think about this, have a read of the world info pop up here, and then think about how you can solve this challenge. So give it a go now. All right, so essentially, if we don't know where the walls are going to be, then we have to test to see if there is a wall in front or if there is no wall in front. And if there is a wall in front, then we're going to jump. But if there's no wall in front, then we're just going to move forwards. And we're going to do this and test this for as long as we're not at the goal. So we're going to need a while loop that's very similar to our previous while loop that I showed you in the demo. While we're not at goal, or rather while this particular condition is not true, then we're going to repeat and loop some lines of code. The first thing we're going to do is we're going to use an if statement to check whether if there is a wall in front. So I'm going to say if wall in front. If this is true, then I'm going to perform the jump function and get it to jump over the wall. But if there is no wall in front, so namely else, well, in this case, we're simply just going to move forwards. And because our jump function is always going to get us to face the right way, which is this direction here towards the goal, then this move forwards by 1 function is always going to take us in this direction. So let's take a look at this code and let's step through it step by step. So the first thing we're going to check is, are we at the goal? At goal is going to be false, so not false is going to be true. So while this condition is true, we're going to carry out all the lines of code inside. So that means we should jump into this if statement and check, is there a wall in front? So at this point, this should be false because there is nothing in front. So it should bypass the if statement and it should go to the else statement, in which case it should move forward by one step. So that's the end of one loop, and we go back to the beginning. Are we at the goal yet? Nope, we are not. But now when we run into our if statement, this check should now come up as true because there is a wall right in front of our robot. So in this case, it's going to go into the if statement and perform the jump function. Now, our jump function that we defined previously actually gets us to move forwards by one step first before we actually hurdle over this wall. So in this case, if we try to do the same thing, then it's actually going to hit our robot into a wall. We have to modify our jump function by removing this first move function. So instead, we get it to just turn left, go up, turn right, turn right, go down, and then turn left to face the right direction. This is a pure hurdle without that extra step in the beginning. And instead, we're going to only move if there is no wall in front. So we've changed the code. Let's back it up and try this again with a different setup. And in this case, you can see as my code is going through the different steps, it's checking to see if there's a wall in front. If there is, then it's going to jump over it. If there isn't, it's just going to move forwards by one step, and then it's going to reevaluate. So this way, once it gets to here, it's actually going to reevaluate the while loop quite a few times, and every time it's going to be the else statement that fires. It's going to move until it hits a wall again, and then it's going to jump over and take us to the finishing line. Did you manage to get this correct? Did you manage to get the solution right? If not, be sure to review the previous lessons on the while loop so that you familiarize yourself with it. And also, if you got stuck on changing the jump function, then be sure to remember that whenever you get stuck, it's important to test your assumptions. And in this case, you could have pressed the step through button many times to see which line of code is being triggered at which point and which is the moment where our code actually fails, so you can figure it out and fix it. Now, on the next lesson, I've got yet another code challenge for you, so head over there and give it a go. All right, guys, it's time for the final hurdle before we get to our goalpost. In this lesson, I want you to switch over to the final hurdle challenge, which is hurdle 4. And in this particular version of the hurdle, the wall that the robot has to jump over to now has a variable height. So the height of each of these hurdles is completely random. The position of the hurdles are random. And also the number of hurdles is also going to be random. You can see that every single time that this regenerates, it comes up with a completely different set of hurdle profiles. And now we can't just jump because we don't know what the height will be each time. So we have to use what we've learned about while loops to modify this jump function and see if we can get the jump to jump as high as necessary depending on the height of these walls. Just as a reminder, in order to complete this challenge, you should take a look at the Rebor's keyboard window and go to this tab called Conditions and see that you can check if the front of the robot is clear, if its right is clear, if there's a wall on the front, if there's a wall on the right, and various other things. The ones that are probably going to be the most useful is this top row here. So we want you to take a look at these conditions, see how they're spelt and how you can use them, and then try to use them and test them out using your Reborg robot. Now the goal is of course to reach this final flag. going over various hurdles using this dotted line as the path, which is going to be different each time. Just as a head up, this is going to require you to modify this jump function, have a serious think about it because it's not easy, and you're going to need to use more while loops to achieve this end outcome, and try to see if you can solve this challenge in the least lines of code possible. So I managed to do it in as little as 24 lines of code, so see if you can aim to achieve that. Pause the video now and give this challenge a go. Alright, so the key difference between this particular hurdle and the previous version is that the height of the wall is now random. Instead of just jumping over one square where we turn left, move, turn right, move, we have to now see if the right side has a wall or if it's completely clear. Now, in this case, what I want to happen is I want to turn my robot to the left first of all, and then I want to check if there is a wall on the right. So I can use this condition, wall on right, to achieve this. And if that is true, then I want to continue moving forwards until there is no longer a wall on the right, in which case I'm going to turn right, and then start going down. So let's modify this jump function. We definitely need the robot to turn left, but after it turns left, we're going to use a while loop to say that while there is a wall on the right, then in this case, we're going to move forwards. So we're going to go up in this direction basically because we've turned left already. Let's test this out and let's run this code. You can see in this version of events, my robot is going to keep going until the very end of the screen. This is not what we want. So what we want to do is when this is no longer true, it's going to skip to line 10. So at this point, there is no longer a wall on the right, because otherwise it would have continued looping and calling this line 9 where it gets it to move forwards. When there's no longer a wall on the right, then we want to do what we did previously, which is to get our robot to turn right, move, and then turn right. Now at this point, we have to move down the wall, and what we're going to check is whether if the front is clear, because it's only when we reach the very bottom here, when the front is blocked, do we actually turn left again and continue back to our while loop here to move forwards. To do this, we're going to add yet another while loop, and in this case, we're going to use the front is clear condition. While the front is clear, we're going to get the robot to continue moving forwards. So once it's turned to face this direction and there's no wall in front, it's going to keep going until this is no longer true. And that is the end of our jump. So now we've basically modified this jump function to take into account all of these new things, such as while there's a wall on the right, then continue moving upwards. While the front is clear when it's coming down, then continue moving downwards. And then at the very end, we're going to get our robot to turn left, so that we're ready to go and check if we're at the goal. And if we're not at the goal, then we're going to check if there's a wall in front. If there is a wall in front, then we're going to jump. Otherwise, we're going to continue moving forwards, or rather to the right, to get to the goal. So now this is the final code. And depending on the number of spaces you've added in here, obviously it's a little bit easier to read if you actually have it like this. But depending on how you've spaced things out in your code, you should end up with anywhere between, say, 20 to 24 lines of code. So I want you to be able to see all of these lines of code on the right when we run this code. And I've actually got a typo in here that it's going to tell me. So it's going to say invalid syntax, and the problem is just because I forgot a colon here. If you get that pop-up invalid syntax, be sure to check if you have any problems in here. And it can get a little bit complicated if you leave your code for a long period of time before you test it. So test your code after every little iteration, and then when you actually get something like an invalid syntax, you'll be able to catch it more easily. So now let's go ahead and regenerate our map, and let's try again. So when we're going to make a jump, and then we're going to turn right, and we're going to keep going down until we hit the wall or we turn left. And now we're not at the goal and there's still a wall in front, so we make another jump and we go down this much, much larger wall. And then we continue this process of using several while loops, checking if there's a wall on the right, checking if the front is clear, checking if there's a wall in the front, in order to achieve our goal and get to our final destination. Now, for your code to successfully complete this challenge, the line that your robot draws should follow the line that's dotted here, just like what you see here. So instead of going just over the top and getting to the final goal, it should follow each of these steps, and finally you should get that green pop-up where it says it's at the right position. So did you manage to complete this challenge? If not, be sure to review the lesson on while loops and just have a play around with while loops. Try some of the different conditions and see what happens when you run the code and see how the robot behaves so that you get a good grasp of how these things actually work. Now, on the next lesson is our final project, and we're going to get our robot to be able to navigate a maze all by itself using what we've learned, including functions as well as while loops, as well as using good indentation. So for all of that and more, I'll see you on the next lesson. All right, guys, it's time for the final project of today. And the goal is to be able to write some code here in Reborg's world to be able to get our little robot to be able to navigate to the goal and go through a maze no matter what the maze looks like. So if you go back to Reborg's world, if you already got a link open, if you don't, then simply click on the direct link in the course resources and it should take you here. And we've got the maze selected in the drop down, which is right here. Here we have a maze. And even though the maze doesn't change, the robot does. The direction that the robot is going to face is completely random. The position of the robot is also random. So you can see every time I restart the game, it will face a different direction. So in this case, it's facing up, but the next time it might be facing down in this case. And it's also always going to start at a random location in the maze. If you click on the world info, it'll tell you that the secret to getting the robot to complete the maze is to get it to follow along the right edge of the maze. If it starts anywhere in the maze and it just continue following along the right wall, it should eventually get to the final destination. For example, like this. Now, in this case, the robot is not making a beeline straight to the exit as if it could see what we can see, but it is following a strategy, or rather what you would call in programming an algorithm. And the algorithm here is to simply follow along the right edge of the wall, and if the right side is clear, then continue going right until it's no longer clear, at which point it should just go straight. And if you can't go straight and you can't go right, then the last option is to turn left. It's almost like the robot is getting a set of instructions in terms of hierarchy. The most important, telling it to turn right if it can. If it can't turn right, then go straight ahead. And finally, if it can't turn right or go straight ahead, then to turn left as a last resort. So you're going to need to use a lot of the functions that you saw previously, such as move, turn left, and testing whether if the front is clear or the right is clear, or there's a wall in the front or a wall in the right, and whether if the robot is at the goal. Think about how you can use a while loop and also the conditional if, elif, else statements to achieve this goal and get our robot to be able to go to the final destination no matter where it starts out and what direction it's facing. Pause the video now and try to use what you've learned to complete this final project. All right, so did you manage to complete this challenge? If not, let's work through the solution together. The first thing we need to do which we've always pretty much needed completing each of these challenges, is we need a way to turn right. So I'm not going to type it all out again. This should be already pretty clear. Turn right is just turning left 3 times. Now, the next thing we need to do is we need to tell the robot to do things and to check for things until it reaches the goal. We know that we have this test called @goal, so we can use a while loop to get the robot to continue working until it reaches the goal. To define that, we could say while not at goal. So basically keep repeating the instructions inside this while loop until @goal becomes true and not true is false. So once this condition becomes false, then our while loop stops. So what we were told in the world info is we should follow along the right edge. We should test to see if the right side is clear, and if it is, then we should turn right and go straight. So that basically means moving right. Let's use an if statement to test if right is clear. And in this instance, so in this if block, we're going to say, well, turn right using our pre-built function up here. And then once you're facing the right, then move forwards. This should achieve a right move. So from here to here, for example. Now let's test this and see what happens. In this case, the right is clear, so it moved right. The right is not clear, so it doesn't know what else to do, and it's now stuck in what we would call an infinite loop. And it will never stop until the browser actually forces it to by crashing. So what we have to do instead is we have to provide an alternative condition. When the right is not clear, what should it do? So we're going to provide that condition by using an elif statement. And what we want to say is, if the right is not clear, well then maybe you should check if the front is clear. And if that is the case, then simply just move forwards. Now this would work unless we're in the situation that we're in right now, where we're boxed in and the only side that's clear is actually the remaining one, which is the left. That's why we have to put in the last line of code, which is going to be an else statement. So in all other conditions, when the right is not clear and the front is not clear, so once both of these have been checked and they're false, then actually just turn left. So now you can see that when our robot is able to go right, it will try to follow along the right wall, but when it can't go right, it'll go forwards instead. And when it can't go right or go forwards, then it's going to turn left, and hopefully the next time it checks the loop, the front will be clear and it will be able to move forwards. So notice how our robot is somewhat haphazardly navigating through this maze, but it is following the algorithm that we specified, which is to follow along the right-handed wall until you reach the goal. And that's what these few lines of code does, using our while statements, our if, elif, else statements, and also our turn right function. Now, while everything seems to work all right, there are select cases where the robot might start at a position and face a particular direction that gets the robot into an endless loop. So here's an example. Let's say the robot starts off at this particular position facing down. If we go ahead and let the robot run the code, you can see that firstly, there's over 1,000 steps in the code. And what happens is, because the robot doesn't have a wall on its right, it's going to keep looping through this circle. Because after all, we're telling it, if your right side is clear, turn right and then move. And the right is always clear when it's inside this boundary box. So depending on where the robot starts out, it might get itself into what we call an infinite loop, because you can see the code just goes again and again through this while statement, and the robot's never going to be able to escape from this position. So this is one of the things that happens to your programs. Sometimes there are edge cases which you might not have thought of, but it's only through testing the code do you discover them. Now, this particular issue, I would say, is more of an intermediate debugging problem. So if you're somebody who's already really comfortable with Python and you want to try out debugging this particular problem, then I've included some problem worlds for you to test your code against. Now, if you are somebody who is still getting to grips with Python, I would say this is not the right time point to tackle this challenge, and I would go ahead and make a note to yourself that once you've completed day 15 and you're firmly within the intermediate territory of Python, to come back to this problem and to continue to debug this particular edge case. Now, if you are a beginner, I recommend to skip the rest of the video, but make a bookmark and make a note here so that you know to come back. Now, if you are more of an intermediate programmer, then let's go ahead and debug this. So what you can do with Reborg's World is you can actually create a file to load up a particular map and robot position. So what I've done is I've created a bunch of problem worlds for you to test your code against that we know if you use the normal code, it's definitely going to get into an infinite loop. So what you need to do is head to the course resources for this lesson and then download the zip file, which contains 3 problem worlds for you to test your code against. And then in Reborg's World, you're going to click on additional options, open world from file, and you're going to select that folder, which hopefully you've unzipped, and go through each of these problem worlds, testing your code in all of the cases. Now, when you open this up, you can close off this box and the robot will start at a particular problem position, facing a direction that is going to cause it to go into an infinite loop. And you can know this ahead of time because when you actually go to start the robot and you hit play, when you can see the number of steps here over 1,000, it usually means that you're probably in a situation where it's going to turn into an infinite loop. So write your code here and then test it to make sure that the step count goes down below 1,000 and your robot doesn't get stuck in this endless circle. Now, because the different problem worlds can have different solutions, but what you're aiming for is one solution code that solves all of the problem worlds, I want you to test your code against all 3 of these problem worlds I've created for you. So here's the time, if you want to tackle this challenge, to go ahead and pause the video and see if you can debug this pretty hard problem. It took me a while, so I think it's going to take you a while as well, but you might be smarter, it might take less time. So good luck, pause the video, and we'll go through the solution together a little bit later on. All right. So first, let's try and figure out what the problem is. The problem here is that every time when the robot's right side is clear, our code tells it to turn to that direction, move forwards, and then check to see if it's at the goal. So it's not, and then again, the right side is clear, so it turns right and moves, turns right and moves, turns right and moves. So basically, in any of these 4 positions, depending on the way it's facing, there might not be a wall on the right side of the robot. So that is the key to solving this bug. We have to get our robot to a starting position where it has a wall on the right side of the robot. Now, I've been thinking about various ways of doing this, and the shortest, most succinct way that's also most understandable, I think, is this. So if we create another while loop before this while loop runs, so remember the code goes from top to bottom, it's going to hit this while loop first. And we check while the front is clear, well then the robot is not next to a wall, right? Such as in this case. Well, if that is the case, we're going to tell our robot to just move forwards. So this means that our robot is going to seek out a wall. So in this case, for example, it's going to go forwards until it reaches a wall. So it's going to loop through that loop twice, and it moves twice until it hits a wall in front. Now this is the point which we want, because we want to make sure that now that it's hit a wall in front, that it's definitely got a wall on the right side of the robot. So what do? Well, once it's hit a wall, so it's exited this while loop, we're going to tell it to turn left. So this loop makes sure that the robot has a wall in front of it, and once it's found a wall in front, we tell it to turn left to turn that wall onto the right side of the robot. So now you can see we're going through this while loop. First, front is clear, so it's going to move. And then front is still clear after that one move, so it's going to move again until it's hit a wall in front. Now at this point it exits the while loop and it goes to the next line of instruction, which tells it to turn left. Now that the robot has turned left, it now has a wall on the right side and it enters the next loop. So in this loop, if the right side is clear, turn right and move. If the front is clear, just simply move forwards. Otherwise, turn left. So as long as the robot starts at a position where there is a wall on the right side of it, right next to it, it's never going to get into that infinite loop with this code. So this is one solution to this problem. Now, there's lots of other solutions, but what you got to make sure is that your solution works in every single one of these test cases. So we can go ahead and open up problem world 2, where the robot starts at a different position, facing a different position, and we want to make sure that still we don't have an infinite loop. In this case, it doesn't, so that's great. And finally, let's test the last one, which is problem world 3. And now we can run our program, and you can see it's also less than 1,000 steps, so it works. So this is a bit of advanced debugging because we're now testing our code against various terrible scenarios where the robot starts off at a position where it's really dangerous and can get into these infinite loops. Now, if you didn't manage to get the solution, don't despair and don't be too hard on yourself. This is a really hard one, and it took me a long time to find a solution that I think is readable and explainable and sort of makes sense. Now, it might be that you should put in a note in your calendar to come and revisit this issue in a week once you've had some time to think about it and to really digest and understand the solution. Then try to write the code yourself, because you will have forgotten exactly what the code was, but you'll still remember how it works. So if that is the case, this is what you should do. If you solved it by yourself, then congratulations. This is really, truly quite a difficult task.
Hey, well done for completing day 6. Now, I remember back when I was learning how to windsurf, just how hard learning a new skill can be. And I think when you become an adult, this is like a really unfamiliar sensation, learning something new. Because more often than not, you're probably working in a job that you've done for years, you've probably gotten really good at it, and you haven't actually needed to struggle to really feel the pain that you feel with learning. And this might be the first time you're doing that for a while. So just as when you get onto a windsurf board and you hit the water a few times really painfully, I just hit my face so many times that you feel like this is too hard. But actually, the struggle is necessary. The more you struggle, the more you're learning. So don't interpret the struggle as a bad thing. It's a good thing. It means that you're making progress. So keep going, and I'll keep practicing my hat tricks.
Hey guys, welcome to day 7 of 100 days of code. Now, today we have a whole day dedicated to a really cool project. And what we're going to be building throughout this day is basically Hangman, or the code equivalent of this game. So the way the game works is you have to guess a word, and for every wrong letter you submit, you end up taking a life away from this little man. And of course, the longer it takes you to get to the word, the more you put your little man in danger. So this is what the final completed project is going to look like. There is a random word that I have to guess, and I'm going to type a letter to see if it's in that word. If it's not, my hangman starts and the little character starts being drawn. But if I do get a letter right, then that process pauses and the letter gets added to the word that I have to guess. And the goal is to be able to guess all the right letters so that eventually you figure out what the right word is. And this is an extremely, extremely difficult game. It took me many tries to get a take where I actually managed to guess the word before the hangman died. But it is quite fun. And you can check it out by simply going to this URL at the top, or going over there through the course resources where there is a link for you as well. But this is what you're going to be building by the end of today. But just by building this game, we're going to be able to review and test ourselves on a bunch of concepts that we've already covered, like for and while loops, or if and else statements, lists, strings, the range function, modules, and much, much more. So I hope you're as excited as I am to get started on this project. And once you're ready, head over to the next lesson and let's begin. All right, guys, so before we get started with our project, it's really important that we're all on the same page and we understand how the code is going to work because we know how the game works. So I recommend that if you've never heard of this game, Hangman, then before you continue to just head over to the Wikipedia article on Hangman, and it might be even easier if you select your own language because I know that it has a different name in different languages. Now, if you've never played this game, I also recommend just to go and give it a go online. So I'll link to this address, and if you click on Single Player Untimed, you can see that you have a word that you have to guess, and then you start picking some letters, and if it's right, then it goes in, and if it's wrong, then the hangman gallows start being drawn, and our little man is at risk of being hung. Once you understand how the game works, it's time for us to examine what the logic for our program is going to look like. And to do that, we're going to use flowchart programming. So it's very simple. It just means that we can draw out a flowchart to represent the logic of our game. At this point, I want you to pause the video and have a quick think about how you would program Hangman. Try and come up with a flowchart that represents the logic of this game. Break it down into little steps. What needs to happen first? What needs to happen when the user makes a guess? And what should happen when the guess is incorrect? When should the game end? Pause the video now, take a pencil and a piece of paper, or use draw.io to create your flowchart. So how did that go? Did you break down the problem? It's really important to say that there's no single right answer here, and there's loads of ways that you could have done this. But let me show you my approach, which is how we'll write our program over the next couple of lessons. So this is what it looks like from start to end. And if we zoom in a bit, let's go through this flowchart step by step so we're all on the same page. At the start of the game, the first thing we do is to generate a random word. Let's say in this case, it was the word mouse. Now, the next step is to generate as many blanks as the letters in the word. So we have these blanks to show the user how many letters are in this word that they need to guess. They don't get to see this, but they get to see this. And the next step, they get to guess a letter. So let's say the user in this case guessed the letter O. Well, the next thing we have to check is the guessed letter actually in the word? Well, in this case, O is indeed in mouse. It's the one at the second position. And so we go down this path and we answer yes to that question. So now we get to replace that blank with the letter O. Now, the next stage is we have to check, are all the blanks filled? Are all of these blanks removed? Because in that case, it means the user has guessed all of the letters correctly. Well, at the moment, it's definitely a no, because we've only guessed one letter. So then we go all the way back to the beginning and we ask the user to guess another letter. Now, at some stage of the game, all the letters will be guessed, and then we can answer yes to this question, which means it's game over. The user has won because they've guessed all the letters correctly. Now, if we go back to the part where we asked the user to guess a letter, and they guessed a letter, say the letter Z, which doesn't actually exist in this word mouse, well then in this case we go down this right path to answer no, and the user loses a life, which means we start drawing out our hangman figure. Now, depending on whether if they have run out of lives, if the hangman has been drawn completely, then they would go down this path, but at the moment they've only lost one life and this figure is not complete, so the answer is no. And that means we go back to the beginning and we get them to guess the next letter. Now, if at the stage where they've exhausted all of their lives and the hangman figure is complete, well then it's the end of the game and they've basically just lost without having guessed all of the letters in the word. So this is the logic, and you might need to come back to this video a few times if you get stuck along the way, just to review how the program flows, but it might also be worth creating your own flowchart or simply downloading this completed flowchart I have here in the course resources. It's a really useful tool to come back to and refer to as you're writing the code, because this will give you an overview of what you're trying to get your code to do. And hopefully this is going to make it easier for you to complete the upcoming challenges in this project. Once you're ready, head over to the next lesson and let's get started. Alright guys, to get started, head over to the starting file in step 1, and we're going to tackle this project in 5 steps. Now, in step 1, you'll see that there are 3 to-dos. So I want you to go through each of them and complete them in the order they're listed, 1, 2, and 3. Now, in PyCharm, there's a really helpful way to view all the to-dos in a particular file. If you go to View and then Tool Windows, and then scroll down to To-Do, and you'll see all the to-dos listed in order in the current file, 1, 2, and 3. Now the goal is to be able to achieve what the solution file does. So without opening the solution file, which you need to double click on, you can also right click on it and run the file without looking at it. Now, once you run it, you can see it's being run down here and it's printed a word. So as we said in to-do number 1, randomly choose a word from the word list up here and assign it to a variable called chosen word and then print it. So there it is printed. And then we ask the user to guess a letter, and that's to-do number 2. And then we have to make the guess lowercase. So let's guess a letter A. And then finally, we're going to check if the letter that the user guessed is one of the letters in the chosen word, and print right if it is, or print wrong if it's not. So it's going through each of the letters in this chosen word, checking each one against the guessed letter. So it's not the first one, but it is the second one. So A does in fact show up here, and then it's also not in the last 3 letters. So this is the goal of step 1, and I recommend you go through the to-dos one by one using everything you've learned in the lessons so far. You should be able to achieve this. If you get stuck, there is a hint down here to tell you how to loop through lists, but we did cover that at one point in the lesson, so you could also go back to that previous lesson where we covered for loops and lists to help you as well. So I'm going to go silent now and let you pause the video and complete this step 1. Alright, so now let's go through the solution. I'm going to collapse everything just so that I have a bit more space to see each of my to-dos. And alternatively, we can also just open up the to-do window. So the first to-do is to randomly choose a word from the word list. So to do that, we need to import the random module. And then using the random module, you might remember that we saw that there was a function called random.choice. And inside here, we need to pass in a sequence. And in this case, the sequence we want to pass in is our word list. So now that we've created a random word from that list, we need to assign it to a variable. And in the to-do, it says to assign it to a variable called chosen word. So we can just add an equal sign between those two things. And now we have set it to this variable. The final thing we need to do is simply just print the chosen word. And that's to-do number 1 completed. Now you might notice there is a yellow squiggly line under the import, and that's because according to PEP 8 and Python style guidance, imports should always be at the very top of the list. But because we've got our to-dos as well, we had it down there, but it would work both cases exactly the same. So now let's tackle to-do number 2, which is to ask the user to guess a letter and assign their answer to a variable called guess. So firstly, let's go ahead and figure out how to ask the user for a letter. So we're going to use input, and I'm simply just going to write guess a letter : space, and then we're going to assign this to a variable called guess. And finally, we want to make this guess lowercase. So we can simply write .lower. Now let's go ahead and print the value of guess and run our code just to make sure that everything works so far as we expect it to. So instead of selecting solution, I'm going to select current file and hit run. So the first thing that prints is baboon, and this means that our to-do 1 was completed successfully because we randomly chose a word from the word list and then printed it out. Now to-do 2 should ask the user to guess a letter and then go ahead and make it lowercase. So we're printing it out just to make sure it works. Let's say I guess the letter, but I type a capital A. Now when I hit enter, hopefully this .lower function will turn it into lowercase, and then it gets stored in this variable called guess, which gets printed out here. Now the reason why we're turning it lowercase is because the user might start off a letter in all caps, or they might use lowercase. But if we were to check against our words in the word list, you'll notice that they're all in lowercase. So if we make everything all the same casing, that makes our lives a lot easier down the line. So we have now completed to-do 1 and to-do 2, and all that's left to do is to-do number 3. So what we want to do is we want to take this letter that the user guessed, A, check it against each of the letters in the word that was randomly chosen, and see if it matches any of these letters. So I would expect the first letter to be wrong because A is not equal to B. The second one, I would expect it to print right. And for the rest of the letters, I would expect it to print wrong. So if you remember, we can use a for loop to loop through things which are in a sequence. And we can do that with lists, but we can also do that with strings. So we can basically use the same for in loop that we learned about previously, where we say for a letter, so this is a variable name that we give each of the letters in the chosen word that we're going to loop through. You can call it anything you want. And then we use in to define what are we looping through. So it's going to be the chosen word. And let's go ahead and just print letter just to make sure this is doing what we expect it to. So let's finish off with the input, and you can see what's happening here is it's looping through each of the letters in this chosen word, which in this case was aardvark, and it's printing it one by one. Now, instead of printing the letter, we want to check to see if the letter is the same as the guess. So if the letter that we're currently looking at in the chosen word, A, is it the same as the guess that the user inputted? Well, if it is, in that case, we're going to print right. And if it's not, so in the case of else, making sure you got it at the right indentation level, notice how if and else are at the same starting line, then in this case, we're going to print wrong. So now let's rerun our code. In this case, the word that was chosen was camel, and I'm still guessing the letter A. Then it goes through this word camel. The first letter is C. C is not A, so that's wrong. Second letter is A, so it's right. And none of the other letters are A, so it prints out wrong. So this was what we wanted to achieve by the end of step 1. Did you manage to get it to work? If not, don't worry, go back to your code, fix it, and as long as you understand what's going on and how the code works in your version, then that is a success in my book. Now, once you're ready, then head over to step 2, and in the next video, I'll describe the steps in that section. So now it's time to move on to step 2 in the 5 steps to create our hangman game. Now, in step 2, I recommend reading through the description for a more detailed breakdown of each to-do, because I don't want to clutter the code file with a bunch of text, but also I need to be able to put the to-dos in so that I can tell you where you need to write each of the blocks of code. So take a look through the to-dos and any hints if necessary. Ideally, if you can create the code for the solution without looking at the hints, that would be great, but the hints are there for a purpose. So if you get stuck, check them out. Now, as always, we're going to start by running the solution code without viewing the solution. And you can see what we're trying to achieve in this step is we've got the chosen word printed. We want to print out a set of blanks because when we actually have the final game, we're not going to show the user the solution. Instead, we're going to show them this is how many letters you need to guess, and we're showing it to them in these blanks, which are basically created with these underscore symbols. Now, the next step is the user will go ahead and guess a letter. And what we want to do in to-do number 2 is to create a variable called display that is going to put the guessed letter into the right position. So you can see in aardvark, we've got 2 A's at the beginning and then an A at this position as well. So we're creating a string where the user guessed letter is put into the right positions of the word, but the unguessed letters are represented by underscores, which will represent a blank for the user to continue guessing. So as we're on step 2, it's getting harder, but hopefully you'll be able to figure out how to do this by looking at the to-dos, the hints, and also using your knowledge of Python. So I'm going to let you pause the video now and try to tackle this challenge. Okay, so the first thing we need to do is to do number 1, and we're going to write our code right here underneath it. We're going to create an empty string called placeholder, so that's quite easy. And we're going to set it to equal an empty string with the double quotes with nothing in between them. Next, we need to create a for loop so that for each letter in the chosen word, we're going to add a underscore symbol to this placeholder. So for example, if the chosen word was apple, then the placeholder will just be 5 underscores. So how can we do that? Well, we learned about the for in range function before. So we could, for example, say for, and at this point you can name this variable whatever you like, but I'm going to call it position. For each of the positions in the range, Now, what is the range that we want? Well, if the word was apple, then we would want that range to be the number 6 because we want this loop to run 5 times. And we know that range goes from the starting point to the end point. So if we wanted to write 1, 6, then go ahead and print this loop has run. And I go ahead and run this current file, you'll see it prints us out 1, 2, 3, 4, 5 times, which means that instead of printing this loop has run, I could assign the placeholder a new value. So the plus equals will add a new letter to that string, and I could add the underscore so that each time the loop runs, we add a underscore to this string placeholder. So let's go ahead and print placeholder and let's rerun this current file. And you can see here we've got our string placeholder being printed out, and it's composed of 5 underscores because our range ran 5 times, between 1 up to but not including 6. So if we want the range to instead run to the number of characters in our chosen word, then all we need to do is to create a word length variable, and we can set it to equal the length of the chosen word. And now if we put that in here as the range and go ahead and rerun this, then you can see that we're getting the same number of times that loop runs as the number of characters in the word. So now we're basically creating this placeholder so that the user can look at this instead of the actual answer and try to guess the letter. Now, if this was at all confusing, do go back and revise the lesson where we learned about the range function in the context of for loops in Python. It hopefully will make a bit more sense, and then you can come back here and fix your code. Now, the next to do is to create a variable called display that puts the guessed letter into the right positions and a blank in the rest of the string. So, for example, in the description here, you can see that if the word was apple and the user guessed P, then this display should put the P letters in the right positions, and then the rest of the positions have a blank. So we're going to reuse, or rather extend, this for loop that we created previously. So we know that we can loop through each of the letters in the chosen word, and if the letter matches the guessed letter, then we'll print right, otherwise we'll print wrong. But instead of printing right and wrong, what we want to do instead is to create a new variable called display and set this to equal an empty string. Now, if in our loop we check the current letter and it's equal to what the user guessed in their input, then we're going to take this display and we're going to use the plus equals to add the current letter that we're looping through to this display. And if the letter is not a match, then we're going to take the display and we're going to give it an underscore instead. So now if I go ahead and finally print out the final value of display at the end of the running of this loop, then we can see it in action. So the current word that's being chosen is aardvark. This is the placeholder being printed out with the number of letters in that word. And then we're asked to guess a letter, so I'm going to guess A. And then you can see that for each time this loop runs, we'll loop through the first letter in the chosen word, A. Is it equal to the guess letter? Well, it is. Well, in that case, we're going to add that letter to the display, and that's how we have this first A. Now, when we loop to this R, so this letter is equal to R, is the letter equal to guess? No, so it's going to trigger the else, and in this case it just adds an underscore to that string display instead. And by the end of this entire process, we end up with the display showing the letters which were correctly guessed and blanks for the letters which were not. So that's all there is to it, to the 2 to-dos in step 2. We're now creating the basis of our game that we're going to build on in future steps. So hopefully that made sense. If it didn't, as always, go and fix your code and make sure you understand what's going on before you proceed. Otherwise, I'll see you in the next lesson. All right, so now that we've reached step 3, we are moving onwards and upwards. And we're going to add a little bit more functionality to our hangman game so that it functions more and more like a real game. So in this particular step, we're going to add the ability for the user to continue guessing again and again, repeating the hangman checks until they get all the letters in the word. So if you go ahead and right click on solution.py and then run that solution, we can see what the end result of this step will look like. So we have the chosen word, we have the number of characters in that word, and then we are asked to guess a letter. So if I start from the beginning and I guess C, now what we want to happen is this. We're getting another opportunity to guess, and we want this to repeat by writing a while loop in our code. So that's to-do number 1. Now the next thing we want to do is to update this for loop here so that if we guess a previous correct letter, such as the C in this case, when we guess another letter correctly, we want to keep the previous correct guess and the new letter and add all of that to our variable called display. Now, in contrast, let's take a look what happens at the moment if we use our current state of our code in main.py. So if I guess A and all the A's in aardvark gets filled in, the next time that I guess this word, my previous ones will be lost because I'm again checking against the current guess. So think about how you might solve that, and if you get stuck, there's always hints in the description box for you. But there is quite a bit of thinking and quite a bit of struggling in this particular program that you're writing. But as always, it's really good when you struggle because that means you're learning something. If you're not struggling at all, then this part is probably too easy for you and you need to skip ahead quite a few days. But if you are struggling, then that means you are at the right stage in your programming journey and you will eventually get to where you want to be. So I'm going to go quiet now and let you have time to think. So pause the video, read the description, try out the solution, run, and see if you can figure out these 2 to-dos in step 3. All right, let's go through the solution. Now, if you haven't attempted to solve this, I recommend to stop and don't watch the solution just yet. It's only worth watching the solution if you've actually tried, at least for 10-20 minutes, because otherwise the solution is just going to be somebody reading to you a bunch of code and you won't do any learning. And I'm really, really against this idea of spoon-fed education where we're just told what the answer is, because without the thinking phase, we're not truly learning. We're just repeating somebody else's thought. And the most important thing to learn is how to think. That's what a really valuable programmer's skill is. Okay, so I believe you. You've already tried it. Now let's see if we can go through the solution. So the first step is to use a while loop to let the user guess again, because at the moment, once they make this one guess, then everything continues and we are at the end of the script. Now, how do we make them guess again? Well, we would need a while loop. So while some condition is true or while some condition is false, then we want to continue running a block of code. And then when that condition switches, we skip out of the loop and we continue in our code. So what is going to be that condition? Well, we can have a condition called game over, and we can set that to false. Now we can check for that condition. We can say while not game over, so while game over is false, we want the user to make some guesses, we want to update this display, and we also want to do the rest of the code because we need to check through the letter of their guess and see if we can update the display, etc., etc. So all of the rest of the code actually go into the while loop, and by go in, if you remember, it means that they get indented one step so that they're inside this while heading. Now, when do we actually change the while loop so that they can come out of it? Well, if we have these blanks in our display to represent the unguessed letters, if all the unguessed letters are guessed and there are no more underscores, well then at that point, that's when our game is over, right? So let's add an if statement and check if display, and there's a really useful function in Python which is called in. And what we can do with in is we can check to see if something exists in something else. So we can say if this underscore is not in our display variable, so this string does not contain any of these underscores, well at that point they've guessed everything because there's no more blanks, they've guessed all the letters, then at this point we can print you win. And that's also the right time point when we can change our game over so that we set it to true because they've won, therefore game is over. Now we're going to define other conditions for game over later on, but for now, at least we have one place where our code can exit the while loop, which is really, really important when you're writing while loops, because otherwise you get into this infinite loop situation and that's not good. So let's test our first to do and see if it does what we expect it to do. So aardvark, let's guess the letter A. A gets filled in and then it's asking us guess another letter, right? So let's keep typing because we know what the word is. But now we encounter another issue because notice how the R is being placed into our display variable and the rest of them are filled in with blanks. But our previous guess, the A, has disappeared from the display variable and it's replaced by blanks. So in this particular situation, we'll never get to the state where there are no more underscores in the display because each time this while loop runs, we're only ever checking one letter, which is the current guessed letter. So to fix that, we have to go into to do number 2 and change the for loop so that we can keep the previous correct letters in the display string. So how do we do this? There's many ways of doing this, and one way of doing this is simply by creating a list. Now notice I'm going outside the while loop to create this list because I want this list to accumulate while the loop runs so that each time it's not being wiped blank. So if I create a new list here, which is called correct letters, and set it to a blank or a empty list like so, if this was placed inside the while loop, then every time the loop repeats, that list is going to be wiped to 0 because of this part here in this line. So instead, we want it to be outside the while loop. And now what we're going to do is if the letter that we're looping in through the word is matching the guessed letter by the user, then not only do we add that letter to the display, but we also add that letter to our list of correct letters. So correct letters.append, and we're going to append this current letter that we're looping through. You can also append the guess, but at this point they are exactly equal, so it doesn't really matter which one you choose. It just depends on which you think is more readable. Now, if we rerun this code, it doesn't really change much, right? If I change a letter, it's still not doing what I want. So what I have to do also is probably add another check. So I'm going to check another condition using an elif. So if the current guess matches the letter that we're currently looping on, then we add the letter to the display. And if it doesn't match, then we add an underscore. But there's another condition we need to check. We need to check elif, the current letter that we're looping in, is in the list of correct letters. Because remember, if on a previous run of the while loop, a letter was guessed to be correct, then it gets added to this list of correct letters. And so now, whenever we check our letters and we want to fill in the other letters in the display, we need to make an elif. So in this case, what are we going to do? We're going to add the current letter to the display. So similar to this line here. So now, if we rerun this code, and we add a letter. So now B has been added to the display. Let's try N. So you can see now B is added, but N is also added. So the flow goes like this. The for letter in chosen word, the first one that gets turned into a letter is B. So we're checking, is B equal to the guess at this point? Yes. So then we add B to the display and we add blanks to the rest of it. Now then the correct letter is added to this list. So B now lives inside this list. And notice it's outside the while loop, so it doesn't get modified when the while loop repeats from the top of the block of code. So the next time this runs, we're guessing a different letter. We're guessing N. So when N is true, then we are adding N to our display. But when something else is not, one of the letters that we're looping in is not matching guess, for example B, but it is in fact inside the list of correct letters, then that letter also gets added to the display. And this might be something that you want to try and run in Thonny if it is confusing. But if it all makes sense, then feel free to continue to the next step in the game. So now we're inside step 4, so we're almost there at the end now, closing in on the finish line. So there are 3 to-dos in this step, and you'll notice that when you look at the starting file, I've got the different stages of Hangman as ASCII art for us to be able to use. And they go from 6, so which is the start of the hangman with no man, all the way down to 0, where the art is complete, and that's when the user would be in game over status. And we're going to combine that, among other things, into our game. So let's first take a look at a run of the solution. So this is what we're aiming to achieve by the end of this step. So we want to be able to guess a letter. And you'll notice that when you guess a correct letter, then the hangman art does not progress. So if the word is baboon, I guess B, then there is firstly art with no man. And then if I guess another correct letter, you'll see the art doesn't change. It's still just the rack. Now, if I guess a incorrect letter, let's try F, you'll see that the hangman picture starts appearing. And if I keep guessing incorrect letters, you'll see that the person is slowly being drawn until we get to the very, very end, where we end up with the complete image, which is image 0 in our list called stages. And at this point, we get the message, you lose. So that's all that we're trying to achieve in this particular step. And if you take a look in the to-dos, either in the description, now that this is updated, or in the main.py, you should be able to see the individual steps which you have to go through. So to-do number 1 is to create a variable called lives to keep track of how many lives the user has left. They start out with 6, And once that reaches 0, then the game should stop and it should print you lose. So how does it go down to 0? Well, every time the user guesses a letter that is not in the chosen word, then we have to reduce their lives by 1 until eventually at some point it'll reach 0 and they lose. Now finally, we're going to incorporate the ASCII art from this list, which is called stages, that I've added in the starting file for you. And you're going to print it out so that it corresponds to the current number of lives the user has remaining. And you might want to print out the stages using different indices or different positions to pick out different pictures and just get a feel for how they're ordered. So that's all there is to it. And if you're ready, then go ahead and pause the video now and attempt step 4. All right, so let's start from to-do number 1. This is probably the easiest to do out of this whole project. Create a variable called lives and set it equal to 6. That's it, to-do number 1 done. Next, if the guess, so the current letter that the user has guessed based on their input, is not a letter in the chosen word, so it doesn't exist in the chosen word, then we need to reduce lives by 1. Now, you might remember that we have this if, elif, else statement here that checks to see if the guess is equal to the letter in the chosen word. So by looping through each of the letters and one of them matches the guess, then this section does correspond to when the letter is in the chosen word, but it does not correspond to when the letter is not in the chosen word. So the situation where the user has guessed the letter that does not exist in the word. So rather than targeting the elif and else or messing with this if statement, we can actually simply just write a completely separate statement so that we keep our logic separate and under different banners, and it will probably be easier to debug as well. So we can use the not in keyword. So we can say if the guess is not in the chosen word, then under this condition, do we reduce the number of lives minus equals 1, and then if at this point, after we've subtracted 1 from lives, if lives is now equal to 0 at this point, well then that's game over, right? So we set game over to true, and that means we break out of our while loop. And in addition, we're also going to tell the user that this has happened by telling them you lose. So that's to-do number 2 tackled. Now the final to-do is simply just to print the ASCII art from this list corresponding to the current number of lives. Now, very helpfully, I've ordered the art in this list so that they correspond to the number of lives. So it starts out at 0, of course. This is what the picture should display when the user has 0 lives. And also it goes all the way up to 6, so that when the user has 6 lives, full lives, then you don't see the man at all. So that means it's as simple as simply getting the right indentation, so being inside our while loop, because we want to print these ASCII art each time the user makes a guess. And then we simply use the print statement to tap into that list, and then use the square brackets to choose the correct index or the correct position for the art we want to display. And as I just mentioned, it's matched to our lives situation. So that's all that we need to do in order to complete this to-do. And now if you run this code, you'll see that as long as I keep guessing the right letter, my art remains on this particular picture, which is corresponding to lives equals 6. And then as I make incorrect guesses, then my hangman picture starts progressing all the way until I end up with no lives, which is the last picture here, lives equals 6, and I get the you lose printed out. So did you manage to solve these steps? I would say this particular step is probably a little bit easier than some of the previous ones, but as you've noticed, the difficulty can vary in this project, and I just want to guide you from step to step, making sure that each to-do and each of the step codes actually makes sense. So if there's something you realize about previous steps that doesn't make sense, go back and rewatch it, and just make sure that all the code that you see at this stage makes perfect sense to you and that you would be able to write it from scratch. All right, we are very much now in the home stretch. We are on the last step, step number 5 of 5, and we're going to complete this game in this lesson. So when you open up the starting file in the main.py, you will notice that there are a bunch of errors, and this is intentional. Now, what's happened is I have deleted the list called stages. I have deleted the list called word list, and instead I want you to get them from these files, hangman art and hangman words, just so that we can practice using other modules. And this is something we learned in previous lessons as well. So if you forgot, then take a look at Python modules when we introduced the random module. So that tackles to-do number 1, to-do number 2, and to-do number 3, which is to basically use what you've learned about import and modules in order to bring in those things that we need for our code to function correctly. Now, the next few to-dos are mostly to do with tidying up the logic and also just making our app a little bit easier to use. You'll notice I've added some extra bits in here, like some asterisks, just to make each section when they lose or when they win a little bit more obvious. And in step 4, I want you to give the user some feedback to improve our user experience. So if the user has entered a letter that they've already guessed, we need to tell them we already guessed this, and we'll print that letter and let them know. But we're not going to deduct any lives because I think that's maybe a little bit unfair. So an example is you've already guessed letter A, something like this. Now, to-do number 5 is on a similar vein. If the letter they guessed is not in the chosen word, we're going to print it out and let them know, so give them some feedback. For example, you guessed D, that's not in the word, you lose a life, just so they know exactly what's going on in the game. And the final to-do number 6, is to update this print statement so that we give the user an indication of how many lives they have left. So it'll be 4 out of 6 lives left, then 3 out of 6 lives left, so that each time we rerun our while loop, they know how close they are to the end and give them a little bit more danger and anticipation. So these to-dos are a lot easier than previous ones, and I think you'll be able to tackle them just fine. So pause the video and complete your project. Okay, let's start with to-do number 1. So you might remember that we can simply import any module, and this module is called Hangman Words, and it looks like this. It contains just a single list called word list. So we can do it in 2 ways. We can do it the usual way, which is how we imported random. So we import the module, which is Hangman Words, and then we can use it inside our file. So here, when we're using word list, to get rid of this red underline, we can say Hangman Words dot word list, and then Python will be able to find this file because it's imported and then find this word list that we need. Another way of doing imports is a way where you can avoid using these dots and makes the code just a little bit tighter. So instead of just writing import Hangman Words, you can say from this module called Hangman Words, import this one thing, which is the words list. Now, of course, if you have lots of things to import from a particular file or module, then this is going to be a little bit painful. But in our case, when there's only very few and we only want to import one or two things, then this syntax can make it a lot lighter. And it means we don't have to write hangman words.wordlist every time we want to use it, which can be a bonus. Now, of course, you might not have seen it this way, so if you complete it the other way, it's also perfectly valid. And in most situations, that's exactly how you want to do it. All right, let's go ahead and knock off to-do number 2 and to-do number 3. So to-do number 2, we just need to do the same thing and import. So from hangman arch, we're going to import the list called stages, and then that gets rid of that error right there. And then to do number 3, we need to import the logo, which we've got right here called logo. And this just means that when we start up our game, it will display a nice little logo. So we'll just print, and we're going to print the logo, and then we're going to import the logo. So we can also add a new from whatever, but it's actually much easier to add a comma and just add logo afterwards. So this way you save yourself a little bit of code. But if you wrote it like this, hangman_art.logo, that is also perfectly valid. Now, step number 4 is when the user has entered a letter they've already guessed, we're going to print the letter and let them know. So this is the example, and I'm going to use it. So if the guess, so the letter that we're guessing right now, is in, so the in keyword, to check if it exists inside the set of correct letters, well, then that means that they previously already guessed that letter. So we need to let them know, print, that they've already guessed that letter. So we can copy this line and paste it in here and use a F string to insert the guess right there. So now if we go ahead and run our file as it is, you'll see firstly we get our nice little hangman logo printing, and I've got the chosen word still printing right now because otherwise it's impossible to test this. I'm not good enough at hangman to be able to do this. So we've got our word to guess, and then we have to guess a letter. So I'm going to guess R, and you can see if I guess R again, I don't lose a life, and it just tells me that I've already guessed R. So that works as expected. Moving on to the next to do, if the letter is not in the chosen word, then we're going to print it out and let them know. So it's important to give user feedback because that improves the user experience. Now, there's a lot of science and art to user experience, but it's good to start thinking about this even as we're learning the basics of Python. So if the letter is not in the chosen word, so that is under this if statement, then we're going to reduce their lives by 1, but we're also going to add this print statement. So I'm going to copy the example as it is, and then I'm going to paste it into this if statement and replace this with an F string, which is the guess. And very thankfully, Python automatically adds this F in here because I'm using PyCharm, and it's a really, really helpful code editor. But just be aware that that's what's happening just now. Moving on to do number 6, we're going to update this part, this print statement, to tell the user how many lives they have left, so that each time the while loop runs, they can see how many lives they have left. 4 out of 6, 3 out of 6, 2 out of 6, give them a little bit of feeling of impending doom, as any good game should do. If you play Elden Ring, you'll know what I mean. And inside here, we're going to insert the variable called lives. And again, this should be an F string. And we only have one more to do left before we finish this game. So update this last print statement to give them the correct word that they're trying to guess. It's never good to frustrate your users too much. I'm looking at you from software, the people who make Elden Ring, and making it really difficult to pass all the levels. But here we want to be able to give the user the word that they've been trying to guess all along. So even if they don't get it and they lose, they at least know what it was. So we're going to again insert this as an F string, and I'm just going to copy the format here in the to-do, telling them that it was this particular word, replacing this with the f string, and my variable is called chosen word. And now I have completed the entire project of Hangman. Now, I'm not saying that there's no more improvement. There's a lot of things that you could do to improve Hangman, and this is by no means a fully fledged game. It is just a exercise to be able to test and revise some of the concepts you learned about Python up to this point. And hopefully it was fun building it, and hopefully you're going to have some fun playing it and showing it to friends. Now, there are a ton of more improvements that you can make to this game, and if you're up for it, then you can of course go ahead and make it to your heart's desire, change it or update the user experience, change the wording, give it more functionality, different functionality, whatever it is you want to do. The world is your oyster. But hopefully you've managed to understand all of the code up to now. And if you don't, just try deleting everything and starting from the beginning until you make sure that every single concept in here that you've reviewed, either you've gone back to previous videos or you've looked up documentation, as long as everything makes sense before you proceed. I know it's really tempting to keep to the one day a day kind of format, but the more important thing is that you're actually learning valuable skills and you're not just skipping ahead. So I hope this was fun, and I hope you'll look forward to building more stuff with me in future lessons. But right now, take a rest, and well done.
Hey, well done for completing day 7. Now, you've come a long way since the very beginning, and you've been here long enough to know what the drill is. You just got to keep showing up, keep doing the days. But don't worry if it takes you longer than one day to complete one of the days in the course, because you might have kids, you might have a really demanding pet, you might have a really difficult job. And in fact, I was learning iOS development while I was working as a doctor. And I had to do that after I came back from a night shift. And it just was so hard when my brain felt like mush and I was so tired. But the important thing is that you're putting in that daily repetition, that you're doing it continuously and you're not spending a long break in between each lesson, because this way the content can feel fresh in your mind when you come to it. So don't worry if each day takes you 2 or 3 days to do, just keep going. It's a whole linear calendar. It's a whole linear process. As long as you follow the order, you'll get there eventually. So keep going, take a break, and I'll see you tomorrow.
Hey guys, welcome to day 8 of 100 Days of Code. And today we're going to be looking at functions that allow you to give them inputs. And once we've learned all of that and we've grasped it, then we're going to be building a cipher program. And the cipher program is called Caesar cipher. So Caesar cipher is a really quite ancient type of encryption. So the story goes that when Caesar wanted to send highly sensitive military messages, he would encode his message so that each letter would be shifted by a predetermined amount. So let's say that we wanted to encode the letter A and we shift it by 3. Well, then A becomes D, B becomes E, and so on and so forth. And this is what the final version will look like. Let's go ahead and encode something. So I'm going to type encode to start encrypting a message. And then I'm going to type my message with no spaces in between. And then I'm going to give it a shift number. So this is going to be a number that the recipient and I are going to agree on so that we know how to decode the message. Let's put that at 9. And then it's going to give us the encoded results, which is something like this. And this will be the message that I'm going to transmit to my friend, either through a letter or through an email. And it means that whenever somebody comes across this message, they won't really know what's going on unless they knew the shift number. So let's say that I am my friend. I've just received this message and I'm going to go ahead and type yes to go again. And in this case, I'm going to decode instead of encoding. And then I'm going to type out the message from previous and hit enter. And of course the shift number is 9, and now I have the decoded result, which I can read and understand. By the end of today, you would have learned about functions with inputs. You'll know what the difference is between arguments and parameters. Once you're ready, once you're loaded up on coffee, then head over to the next lesson and let's get started. To get started, we're going to learn more about functions. And previously we learned that functions are a really handy way of taking a complex set of instructions and packaging them together inside a block of code that has a name given to it. And when we need all of the lines of code that's packaged inside this function, all we have to do at any point later on in our code is just to call the function by typing its name and then a set of parentheses. And when this line of code is run, it's going to search for where this function is defined, which is up here, and then it's going to execute all the lines of code that are contained within it. Now, it's been a little while since we've seen functions, so to begin, I want you to create a new function called greet, and I want you to give it 3 lines of print statements telling it to do 3 things. And finally, once you're done, go ahead and call the function so that it gets executed in the console. So pause the video and give that a go. Alright, so to create a function, we of course need the def keyword, and we know it's a keyword because as soon as we type it, it changes the color. And after the keyword, we get to give our function a name. So in my case, it's called greet. Now after the greet, we add a set of parentheses after the name of the function. Finally, we add a colon and we enter into the block of code because we're indented over. Now, the first thing I'm going to do is to create a print statement that just says hello. And then I'm going to say, well, how do you do? Now, nobody in England actually says this, but I always see it in the Learn English books, which is quite funny. I think people will give you very strange looks if you go to somebody at the bakery and say, well, how do you do? But anyways, now finally we're going to add a final print statement, keeping in line with the Britishness of my function. I'm going to ask about the weather. Now this line, on the other hand, is something that you will often hear British people say. They're obsessed about the weather, mostly because it's terrible all the time. So now that we've created our function, it's time to actually trigger the function, or what we say in programming lingo, call the function. And we do that by calling the name of the function and then adding a set of parentheses. And now, once the code reaches line 6, it's going to search for this greet function, which you'll find over here, and then it's going to carry out each of the lines of code one by one. So let's run the code, and you should see each of the 3 print statements being called. So that's pretty simple. Notice that every single time I call the greet function, it's going to do the same thing, right? It's just going to print out those 3 lines of code. Now, in reality, it's very rare that you'll want to repeat the same instructions every single time when you call a function. It would be nice, wouldn't it, if we could modify some of the parts of the code inside the function and allow for a little bit of variation. For example, it would be nice if we could greet somebody by their name, so they could say, hello, Angela, instead of just hello, how do you do, Angela, so that it could change each time I call this function. Maybe next time it'll be, how do you do, Jack Bauer, etc. So how can we achieve this kind of functionality? Well, we need to look more closely at these parentheses. Now, what we can do is we can actually add the name of a variable inside those parentheses to start giving our functions some inputs. So let's say that there's a variable called something that's going to be passed to my function. And this something can then be used inside this block of code, this function, and I could do something with it. Now, in order to actually pass this value when I call my function, I have to add the data inside the parentheses. So let's say I decide to pass 1, 2, 3 over. Well, in this case, when this line of code gets triggered, the computer is going to search for where this function is declared, which is up here, and then it's going to pass over this piece of data, 123, over to this variable called something. So now, effectively, inside this function called myFunction, we now have a variable called something that's equal to 123. And that can then be used inside the block of code to do something with that piece of data. Now, it's a bit like plugging a USB stick into a computer. If we took a different piece of input, we would end up with a different file being shown by the computer. So this means the computer can do something different depending on the input that we give it. And if we change that input, then it will receive a different piece of data. So in addition to a simple function, we can also create a function that allows for input. And to do that, you saw earlier on, the syntax is again the same as before. We use a def to create the function, and then let's just give it a slightly different name to differentiate it with the previous function. Greet with name. And then inside the parentheses, instead of leaving it blank, we get to create the name of the variable that's going to be passed over. So let's just call it name, because that describes the data that's going to be received. It's going to be the name of the person that I wish to greet. So now let's add a colon, and finally we can create our print statements. So I'm just going to copy these print statements from above. And now, instead of having these names hard-coded in here, I'm going to delete it and I'm going to replace those names with the value of this variable. So I'm going to put it in using an F string like this, and then I'm going to do the same down here. When we actually call this function, it's also going to be a little bit different from previously on line 6. So now, firstly, the name of the function has changed, but notice how it's expecting some sort of input inside the parentheses, and it tells me that it wants to receive a name. It's when we call the function that we actually pass over the piece of data that's going to be stored inside this variable. Let's give it my own name, Angela. And now when I hit run, I want you to predict what's going to happen, what's actually going to be printed. So let's go ahead and comment out the previous line of code and now run our code. And you should see that it says, hello, Angela, how do you do, Angela? So this piece of data has basically been inserted under this variable name, and then it's been put into both of these print statements. Now, if I go ahead and call this function with a different piece of data, say a different name, then it's going to use that piece of data to modify this function so it does something a little bit different. So this way we can create one function that carries out some instructions, but every time we execute it, we get to modify it a little bit by changing the inputs. When we're talking about functions with inputs, there's two things that we're working with that's really important to differentiate. So we know that when we call this function and we pass over this piece of data, effectively we're creating a new variable called something, and we're setting it to equal this piece of data that we're passing in. Now in programming lingo, you'll hear this being referred to as the parameter, and this piece of data being referred to as the argument. Now the argument is the actual piece of data that's going to be passed over to this function when it's being called, whereas the parameter is the name of that data, and we use the parameter inside the function to refer to it and to do things with it. Now, very often on the internet, when you come across somebody explaining something, be it on Stack Overflow or in some piece of documentation, you'll hear them referring to these two types of things, the parameter and the argument. So if you need to, come back to this lesson and remind yourself the difference between those two things. The parameter is the name of the data that's being passed in. The argument is the actual value of the data. Now, sometimes people also get confused on the internet between these two words, but as long as you know what they mean, then you'll be in a good place. In the last lesson, we saw a very simple form of a function that allows for an input. Now, in this lesson, I want to take it even further And I want to create a function that allows for multiple inputs. So let's comment out the previous line of code and let's create a new comment, functions with more than one input. And I'm going to create a new function called greet_with. And in this case, it's going to take two parameters. It's going to be name and location. If you remember, this is how we added a parameter previously. Now, as a challenge, I want you to quickly think about how you might add two parameters. One's called name and one's called location into this function declaration. Pause the video, have a brief think, and then we'll go through it together. All right, so we know that if we wanted to add one parameter, name, then this is how we would do it. We would just add it inside the parentheses. Now, if we want to have more than one parameter, all we have to do is just add a comma and then add the second parameter, which we said was going to be called location. So now this particular function is going to take two inputs, the name and the location. And then inside this function, we're going to use the name to print something like hello, name. And then we're going to print and ask them what is it like in their particular location. See if you can modify this to use the actual parameters and to replace them with print statements so that we use these parameters inside our function. Pause the video now and give that a go. All right, so essentially we want to create a print statement here, and print statements print strings. So we have to add some quotation marks around that text. And then finally, I'm going to use a f string to replace this parameter name inside this string so that the data that gets passed in gets replaced here and it says hello, whatever their name is. And then I'm just going to do the same thing over here. And notice that you can simply highlight a word or highlight a sentence and then use the open curly brace to actually add the brace around both sides of the word. And you'll notice that I did the same thing with the quotation mark. So highlight the whole sentence and then hit the double quote key and it will keep adding quotes around both sides of your highlight. But I only actually need one. So that is our function completed. And now it means I can call this function by calling greet_with, and it's going to prompt me to add both of these inputs. And the first piece of data is going to be the name. And let's put Jack Bauer. And then we can add the second piece of data and separate it with a comma. So let's say that Jack Bauer is nowhere. Now, if we go ahead and run this code, then you'll see that it's going to print hello and replace name with Jack Bauer. And then what is it like in nowhere? So nowhere gets replaced with this location. So that means that you can now put in as many pieces of inputs as you want and modify the functionality of your function to make your function do different things each time. Now, here's a question. What happens if I call the same function greet_with, but I switch the order of the data that I give it? So let's say the first piece of data I give it is nowhere, and then the second piece of data is Jack Bauer. So we've just switched the order of these pieces of data. Now, what do you expect to happen? Pause for a moment and have a think about what you expect to be printed in here, and then continue. All right, so let's click run and you can see that it's now complete nonsense. Hello, nowhere, what is it like in Jack Bauer? And what's actually happened here is it takes the position of the data, looks at both of these arguments, and the first argument gets assigned to the first parameter, the second argument gets assigned to the second parameter. So in this case, when it's actually gone in here, name is now equal to nowhere, which is why this line printed this, and Jack Bauer is now assigned to location, which is why it printed this second line, like so. And in Python programming, this is called a positional argument, because when we call the function, we haven't specified anywhere which particular parameter we want to associate these pieces of data with. So it's just gone and looked at the position. Now this is the default way of calling functions, because on one hand, when you're typing out the code, you get the hints here as to which piece of data you need to enter, but also you can refer to the function and look at the order of the parameters. Even if we had more inputs, let's say in this case we had A, B, and C, and we put the arguments 1, 2, and 3, then it means that our variables that gets created will be A equals 1, B equals 2, and C equals 3. Now, if we switch around the order of the arguments in the function call, now what will happen is A is going to be equal to the first argument. So A is now equal to 3, B is equal to the second argument, and C is equal to the third argument. So it might be doing slightly unpredictable things in here. So whenever you're creating code and you're using these positional arguments, and you're just inserting the data one by one like this, and it does something completely unexpected, then be sure to check your positioning and to make sure that it matches with the position of the parameters. Now, what if you wanted to be more clear when you actually call the function so you don't ever encounter this problem? Well, you could use something called keyword arguments instead. So now, instead of just adding the arguments into the function call like this, we can actually add each of the parameter names and an equal sign to say that the first parameter A should be equal to 1, B should be equal to 2, and C equals to 3. And now, when we actually change the order around, it doesn't matter how we order it, it's still going to abide by these bindings. So C will still be 3 and A will still be 1. As a challenge, I want you to take this previous function, greet with name and location, and I want you to call this function down here. But this time, instead of using positional arguments, I want you to use keyword arguments. So pause the video and try and give that a go. All right, so when we call the function, we still use the name. So it's greet with. So everything up to the first parentheses is the name. And then we add in each of these parameter names. And then we add an equal sign. And finally, we give it the actual value. So let's say Angela, and then the location is going to be equal to London. Now, when I hit run, you can see it does pretty much the same as before. It puts Angela into name, London into location. But this time, if I switch the order around, it no longer matters. And when I hit run again, you can see it does exactly the same thing, because it now knows which argument is associated with which parameter. So this can make your code less error prone, but it does make each line of code longer. I recommend using your judgment to figure out when you want to use which type of argument. And depending on the need, you can pick between these two. Now, in the next lesson, I've got a coding exercise for you to put into practice everything that you've learned so far. Head over there when you're ready, and let's give it a go. All right, it's finally time to tackle our final project, the Caesar cipher. As I've mentioned before, Caesar cipher is this way of encoding text that was seen as early as during the times of Julius Caesar. So when he had these top secret military messages, what he would do is he would shift each letter of the alphabet by a certain predetermined amount. I want to show you quickly how this works. So we've got the alphabet here, and let's say we wanted to encode the letter E. So now we can line up the alphabet with a new set of alphabet, and at the moment the shift is 0 because the top alphabet and the bottom alphabet are lined up with a 0 difference. Now let's say that we had a shift of 1. Well, then the alphabet moves to the left and A becomes B, B becomes C, etc. And we can keep going until we get to the amount of shift that we wanted. So let's say we're going to encode all of our text with a shift of 3. Well, then E becomes H, F becomes I, G becomes J, etc. and so on and so forth. And they've actually discovered these artifacts from ages ago where people have created these sort of dials. And by simply rotating the dial to a certain amount of shift, then you can line up the letters with each other. So A becomes N and Z becomes O, and so on and so forth. And this is a way that people actually encoded top secret messages. By the end of this day, you have also built a digital form of the Caesar cipher. And all you have to do is to type encode to start encoding a message. Let's say something like, hello world. And once we hit enter, we get to type the shift number, which I'm just going to choose a random one, and it gives us the encoded result. So now if I take this encoded result and I go ahead and type yes to restart my program, and I'm going to use the decode function to decode my message. Now, when I use the same shift number, then I should be able to get back the decoded result. So if there's people monitoring your phone, or you're trying to throw a message to your friend in a paper ball, then this is an easy way to ensure that if your message was intercepted, then it won't be understood by the other person.
All right, so once you're ready, let's get started building out the Caesar cipher. Now, you'll notice that I've split it into 3 parts. So 3, 4, 5 are all the Caesar cipher. And that's because there's quite a few things to do. And I thought it might be a good idea to break it down into separate lessons so that we can go through them individually. And hopefully it'll make this very large problem a little bit easier. And we practice that key engineering skill, which is breaking down a large problem into smaller problems, and then taking a small problem, breaking it down into even smaller problems. That is the only way that we can get through really, really hard problems. All right, so you'll notice that in Caesar Cipher 1, I've split the tasks into 4 to-dos. You'll notice the order is a little bit weird because it goes 4, then 3, but they're roughly at the places where I expect you to write the relevant code. So it's not a mistake, it's actually very much on purpose. Now, what I want you to do is to go through each of the to-dos and read through their descriptions on the right-hand pane and try to solve them. If you get stuck, there are some hints in there that will hopefully help you. But essentially, the really important thing is you actually read through the to-dos, because some of the things we might not have seen before. For example, in order to complete the task, you will need to use a built-in function called index. And index is really handy because it allows us to find out the position of any item in a list. So if we had a list of fruits and we know that they start counting from 0, so apple is at position 0, pear is at 1, orange is at 2, then we can say fruits, the name of the list, dot index, and then in between the parentheses of this index function, we pass in whatever it is we want to check. So in this case, pear would give us a position of 1. And we can verify this by printing it out. So I can show this to you in the Python console, which is basically something that's completely separate from the rest of our code. And if I go ahead and now print this value, you can see it gives me 1, which is what we would expect. So this is going to be key for you to be able to solve this challenge, especially to do number 2. So look through the description, it's there to help you, and hopefully you'll be able to tackle each of these to-dos. And in order to figure out what it is that you're trying to aim for, as always, you can right-click on solution and run it without viewing the actual solution. So we already have some pre-built-in code, which I've added in for you. I wanted to save you the tedious task of typing out all the 26 letters of the alphabet, as well as all the various inputs that we need. So we need the user to tell us whether if they want to encode or decode a message, and then we want to actually ask them for the message, and then we want to ask them for the shift number. So what you want to do is, by the time you have entered these 3 pieces of information, the next time I hit enter, it should give me a printed output. Here is the encoded result, and it gives me the encoded output. So we're encoding hello, so H plus 3 letters, I, J, K, so H becomes K. E plus 3 letters is F, G, H, so this becomes H, and so on and so forth until we complete the entire text that we are supposed to encode by the shift number.
So that's all there is to it. Look through the to-dos, look through the description, and try to complete part 1 of Caesar Cipher. I'll go quiet now and you can pause the video and tackle this challenge. All right, hopefully you have completed this challenge in its entirety. If you haven't, I'm going to go through the solution together with you. And hopefully by viewing the solution, some things will become more obvious and you'll be able to go back and tackle the code by yourself. So the first step is to create a function called encrypt. I'm going to hide this right-hand side pane just so that I can show you the to-do in the entire line. So we create a function with def, and then the function is going to be called encrypt, and then we add a set of parentheses. And in this case, we want to have 2 inputs. One is called original text, and the other one is called shift amount. And we add those, if you remember, into the parentheses. Finally, we finish this function definition with a colon, and then we can write something inside the function. So to-do number 2 is going to go inside the function. So I'm just going to bring it up here to make it easier to see. So inside the encrypt function, we're going to shift each letter of the original text forwards in the alphabet by the shift amount and print the encrypted text. So there's a couple of things that we need to do. So we're going to do them in several steps. And the first step is to loop through each of the letters in this text. So we can do that using a for loop. So for letter in the original text, we're going to go ahead and figure out what is the shifted position for that letter. So if we take the current alphabet and we use .index, and inside here we pass in the letter that we're currently looping through. So let's start with a concrete example. That way we can go through it line by line. So if the original text was hello, and if the shift amount was 2, then the letter that we first loop through is H. So H is going to be checked against this list called alphabet for its index. So H is at position 0, 1, 2, 3, 4, 5, 6, 7. So H is at position 7, right? And this becomes 7. And once we've gotten this number, what we want to do is we want to shift it upwards, right? And we want to shift it by the shift amount, which in our case we said was going to be 2. So H plus 2 is IJ, so it becomes J. So how do we make it go to that position? Well, we take this index 7 and we add the shift amount to it, and then this means 7 then becomes 9. 7 plus 2 becomes 9, and position 9 is the letter J, which is what we want. So how can we turn this into the actual letter? Well, firstly, we need to probably save this shifted position into a variable so that we can use it on the next line. And what we're going to do is we're going to create a letter by using the alphabet list, using the square brackets and tapping to the item at this shifted position. Now, what do we do with this letter? We actually need to accumulate it. So in order to accumulate it, we need to have some sort of empty string, which I will call ciphertext. We started out as just an empty string with nothing in it. And as always, it's very important that it's outside the for loop because we don't want it to reset each time if it is inside the for loop. So now going inside the for loop, so indented inside here, I'm going to set the ciphertext to plus equal this new letter that we've found by this shifting process. So at each of these steps, I recommend printing out the values that you've got just to understand what is going on behind the scenes. So at this point, we've now got the letter J from this, and this J is being added to the ciphertext as the first value in there. So it should look something like this. Now, the next step is to go ahead and for this loop to continue to the next cycle. So we've now done H. It's going to go to the next letter in the original text, which is E, and it's going to repeat this process until we end up with all of the letters of the ciphertext. And once it's done that, then we want to print it out. So making sure that we are outside of the for loop. So once the for loop has completed, then we will go ahead and make a print statement. And what we want to print is something like this. Here is the encoded result. Now, if I go ahead and turn this into an F string, then I can replace this with my ciphertext. And now all I need to do is to actually call this function so that it gets triggered and it passes in all of the user inputs from up here. Now remember, with functions, just defining it and running your code is not going to do anything. It's just going to sit there until it is called upon. So let's complete to do number 3 and complete this process. So let's call this function encrypt and pass in the user inputs. So I'm going to use keyword arguments just to make it a little bit more clear. So I'm going to say original text is equal to the text that was entered by the user. And then the next value that I need to add in is the shift amount. So here, let's go ahead and add the shift amount, and that's going to be set equal to whatever the user typed in here as an input. So it's called shift. And now I can run this file and go ahead and go through the process of encoding the word hello, and I'm going to shift it by 2 again. So now you can see the result is printed out, and the first letter indeed does start with J. And then it continues working out all of the other letters. And you can see that there's 2 N's because there are 2 L's in the original text. So that all seems to be working just fine. Now, there is one slight problem which is highlighted by this to-do number 4. What happens if you try to shift the letter Z forwards by 9? Well, let's try it. Let's encode, and we're going to encode just the letter Z. We're going to shift it by 9. Well, we get a classic error, index error, list index out of range. So what's going on here? Well, if we take a look at our alphabet, we know that Z has position 25. And I know that because there's 26 letters in the alphabet. If we start from 0, then Z is at 25. So now we've got that position. This is 25. And then we add a shift amount. We try to add 9 to it. So 9 plus 25 is 34. And then we're going to try and take 34 as the shifted position to go into the alphabet. Now, of course, that is going to give us a index out of range error because there is nothing at position 34. It ends at 25. So how can we solve this problem? Well, if you think about this problem, there's actually many ways that you can solve it. Some are easier and some are more difficult. But if you think back to when we learned about the modulo, you might remember that we can use the modulo to get the remainder. So let's go into the Python console again and let me show you. So if we had the number 4 and I tried to modulo it or divide it by 25, it's going to give me 4 because 4 does not divide by 25. So the remainder is what we had at the beginning, which is 4. Now, let's see what happens if we go over 25. Let's say that we had 34 and we tried to modulo it by 25. Well, what's going to happen here is 34 divided by 25. There is one set of 25 within 34, and then it's going to give us the remainder. So that means it's going to give us 9. And this is really, really useful because in our case, this is exactly the behavior we want. If we go outside the range, just by moduloing by the length of the alphabet, we can make sure that no matter how far outside of the range of the list, we're always going to adjust it to within the length from 0 to 25. So to do this, all we need to do is take this shifted position and we're going to set it to equal the previous version of shifted position modulo by the length, so the number of items in our list called alphabet. Now, just as what you can do with plus equals, where you take the ciphertext and add this alphabet to it and then set it as the new value, you can do the same with modulo. So we can actually change this to modulo equals to make our code even more short. So shifted position modulo equals the length of the alphabet is going to make sure that we are always within the range of 0 to 25. And this is going to prevent that problem that we had earlier. So if I go ahead and run the code and type Z and I shift it up by 9, you'll see that it's performing the correct implementation, which is taking it all the way around and starting over here. So Z plus 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9, and it should, as expected, give us I. Now, this can be quite confusing, this idea of the modulo, because it does involve a little bit of maths, but it's nothing that you can't understand if you just try out some principles, try out some different letters, try out some different numbers, experiment with it, and I'm sure that you'll eventually understand what's going on. Don't move on until you actually understand what the code does. Alternatively, you could have tried some of the other methods that I gave in the hint, and maybe one of the other ones would be a little bit easier to understand for you. But I think this one should be doable by most of the students as long as you invest a bit of time understanding how it works. So that concludes part 1 of the Caesar cipher, and we've got a functioning cipher that can now encode messages. In the next part, we're going to tackle how to decode messages and how to combine the encryption and decryption functionalities together. So for all of that and more, I'll see you there. All right, so now that we've managed to get our program to encode some text, it's time to do the opposite direction, which is how do we get our program to be able to decode a piece of text based on a shift number? So let's say that we try to decode the letter G and we had a shift number of 3. Well, in this case, we actually have to work backwards and shift backwards in the alphabet in order to get the letter that's 3 spaces previously. So go ahead and open up the step 2 of our Caesar cipher project. Now we've got all the code from the previous lesson, and we now have to complete 3 more to-dos to complete the decryption part of our program. So the 3 to-dos are, you're going to create a function called decrypt that takes also 2 inputs. Then inside the decrypt function, you're going to write some code to shift each letter of the original text backwards in the alphabet so that we decode it to the original text, and then we print out the decrypted text. Finally, we're going to figure out how to combine the encrypt and decrypt functions into a single function, and then within the function itself, write some conditional statements to figure out whether if the user wants to encrypt or decrypt using this direction variable. And then we end up with a single function rather than 2 functions, encrypt and decrypt. So I recommend to do these to-dos in order and not to go straight towards to-do number 3, because it's quite important that you understand how the decryption works and how it differs from encryption before we move on to combining them. So there are some hints in the description box as well, and there's some more details in the description for you to read. Once you're ready, pause the video and I'll go silent and wait for you to complete this exercise. All right, hopefully that went really well for you and you managed to figure it all out. It's really, really hard. So all of these projects are really hard because they don't just rely on what you've learned in class. They also rely a lot of thinking outside the box, a lot of Googling, a lot of figuring things out, and also that key skill of engineering, which is breaking down problems to small enough a problem that you can solve. So there is no way that you would be able to just breeze through any of these projects. So don't feel bad if that's not happening. But now I want to go through the solution with you in case you wanted to check your solution or you need a couple more hints to figure out what's going on. So the first thing we're going to do is to create a function called decrypt. And this function is again going to take two inputs, the original text and also the shift amount. So now that we're passing in these two variables inside the decrypt function, we're going to shift each of these letters by the amount that is required based on whatever it is the user wanted. And then we're going to shift it backwards in the alphabet. So if the original letter was F and their shift amount is 2, becomes H. So now they're giving us H as the letter to decode. Then we take the shift amount and we subtract 2 and to get back to the original letter. So most of it is pretty much exactly the same as what happened in our encrypt. But the only difference between decrypt and encrypt is the shift direction. Because instead of taking the position of the current letter in the alphabet and shifting it up by adding the shift amount, what we want to do is we want to subtract it by the shift amount. So that instead of going in this direction, we're now shifting it down this direction. And the rest of the code is pretty much exactly the same. Let's walk through them line by line, just so that we revise what's happening. Firstly, we're looping through each letter in the text to decode. We're working out the shifted position, so the position of the new letter, by taking the current letter's position and subtracting it by the shift amount. Once we've got that shift position, we're using the modulo to divide that position by the length of the alphabet, which is 26 letters. And what that means is we're always going to be within that range of 0 to 25. And we're never going to go out of range of our list, which is called alphabet. Finally, we take our empty ciphertext and we add each of these letters as we loop through each of the letters in the original text, and we end up with the final ciphertext. Now, even though ciphertext is what worked for us previously in encrypt, it's probably not the best wording in this case, because the ciphertext is the result that we get after we encrypt some plain text. So let's just change this to output text. And we need to change it to all the places that we use it. And now we're ready to go ahead and test our decrypt function. So let's go ahead and call decrypt and pass in the original text, which is going to be whatever the user added to this input called text. And then we also add the shift amount based on what the user typed for the shift. So now let's go ahead and run our code. And this part is still not considered, so it doesn't actually matter what you type. And then we're going to check just one letter. So let's say that I have the letter A and I want to shift it down by 2. So remember, even though we can type encode or decode, the only function that's being called right now in our code is decrypt. So it should be taking my letter and shifting it down by 2. So if A is right here, then shifting it backwards will take it to Z and then to Y. So now let's go ahead and hit enter, and you can see that my decryption is working as expected. So now all that we have left to do is to combine the encrypt and decrypt functions together into a single one, because as you can see, they are extremely repetitive. They're so repetitive that I was able to copy and paste the encrypt function into the decrypt function to get the same functionality. So let's go ahead and create this new function called Caesar. And this function is going to take the original text as an input and also the shift amount as the input, so same as before. But in addition, I'm also going to add the directionality into this function. Now, instead of calling it direction, which will be a little bit confusing because am I referring to the direction variable here or am I referring to the direction variable here? And you can see as soon as I write that, PyCharm is already giving me a warning telling me that it shadows the name direction from the outer scope, which means you're trying to create a new variable name that's only going to be used inside your function, but you've already got this variable name declared outside. Now, this will still work, by the way. This is valid code, but it's just confusing code. So let's change it. Let's call this variable encode or decode. It's pretty easy to understand, right? We're trying to figure out, do we encode or do we decode in this function? So I'm going to copy everything I had from the decrypt function, paste it inside my Caesar function. And now what I want to do is to change it so that whether if the user wanted encode or decode, I will make this function do the exact thing that they want and encode or decode the text. So what is the difference? Well, the only difference really is this line right here. Either we subtract the shift amount when we're decoding, or we add the shift amount when we're encoding. So in maths, as you might have seen in the little hint I had here, in maths, when you multiply a number by -1, you will reverse its sign. So +5 can become -5 by simply multiplying it by -1. And then if we add a negative number, that's the same as subtracting it. So this might be a little bit of a mathematical knowledge that you may or may not know, or may not remember, as in my case. But hopefully with that hint, you could work out that in order to have this line of code work both during encoding and decoding, all we need to do is to change that shift amount based on the encode or decode variable. So if encode or decode is equal to decode, well, in this case, we're going to take the shift amount and we're going to multiply equals it by -1. So this is going to change this value to the opposite sign. So if it was positive, it becomes negative. And that's what we want when we're decoding. Now, in this case, instead of subtracting, we can simply add. So whatever it is, when we add a negative number, such as in the case of decoding, it's the same as subtraction. And when it is encode, then this if statement is not going to trigger, and we have the original code that we have for the encrypt function. So this is a really neat way that you can get around this problem. So now all that's left to do is to actually call this Caesar function instead of encrypt or decrypt. So let's clear the code a little bit to make this file a little less confusing so that we only have our Caesar function. And now I'm going to call this function Caesar, and pass in the 3 variables that it expects: original text, shift amount, encode or decode. So text is the name that we had for the input of the message, and then the shift is the variable we had for the shift amount input, and finally we also have the direction. So this is of course a positional argument way of calling this function, but if you want it to be more clear, then you can of course add in the keyword arguments. So now let's go ahead and run our code to see if it works. So I'm first going to type encode to encode my message, and I'm going to encode just a single letter to make our lives a little bit more easy. So now I want to encode, which means shifting it up, and I want to shift it up by 2. So A, then B, then C. So hopefully I get the result C. Now let's go ahead and rerun this code. So go ahead and run it again, and this time I'm going to say decode. So again, I'm going to use the same letter A, and I want to shift it by 2, and this time instead of getting C, I now have Y, because our code is working as expected, and we only have a single function that achieves all of that functionality. Now, there's just one last thing that you might be bothered by if you have a little bit of OCD like me. I don't like the fact that this prints out, here is the encoded result, whether if it's decode or encode. So how can we get it to say, here is the encoded result when it is encode, and here is the decoded result when it is decode? Well, there's a really neat trick here, because notice that the word encoded and decoded in English actually both have the word encode and decode, and the only thing that they have in common is the D to represent the fact that it happened in the past. So for us, it's as simple as simply taking this part, adding in the encode or decode variable, adding D at the end, no matter which one it is, and this F string will now print out encoded result if it is encoded, and it will print out decoded result when it is decoded. So hopefully you managed to understand what's going on in the explanation, or you already got it by yourself anyways and you're just watching to check. But once you're ready, we're going to move on to the next step and complete our Caesar cipher program. So for all of that and more, I'll see you there. Now we're really close to the finish line. I know today is quite a long day, but just bear in there. You're going to get there really, really soon. So the last part of our Caesar cipher just has 3 to-dos. One is we need to import and print the logo from this file art.py. And then we have to figure out, well, what happens if the user enters a number or space? So if you take a look at the final demo and we were to write a message, say hello, and then we add some numbers or some symbols, we don't want those to be lost when we encode the message, right? So what we want instead is we only want to encode the alphabetical letters. And then for anything that is not within the alphabet, we just keep it as it is and add it to the final encoded result. This way we can encode and decode and keep any of these characters the user types in. And then finally, we need a way for our program to rerun once the user is done with encoding or decoding. So that way, we ask them, type yes if you want to go again, otherwise type no. And if they type yes, then they get to encode or decode again. And once they're actually done, then they could type no, and the program just says goodbye, like a good little robot. So those are the 3 to-dos. Have a look in the description box, have a look at the hints if you need them, and go ahead and pause the video and complete the final part of the Caesar cipher project. Okay, hopefully it was straightforward and you're just here to check the solution. If not, don't worry, I'm going to walk through everything and explain everything anyways, so hopefully it'll be a lot more clear afterwards. So to do one is pretty simple. All we need to do is import the module art and then just simply print art.logo, which is the name that we've got in here. That's the name of the variable, and that's going to print out that Caesar cipher logo with ASCII art every time we start our program. Now you can also do the previous from import, but this is also clear enough as well. Now to do number 2, we need to figure out what to do if the user enters a number or symbol or space, and how can we keep hold of it when they actually type that in. So let's think about where we would make that differentiation. Every time we loop through each of the letters, if that letter that we're looping through from the original text happens to be not something that exists in this list of alphabet, then it's probably a symbol or a number or something that we can't shift very easily. So then we probably want to bypass the rest of this and do something separate. So what we can do is we can say if the letter is not in the alphabet list, then in that case, all we're going to do is simply take the output text plus equals the current letter. And this will add whatever letter it is that we need to skip into the output text as its original format. But then we can have an else statement and have the rest of this carry out if this is not the case, which means the letter is in the alphabet and we can in fact shift it. Now another way that we could do this is we could add a bunch of symbols and numbers to our alphabet list, and instead of calling it alphabet, call it something else, and that way we can be more inclusive. But it's quite hard to include all of the symbols and all of the numbers, and just to keep it simple for this practice exercise, this is probably the most straightforward solution. So now we're on to do number 3. Can you figure out a way to restart the cipher program? So as previous, the way that we need to do this is to use a while loop. So if we have some sort of variable, let's call it should continue, and we set it to true because normally while the program is going, it should in fact continue asking the user, do you want to go again? Do you want to go again? But sometimes the user will say no. So let's go ahead and create a while loop that checks for this variable. And if it is the case, then we're going to keep running all of these inputs, asking them direction, text, shift, and also running our Caesar function. But then at the end of all of that, once we've given them the encoded or decoded text and that Caesar function has come to an end, then the next thing we're going to do is we're going to check with them whether if they want to go again. So I'm going to copy this message and add it into an input. So in this input, I'm going to go ahead and change it to .lower to make sure that we've got the whatever it is they type, capital or no capital, set to the same thing so that we can check it more easily. And I'm also just going to add a \n so that our cursor goes on to the next line when they do have to type, so that it's cursor here rather than cursor here. Now finally, I'm going to save that input into a variable called restart. And now we can check the value of that restart. If restart is equal to no, well, in that case, we can change our should continue to false, and then we can print goodbye. And if the restart is any other value, so yes or capital yes or whichever, then this if statement is skipped and our while loop loops back up from the start. So that is how we can make sure that our code continues asking the user for a message and their encoding or decoding, and it will continue forever until they basically say no. Now, if you've been following my code all along, I want you to try and test your code right now repeatedly and see if you can spot a crucial bug. Now, it relates to this Caesar function, and I want you to see if you can, through testing, figure out what is wrong and solve the issue. So pause the video now. So did you manage to find the problem? Here, let me show you. So if I go ahead and start encoding, and we decide to type A and B, and then type the shift to go up by 2. So that becomes CD, which is great. So let's go again, and let's now type decode. And again, use the previous cybertext, which is CD. And if we take our ciphertext and shift it down by 2, we should expect AB, which is our original message, which we encoded up here. But instead we get AF. So what is going on? Well, if you debug, either using the debugger or your own knowledge, you'll find that this line here is the culprit. We're determining the shift amount by shifting it back to the negative, and that's what happens when we do -1. But this is inside the for loop, which means that it's going to happen and flip every single time the for loop runs. So in order to fix this, what we need to do is just to take it out of the for loop and then put it above the for loop. And now, if we retest, you'll see we've managed to solve that problem. So going up works and going down also works. So that is all there is to it, to this 3-part Caesar cipher project. And of course, as always with all of these projects, feel free to add modifications, tackle any edge cases. There might be things that I haven't thought of that you've thought of. There might be improvements you want to make. The program is yours, so you can do whatever it is you want to do to improve it. And hopefully in the process, you've managed to solidify and revise some of the topics that we've learned in today and previous lessons. And if it was really, really hard, then that's a good thing. That means you've really struggled and you're building those programming muscles, right? There's no point going to the gym and lifting 1 kilogram weights. It's not going to make you very muscular. We got to push ourselves, and this is okay. So I hope you had fun with me today, and I look forward to seeing you tomorrow.
Hey, well done for completing day 8. Now, somewhere along this journey, you will feel a dip in your motivation. It might happen around now, it might happen later. But what you got to think about is what really motivates you. Why are you doing this? What is learning this skill going to do for you? What is it going to do for your family? It might be that you want to get a better paying job. It might be that you just hate your current job and you want to do something that you actually enjoy, like programming. Or maybe you want to start your own business and you need the skills to be able to build the product that you're going to sell. So have a think about what drives you, why you're doing this. Write it down on a piece of paper, put it up on a wall so that you can see it every day when you wake up. And maybe comment in the box below so that other people can cheer you on and you can be motivated and also motivate others. So have a think about that, and I'll see you tomorrow.
Hey, welcome back. It's day 9 of 100 Days of Code. And today we're going to be learning more about Python dictionaries and nesting. And by the end of today, you will have built a silent auction program. We all know that there are auctions where everybody bids and you can see everybody else's bid, and the auctioneer gets you to bid higher and higher values. Now, there's also a type of auction called a silent auction, where everybody bids silently and no one knows the other person's bid until at the very end of the auction, where the highest bid is revealed. That's what we're going to be building. And if you want to check out the final program, you can head over to this URL right here. And here you'll not only see this amazing gavel built out of ASCII, but also the secret auction program, So here's how it works. Let's say that I'm going to be the first person logging onto the program. I'm going to give my name and my bid. Let's say I'm going to bid $53 for this item. And once I'm done with my bid, it asks me whether if there are any other bidders. So if I type yes, then the screen clears and I can hand over the laptop to the next person who's going to make their bid. So let's say there's James who's going to bid even less than I did. And then he's going to make way for the final bidder who is going to bid $121. So now at this stage, if everybody is done, then we type no, and it's going to now tally up all the bids and figure out who bid the highest and give us a winner, printing out the winner is Ginny with a bid of $121. There's a number of places that you could use this if you were auctioning some piece of art, or if you're trying to outbid your brothers and sisters on who gets to go on the trampoline, or if you're trying to start an auction with your friends or co-workers. The silent auction has many, many uses. All right, in today's lessons, we're going to be focusing mostly on the Python dictionary. But in addition, we're also going to look at how we can nest, say, lists inside lists or dictionaries inside dictionaries, and also mixing lists and dictionaries as well. Once you're ready, head over to the next lesson and let's get started with the day. All right, so the first thing I want to talk about is dictionaries in Python. Now, dictionaries in Python work kind of similarly to dictionaries in real life, right? So if you were to look up a word in the dictionary, say the word code, then you might find the definition as something along the lines of program instructions for the computer. And dictionaries are really useful because they allow us to group together and tag related pieces of information. The way I like to think about dictionaries is in the form of a table. Every dictionary has two parts to it. On the left-hand side is the key, and that is the equivalent of the word in the dictionary. And then it's also got an associated value. That would be the equivalent of the actual definition of the word. Now, let's say that we took this very simple table of definitions of programming words that we've come across so far, and we go ahead and we try to convert it into a dictionary. How would we do that? Let me firstly drop the last two rows, and let's just start with the first one. The first thing we want to do is we want to create a dictionary. And to do that in Python, this is what the syntax looks like. We have a set of curly braces, and everything that's inside the curly brace is the content of our dictionary. The key goes first, followed by a colon, and then followed by the value. In our table, we've got this word bug, which is the first key, so we can replace that over here in our dictionary. And the value that's associated with this key is the definition for a bug. So an error in a program that prevents the program from running as expected. That becomes the value and can be replaced here after the colon. So now we've created an actual dictionary using Python code. What if you wanted to have more than one entry in your dictionary? Well, you would separate each of the key value pairs using a comma. And then you can continue adding key and value pairs until you get to the end of your dictionary. All right, let's take a look at dictionaries in action. If you head over to the day 9 start code file, then you can see that in here I've already added the dictionary that we were defining earlier on, and I've stored it inside a variable called programming dictionary. Now currently I've only got 2 entries in this dictionary, the definition for bug and the definition for function. Now the first thing I want to highlight is when you create a dictionary that has more than one element, such as in this case, then you want to take care to format it properly so that it's more easily readable. So what you'll see Python programmers do by convention is they will start off the dictionary with the open curly brace at the top, and then every subsequent entry is indented by one indent. And then at the very end of that entry, there's a comma, and then we hit enter so that the next item goes on to the next line, And finally, the last curly brace should go at the very beginning, in line with the start of the dictionary. And another thing that's quite nice to do is to cap off all entries in your dictionary or list with a comma. This means that if you needed to add more items into the dictionary, you can simply just hit enter and continue typing the next thing. And if we wanted to add another entry, it's as simple as adding in the key, a colon, and then the value. And to cap it off, again with a comma. So now our dictionary represents exactly the same data as we saw in our table over here, with a bunch of key value pairs and a total of 3 entries. Now, the next thing I want to do is, what if I wanted to retrieve an item from the dictionary? Because we know that if we had a list, what we would do is we would use a set of square brackets, and then we would give the index of the item that we wanted. So the item at index 0 or 1 or 2, and so on and so forth. Now, for dictionaries, it's kind of similar in terms of syntax, but the only difference is that dictionaries have elements which are identified by their key. If we wanted this piece of information, for example, then all we have to do is tap into the dictionary and then add a set of square brackets, and inside the square brackets, we're going to provide the key. So here, the key is a string, and it's the string bug. So let's go ahead and put bug in here. And now if I go ahead and print this, then you can see that is going to give me the value, which is an error in a program that prevents the program from running as expected. Now, it's really, really important that you make sure that when you're fetching something out of a dictionary by its key, that you actually spell the key correctly. A really, really common error is when you're trying to retrieve something out of a dictionary and you've just made a very simple typo. So instead of U, I'm typing O here, and you'll see we get an error. And the error tells us that it's a key error referring to this particular key, and it highlights this line 7 where we're trying to retrieve something out of this dictionary by this key. Basically, it's telling you that this key doesn't actually exist and it can't be found, so it doesn't know what it is that you want. Remember how when we had lists and when we tried to retrieve something that was not inside the list, so for example, this particular list at index 4 doesn't actually exist because this is 0, 1, 2, 3, and 4 is actually not a piece of data inside this list. Similarly with dictionaries, if we try to put in a key that doesn't exist, then we get this key error. Now, another common pitfall that students fall down into is they don't actually use the correct data type. So, for example, if when we defined this dictionary without putting a string around each of these keys, then it's going to error out and it won't even let us run. It's going to tell us undefined name bug because it thinks that this is a variable that you've declared somewhere, but it's not. In fact, what you wanted are these strings for keys. And so when you have a key that is a string, when you're trying to retrieve the data from that key, you also have to make sure that you provide the key in its actual data type. So for example, if this was just a number, say 1, 2, 3, then of course all you have to write in here is just 1, 2, 3. And it would know that this piece of data is what you wanted. So that's how you retrieve items from a dictionary, by adding a square bracket and then giving it the key. And it will look for the key inside the dictionary and give you back the value. Now, what if you wanted to add a piece of data, such as that loop that we had earlier on, but you want to do it programmatically? So instead of doing it when you were defining the dictionary at the beginning, what if at some later stage in your program you needed to add a new entry? Well, to do this, it's also really simple. All you have to do is to tap into the dictionary, which is called Programming Dictionary in our case. And again, using square brackets, we define the key. The key I'm going to add is our loop. And then after a equal sign, I get to assign the value. So in my case, the value is going to be the definition for a loop. And now when this line of code is executed and we go ahead and just print the programming dictionary after this has happened, then we'll see that it's actually different from what we had before. So let's hit run, and you can see that previously we had a programming dictionary that had only 2 items, bug and function. And after this line where we print our programming dictionary again, you can see it's now got 3 items, bug, function, and loop. Now, very often when you're writing code, it can be really helpful to start out with an empty dictionary. Just as you saw previously, you could create an empty list by simply having a set of square brackets with nothing inside. You can also create an empty dictionary by simply creating a set of curly braces with nothing inside. And then at a later stage, you can add to your dictionary by using this method that you saw here. Now, on the other hand, you might actually want to wipe an entire dictionary. Here, I'm creating a new empty dictionary by creating this pair of curly braces with nothing inside. But I can also wipe an existing dictionary by simply doing the same thing. We know that this dictionary, programming dictionary, has 3 items in it, but on line 17, I'm going to say programming dictionary equals empty dictionary. And now if I move this print statement down here, then you can see that when it prints out, it's actually going to be completely empty. That can be really useful if you wanted to clear out a user's progress, or for example, if a game restarts, then all the scores and stats will probably have to be wiped empty. So this is one way that you could do that. Now, this method of tapping into a dictionary using the key to fetch the relevant item from it, and then doing something with it, goes beyond just adding. You can also use this to edit an item in a dictionary. For example, let me go ahead and comment out these 2 lines of code so we don't wipe our programming dictionary. And instead, I'm going to tap into the programming dictionary and I'm going to fetch the item that has a key of bug. And I'm going to redefine its value. So currently it should be an error in a program that prevents the program from running as expected. And I can prove that if I just wrap this around a print statement. If instead I wanted this to be a different value, then I can simply use the same syntax as I did for adding new items, but in this case, I'm actually editing this entry because it's going to look through the dictionary, find a value with this key, and then assign it to whatever I put on the right-hand side of the equal sign. Now, on the other hand, if it finds nothing with that key, then it's going to create a new entry with the value again on the right-hand side of the equal sign. Now, let's say that a bug is instead a moth in your computer. Now, if I go ahead and print my programming dictionary once more, then you can see that the definition for our bug has now just been changed. The final thing with regards to dictionaries that I think is really, really useful is how you loop through a dictionary. And using your knowledge from lists, you might think that to loop through a dictionary, you would, let's say we're using a for loop, and we say for thing in programming dictionary, let's go ahead and print this thing each time. Here's a good moment to play computer and think, what do you expect to be printed? So let's comment out all the other print statements so we don't get confused. And when I click run, what do you think will be printed? All right, is that what you expected? Because it certainly wasn't what I expected when I first learned Python. I thought it would give me each of the items in the dictionary with its key and its value. But instead, this code actually just gives you the keys. Now, of course, once you do have access to the key, instead of thing, I should actually really say for key in programming dictionary. If I wanted to print the key, then of course I could just write print key. But if I wanted to get hold of the value, I could equally just as easily tap into my dictionary, use the square brackets, and pass in that key. So now when I hit run, you can see it's giving me first the key from this line, and then secondly, the value based on this line. I'm using that retrieval code in order to get the value. Of course, remember that you can get access to all the code that I'm writing here. And if you want to, have a quick review of everything that we've gone through so far, because a lot of this knowledge is going to be tested in the next lesson, where we do a coding exercise that will really solidify everything you've learned in this lesson so far. So for all of that and more, I'll see you on the next lesson. Now that we've seen lists as well as dictionaries, I want to talk about a concept that you often see in both of these collection types, and that's something called nesting. Now, if we imagine a list or a dictionary being something like a folder where lots of things can be stored inside it, then nesting lists and dictionaries is just a matter of putting one inside the other. For example, here's a dictionary that is very simple. It's only got one key value pair. Now, we know that we can add multiple key value pairs into the same dictionary by just adding a bunch of commas to separate them. Now, what if instead of having a simple value like a string or a number, I could also put a list as a value as well? Similarly, I could also use a dictionary as a value. In this case, we've got a list as the value for key, this first one, and we've got a dictionary as the value for key 2. Notice how this is a list and a dictionary nested inside another dictionary. The structure gets a little bit more complex, but it gives us more flexibility when we're trying to store more complex pieces of data. Coming back to our code, let's go ahead and create some sample dictionaries to see what this actually looks like in real life. For example, this could be a dictionary that contains the country as the key and the city, that is the capital, as the value. So for France, that's Paris. For Germany, that's Berlin. This is a very simple dictionary that you've seen already. Now, if I wanted to nest a list in a dictionary, then I would be able to represent even more complex data. For example, if I had a travel log where I was going to collect a dictionary of all the cities I had been for each of the countries I've traveled to. So for example, if I had traveled to France and I wanted to say that I've been to multiple cities, I can't simply just say Paris and then Lille, Dijon. That doesn't really work because each key can only have one value. The only way that we can make these 3 pieces of data one value is by turning it into a list, like so. So now in our travel log dictionary, as represented by the curly braces, we have one key value pair, and it just so happens that the value in this case is a list. And of course, you can go on and add as many entries as you would like, and still preserving this kind of structure of key being a string and the value being a list.
Now, I've got a challenge for you to test your understanding of how lists nested inside dictionaries might work. I want you to guess and figure out how can you print out the Lille string from this travel log. So think about how you might access items in a dictionary, and then think about how you access items in a list, and the goal is just to print out this Lille. Pause the video, give this a go. Okay, so let's first start with accessing this list. So if we go ahead and use our print statement to tap into the travel log, we know that we can access the value of a dictionary by using the key. So we use these square brackets and then we have to type the key, which in this case is France.
So if we print this, right now we're getting hold of the list, and we know how to work with lists already. So if we want the item at index 0, 1, then we just need another set of square brackets and add 1 in there. So now if we run this, you can see we're able to get hold of this item. Now we've previously seen that you can nest lists inside other lists, and you can end up with a many layered nested list. So for example, if I had a list that had the letters A and B, I can nest a list inside there at the index 2, so 0, 1, 2. The third item in this list is another list, and I'm going to add C and D. So now we have what's called a 2D list. We have a list, and then we have a list inside that list. So here's another challenge for you. See if you can figure out how to print out this letter D from the nested list. Think about what we did before, and think about what you've learned previously about nested lists to complete this challenge. Pause the video now. Okay, so let's first access this list. So if we go ahead and print our nested list, and then we put in the index of this list, it would be at 0, 1, 2. So let's put 2 inside the set of square brackets. I'm just going to comment this other print statement out. And now you can see we've got hold of C and D. So now that we've got that list, how would we access D if we were working with this list? Well, we would tap into the item at index 1. So what we know is this part of the code results in this list. Then to get hold of D, all we need to do is add another set of square brackets and then add 1 as the index. And now when I print it, I'm able to get hold of that item D. Now, this is quite confusing at first because there's a lot of nesting and it can be a little bit difficult to wrap your head around it. But if you try it a few times with some of the other items in the nested list inside a dictionary or the nested list inside a list, then eventually it will make sense and it's not actually so complicated. Now, other things that you can nest is you can actually nest a dictionary within a dictionary itself. So if I have this travel log and I'm going to copy it and then comment it out so that I can have a different version of it. Now, if I wanted to, instead of storing a list as the value of the key France, I can also store a dictionary. So now this is a dictionary which has a key of France, and the value for that key happens to be another dictionary. So what's going to go inside this dictionary? Well, if I was really building a travel log, I might want to log, well, how many times have I visited this country? So let's create a num times visited key for this France and make sure that we've got it as a string. And then for the value, we could have a number. So let's say I've been to France 8 times. Then that would be the first key value pair in our France entry. And then we've also got another key called cities visited. And now what we can do is we can save the list into the value for that key. So now we've got a list nested inside a dictionary, which is nested inside another dictionary. And if I was to complete my travel log, then it might look something like this. And you can see that our data is more complex. We've got more key value pairs associated, and we've essentially got a much better way of organizing the data for our travel log. So now comes the question of how would you access some of the items from this more complex travel log? Can you figure out how to print out Stuttgart from this travel log? Figure out how you might access this dictionary, and then how you might access this list, and then how you might access this item in the list so that you can print it out. Pause the video now. All right, so let's go step by step. The first step going inside this dictionary is we have a key and we have a value. So let's try and pick out this value. We can do that by printing out the travel log and then using square brackets to tap into Germany. Now, when we print this line, we should be able to get this dictionary that contains all of this data. So to narrow it down to this list, we have to again use the next key. So add a set of square brackets and then use cities visited, and making sure that you've actually typed it right without any typos. Often it's easier to just copy and paste. And now I should be able to get the list that's stored under that key. So finally, to access this item in the list, it's at index 0, 1, 2. So another set of square brackets, put the index 2 in there, and we've got Stuttgart being printed out here. So there you have it. You have lists inside dictionaries, dictionaries inside dictionaries, lists inside lists, and a whole lot of different ways of organizing your data and working with dictionaries in Python. Next, we've got a quiz for you to test some of your knowledge on these dictionaries, and hopefully you will pass with flying colors. All right, so now that you've learned all about dictionaries, we're going to put all of that knowledge to test and to use by building a blind auction program. So here's the program. When you first run it, it's just going to show you the logo art and maybe a line that tells you what program you're in. And then it's going to ask you for your name. So let's say we have 3 bidders, right? So first go, I go to the computer, I type in my name, I type in my bid, and I hit enter. It asks me if there are any other bidders. I look around the room, I see 2 other colleagues, so I type yes. And now it clears the entire screen so that other people can't see what my bid was. So now I leave the computer and my colleague comes over, they type in their name and also their bid. And again, they look around the room and they see there's one other person who wants to bid, so they hit yes. Again, it clears their bid, and finally the last person makes their bid. At this point, everybody has bid, so she's going to type no. And it's at this moment when our program is going to work out who has made the highest bid and print out who the winner is and what their bid was. This way, instead of competing with each other on bids, we actually all just give the highest price we're willing to pay, and this is known as quite an efficient way of making a bid. And you see that a lot in, say, the construction industry and government, etc. The important thing in this program is, now one of the most complex parts of actually trying to build this program is how do you clear the screen in between bids? Now, what I want you to do in your version of the code is I simply want you to print out a new line character. So if we print a string and the string happens to be just the \n, so just a new line, and then we can do this thing where we multiply this string by, say, 20 times or 100 times. And what this means is it's basically going to add 100 new lines. So if I go ahead and print hello, and then I go ahead and have an input, type something. Now, if I run this code, you'll see that hello was printed, and then immediately the next thing I did was to basically clear the screen, and I did that by typing \n 100 times. And this programmatically will scroll to this part, and now I can use this input and the user won't be able to see the previous part unless they know how to scroll up. In addition, we've also got the starting art of the gavel logo, which you're going to put into the program. And the most important thing of all is that I want you to create a dictionary so that each person's name will be the key and their bid will be the value. And this dictionary is going to contain many of these key value pairs. And at the very end of the program, when everybody's done with bidding, then we're going to loop through that dictionary and figure out who has made the highest bid. if you want, this is a good time to analyze this completed project and see if you can create your own flowchart using something like Draw.io that I've shown you before, or just take a piece of paper and a pen and draw out your flowchart. Now, if you want a hint, then you can head over to the course resources and you'll get taken to the flowchart that I've created for this program. So spoiler alert, I'm about to show you that flowchart. So if you don't want to see it and you want to create your own because it's a relatively simple program, then pause the video now and complete the challenge by yourself. Now, for everybody else who's still here, I want to show you this is a flowchart I've created to represent this program. So we start at the beginning, we first show the logo from that file art.py, and then we ask for a name input, we ask for their price. Now we're going to add the name and the bid into a dictionary with the name as the key and the bid as the value. Now, once we're done with that, then we get to ask the user for another input and see if there are any other users who want to bid. So if they answer yes, then we're going to clear the screen and we're going to go back to here, ask for another name, another price, and so on and so forth. But if they say no, everybody's done with bidding, then we're going to call some sort of function that we have, which is going to loop through our dictionary that was created here and find the person who had the highest bid value and then declare them as the winner and print out their bid. So it's a relatively simple program, at least compared to other things that you've built so far. So this is the time to pause the video and give it a go. All right, now I'm going to walk you through the solution, or at least my solution, for the blind auction project. So the first thing that I like to do when we have something that is a large project is to break it down. So you saw me draw a flowchart, and the next step is I could translate that flowchart into several to-dos in my code. So the first thing I'll probably want to do is to ask the user for some inputs. And the inputs that I need, if you take a look at the demo, is it asks for what is your name, and then what is your bid, and then it's got this $sign in front. And then it asks, are there any other bidders? Type yes or no. So we need a way of capturing these inputs, right? So that could be our to-do number 1. Next, we also need to save the data that the user gives us into a dictionary. And that way we can later loop through the dictionary where we have a list of name and then price, and we'll be able to figure out who is the name that had the highest price. Now, the next thing we might want to do is to figure out whether if the user wants to continue adding new bids. And this might involve some sort of a loop so that we can keep going back to ask the user for input, but of course it will be a different user each time. Now, the final thing to do is to actually go ahead and compare all the different bids and then figure out who has the highest bid in the dictionary. So that's pretty much all there is to it, and let's go ahead and tackle it one by one. So firstly, let's ask the user for some input. So let's save their name into a variable called name, and then we'll use an input to ask them, what is your name? And then we'll add a colon, maybe a space, so they can type their name here. And then once they've typed their name, we'll ask them for a price. So again, it's going to be an input, and we're going to say, what is your bid? And now we're going to add a $sign or whatever currency you work with in front of their bid. But remember that they're going to write a number in here, and inputs are strings. you can see that it's going to give you a string. So in order for us to be able to save it into our dictionary as a number, I'm going to convert it to an integer. Now, of course, if you want bids that have floating points, decimal places, you could also convert this into a float. So now that we've got our number and our name, the next thing to do is to save that data into a dictionary. So if we have a dictionary that we call, let's say we call it bids, and we started out as an empty dictionary, then once we've gotten hold of the data from the user, their name and the price, we can then add to this dictionary of bids. So we can say bids, and then the key is going to be their name, and we can set it to equal the value. So if this is at all unfamiliar, then you might need to go and review the lesson where we learned about dictionaries, how to modify, how to edit, how to add, how to create empty dictionaries. But this is essentially the process to save the data into our dictionary in this format. So now we need to ask the user whether if there are any new bids that need to be added. So we could probably have a variable called should continue, and we could set that to equal an input. And our prompt could be, are there any other bidders? And we can say type yes or no. And then we could add a new line so that they type on the next line. And now we have this variable should continue. So how can we use this variable to go back to the beginning and ask for the new person's name, price, and save it to our bids variable? Well, we would probably need some form of a loop, right? So let's go ahead and use our friend, the while loop. Now, what is the variable that we'll check? Let's say that we had a variable called continue bidding, and we set it to equal true to start off. While continue bidding is true, then we are going to keep asking the user for their name and price. And then we're also going to keep saving their bids into this variable called bids. And then finally, we're also going to ask them what is their choice, whether if there are any more people who are going to enter this auction. So we can now delete all these bits of repeated code. And if you think about this dictionary, we need it to be outside of the while loop so that it accumulates and it doesn't reset to 0 every time the while loop runs. If we had this inside the while loop, then every single time we repeat the loop, we're going to lose all of our previous data. So let's keep it outside. Now, finally, we need to compare the bids in the dictionary once the user is done. So once the user is done, then we would get a no. And if the user was not done, we would get a yes. Now, because this is going to be user input, yes or no, it's usually a good idea to add dot lower onto this so that when we're comparing it using our if statement, we know that it's always going to be lowercase. So if the should continue input is equal to no, well, in that case, we need to compare the bids in our dictionary. Now, since this comparison in our dictionary is kind of like a separate piece of functionality, it's probably a good idea to create a separate function for it. That way we can reuse it and we can also modularize our code so that it only does that function and we can keep it outside of the main body of our script. So let's go ahead and create a function which I'll call find highest bidder, and this is going to take an input in the sense of a bidding dictionary. Now, this is just a parameter. We can pass anything we want in here, but we know that what we're going to pass is actually this dictionary of bids. So what we want to do is we want to loop through our dictionary, bidding dictionary, and we're going to look for each bid. So for bid in bidding dictionary would be nice, but as you might remember, when we loop through dictionaries, what happens is we actually loop through each of the keys. So if our dictionary is structured like this and we say for something in bidding dictionary, we're going to be getting hold of each of the names. So let's say for bidder in bidding dictionary, that way we're not confused as to what this value will be, then we can set their bid amount to be equal to the bidding dictionary, and then using the square brackets to tap into that key, the current bidder. And this is how we get hold of the value in a dictionary when we're looping through it. And this is something we covered in previous lessons as well. So now we need to figure out what is the largest number in terms of this bid amount when we loop through the bidding dictionary. Now there's several ways of doing this, and the most easy to logic through way is to simply set something called a highest bid, and we can set it to equal 0. And then every time we loop through a new bidder and we get hold of their bid amount, we can check to see if the bid amount is greater than the current highest bid. And in that case, then the highest bid is going to be set to the bid amount. So now we can set a winner. So we know who this person is, right? If at this point of the loop, our highest bid is equal to the bid amount, then at the same time, the winner is going to be the person who has that highest amount. So we can also reset the winner to the current bidder. Now, outside of the for loop, so once all of the loop has completed going through each of the entries in our dictionary, we've gone through everybody's bids, then we can go ahead and print the winner. So let's create an F string and say the winner is, and then we can insert this winner variable, and we can say with a bid of, and then our $, and the highest bid can go in here as well. So that completes our finding highest bidder function. And the thing that I said earlier, where I said there's many ways of doing this, you can also actually just simply use the max function. Now, Python has a max function that can figure out what is the maximum value of all of the values in a dictionary. So I've got my Python console open here just to build a separate dictionary. So here I've got a dictionary representing the fruits that are in my house, and I want to know which fruit I have the most of. So what I can do is I can use the max function, pass in my dictionary, fruits, and then after a comma, I could set the key to equal the fruits dot get. And what this line of code is going to do is it's going to look through the values of all of the items in my dictionary, compare them against each other, do a whole bunch of number crunching, and then give me the key that corresponds to the maximum value. Now, if you did a bit of Googling and went onto Stack Overflow because you thought to yourself, surely Python must be able to figure this out without me having to work it out, then you are right. But I think given that most people are learning Python from scratch and they don't have any knowledge of other programming languages, this is super mysterious. And I recommend to actually always try to go from first principles and just simply work it out, because the code is not that complicated. And down the line, this will be a lot easier to figure out than some code you got off the internet. And besides, we're learning at the moment, right? So it's always good to write more code. So we've got our dictionary comparison function. We just need to use it in our while loop. So if should continue is equal to no, that means everybody's done with their bids and this dictionary is now full. So we can now pass that dictionary over to the find highest bidder function. So we can firstly set continue bidding to false, so we exit our loop, and then we set our find highest bidder to work on our dictionary of bids. Now you'll notice that at the moment I have this red underline and I'm not getting any auto suggest for my function down here. And that's because we need to declare this function or create this function before we use it. So if I move it all the way up there, then we now have a working bit of code. So finally, the only other thing we need to do is to check if they typed in yes. So if should continue is equal to yes, that means they want to go back to the beginning of the loop and enter the next person's name. But remember that what we want to do is to clear the screen when that happens. So if I type yes, I don't want the previous person to see the bid because it's a blind auction, right? So as I mentioned previously, in order to clear the screen, we're simply just going to print out the new line character, so \n, and we can print it out 20 times or 100 times or however many times you want. And then it's going to loop back to the beginning of the while loop, asking the next person. So let's try this out. Let's say that we have one person called Angela who wants to bid $12 for this half-eaten apple. And then we have another bidder who is called John who wants to bid only $3. And finally, we have Kate who only wants to pay $1. So now if we go ahead and say no, there are no more bidders, it tells us that the winner is Angela with a bid of $12. And now all we need to do is to put in the final finishing touch, which is to import and print our logo. So import art, and then we'll go ahead and print art.logo. And that will complete this project. So as always, you can go into the solution.py to view my solution. You can improve the project to your desire, and you can also go back and review some of your code to make sure that everything works as expected. Now, tomorrow will be a new day and we'll be learning some more Python. So get some rest and I'll see you soon.
Hey, congratulations on completing day 9. Now today I want to share with you a trick that's really useful for keeping your motivations high. And the idea is to make sure that you are accountable by not just yourself, but also somebody else. So find a member of your family, find a friend, find a buddy, and just tell them that you've committed to doing this 100 days of code. And then they'll check up on you every week, asking you, what have you made? What have you learned? And then you can send them the projects you've built, like Handman or Treasure Island, so that they can share in your learning and what you've been building. Now, what this is really important for is that you can't just tell yourself, maybe I'll give myself a day off today. Now you've got somebody who's going to hold you accountable to make sure that you keep showing up and you keep persevering. So give that a go, and I'll see you tomorrow.
Hey there, welcome to day 10 of 100 Days of Code. And today we're going to learn about functions with outputs. Previously, we've already seen the other two flavors of functions, a plain function and also functions with inputs. But in today's lessons, we're going to be using the skills that we've learned, and we're going to be extending our knowledge of functions to build a calculator app. I think at some point in every programmer's lives, they will have built a calculator app. So if that hasn't already happened to you, then today is your lucky day, because that's exactly what we're going to be making. So it's a simple text-based calculator, and we can start off by writing a number and then picking one of the operations: plus, minus, multiply, or divide. So I'm going to divide this by 2, and then it shows us the full calculation: 5 divided by 2 equals 2.5. And now we can continue calculating with the answer from the previous step, or we can type n to start a new calculation. Let me type y, and maybe I'll do 2.5 plus 6, and now I get 8.5. By the end of the lessons today, you'll have understood how functions really work, how you can use them to reduce redundant code, and how you can provide inputs to functions as well as providing outputs. Once you're ready, head over to the next lesson and let's get started. To begin, the first thing I want to talk about is more on functions. So we've already seen a couple of things that we can do with functions. The first thing I showed you was how to create a very simple bog standard function using the def, the name, the empty parentheses, and then the colon. And then within the body of the function, you can do a bunch of things which will be carried out every single time you trigger or call the function, like this. And the first type of function basically just helps you reduce the amount of code you have to write when you have instructions that you want to execute repeatedly. Now, the next type of function we saw actually had something inside the parentheses. And this something is an input which can be passed over when we call the function. So in this case, 123 is the argument which gets passed in to this parameter called something, and then it gets used within the body of the function. The second type of function, the functions which allow for inputs, gives us the ability to modify the code in the function and to get it to do something different each time depending on what input was passed in. We're now on to the final sort of flavor of functions, and these are functions which allow you to have an output once the function is completed. We start off with a simple function, and in this case you'll notice that even though I'm actually not giving it any inputs. The inputs and the outputs are completely separate from each other. So this is a normal function that you've seen many times now. And within the body of the function, I'm going to do some piece of calculation. Let's say I'm going to calculate what is 3 times 2, and then save it to a variable called result. Now, once that's done, I can use the output keyword, which is return, and then after that keyword, I can put whatever it is I want to be the output of this function. So in this case, the output is the result. And what that means is when I call this function later on and it runs, then it will go ahead and output this result, and it replaces this line of code where this function was called. Now, that result is held in the code where the function was called, and I could save it to another variable. Result, of course, equals 3 times 2, and that means this output now equals 6. So this is what the code might look like. Somewhere I would define my function which has an output, which you can tell by the return keyword. Now, at some other point in my code, I decide to call that function. And once that function executes, that return, or whatever is outputted, replaces the function call. And at the very end, it means this variable output will store whatever the output is. So in this case, output would be equal to 6. The way that I like to think about functions with outputs is almost kind of like a machine, right? If you had a machine where in goes some empty bottles, and after some processing or some inputs, out comes a bottle filled with milk. So in this case, this function has an input, the empty glass bottle. It has an output, the glass bottle filled with milk. And in the middle, there's some processes or some code that's being executed to create this change. This ties together all the things that we've learned about functions.
So now head over to the starting file for today's lessons.
Let's start off by creating a new function, which I'm going to call format name. And the reason is because this function is going to take a first name and a last name, and it's going to change those inputs. Even if it was lowercase or if it was all caps, it's going to change it into title case. Something like this, where the first letter is capitalized in each word. To begin, I want you to create this function and then go ahead and add two inputs to it. One called fname, so first name, and another called lname, which is the last name. Pause the video and give that a go. Alright, so all we have to do to add inputs to our function is just to put the names of these parameters inside the parentheses. So now our function is able to take these parameters as inputs whenever this function gets called. The next step is we're going to convert these strings that gets passed in. So it could be something like this, all lowercase, it could be all capitalized, or it could be kind of random, right? Like some are capitalized, some are not, but we're going to make it all uniform. So all of these are going to end up like this. And to do this, we can search around in Google and you might come across a similar question in Stack Overflow. How do you convert a string to title case in Python? They have an example and it's trying to do exactly what we're trying to do. If we take a look at the answers, you can see that somebody is helpfully pointing to this title function. So you take a string and then you write .title, and then afterwards the string gets transformed and every word now starts off with a capital letter. And if you want to know more about how this title case works, then you can click on that link in title and then have a read through the Python documentation. Once you've read through that, go ahead and modify this fname and lname so that they end up being both in title case. Pause the video and give that a go. All right, so we want to go ahead and take this fname and then write a dot and then write title to convert it to title case. Once we've done that, then we're going to do the same with the lname. And if we go ahead and actually print these out, and of course, in order for the function to actually execute, we'll have to call the function. So I'm going to put two inputs in here. One, which is going to be just Angela all in lowercase. And then the second one is going to be Angela all in uppercase. And now when I run this code, you'll see that the result is they both get converted to title case. In essence, this part of the code becomes whatever the previous value of fname is converted to title case. You might have spotted already that this title function actually has an output. It returns a version of the string where each word is title cased. Instead of simply just printing this, we can also capture it inside a variable. Let's create a new variable called formatted fname and also formatted lname. Now, what's happening here is we are transforming this input fname, turning it into title case, and then once this function executes, it has an output. And that output replaces this part of the code, and then it gets stored inside this variable. Now we can go ahead and print the final version of our function, which is going to use an f string to take the formatted fname and then add a space and then print out the formatted lname, like this. Now, if I start out with my first name, but all in strange sort of casing, and then my last name in all caps, let's go ahead and hit run and see what happens. You can see that my first name gets converted to title case, my last name gets converted to title case, and then that result is stored in formatted fname, and this result becomes stored in this lname, and then they get printed and formatted, like so. Now, instead of printing this result out, we could also return it as well. In the same way that this title function returns the output, replaces this part of the code, we can also do the same with our format name function. So let's delete the print function and go ahead and use return instead. Now this formatted string becomes the output. And as we mentioned before, what happens with functions with outputs is this output replaces the part of the code where the function was called. Now, if this is the string that we want to print, then all we have to do is just to save the output, which replaces this part of the code, inside a variable like this. And then all we have to do is just go ahead and print that formatted string. As you can see, when I run the code, the same thing happens. Now you can, and you might have, alternatively, just taken this function call and put it straight inside the print statement. That works exactly the same way. And we can visualize this using Thonny. If I go ahead and paste everything we have inside the editor and go ahead and run debug, then we can step into and see what are the steps that happen. So the first thing when this line 6 gets executed is it tries to call this function, format name. So it passes in these two inputs, and we're now within the function where we have access to these two inputs, fname and lname. Now the formatted fname becomes the title case version of the first name, and the same thing happens with the last name. So we now have a formatted fname and a formatted lname, and that is what's going to be returned as the output. Now, once that's completed, that output replaces whatever was in between the print statement, which is where we called this format name function, and this is what gets printed into the console. As I mentioned before, we've actually already been using functions that we didn't create that have all of these functionalities, right? For example, the len function takes an input and has an output. The input is going to be a string, my name again. I seem to be really obsessed with my own name. So now this line of code is going to run this built-in length function, calculating the number of letters inside this input that we've given it, and then it's going to return the result as an output, which we can now capture inside a variable. This is the input, this is the function, and once this is completed, the return, or whatever it is after the return statement, is going to replace this part of the code. Then that result or output then gets stored inside this variable. So this return keyword is really the most important thing in order to create a function that has an output, because everything that comes after it is going to replace where the function was called.
Now, students often ask me, well, what is the difference then between a print statement and the output? Because it seems like we could use either to get to print to the output area. Well, here is the explanation if you also have this question in mind right now. Let's consider that we create a different function, and this function doesn't actually print its output at all. So let's define a function called function1, and it takes some text as input. And all it does is it outputs the original text, but it adds the original text together. So this way, if I had the word, for example, hello, then the output would become hello, hello, like an echo. So now if I go ahead and create another function, let's call it function2, and it also takes some text as input. Well, in this case, this function2 is going to return the text, but it's going to return it in title case. So we've already seen this before, and we know how this works. It's going to take whatever input it is here, make the first letter capitalized and the rest of the letters lowercase.
So neither of these functions have a print statement. So let's go ahead and call our first function and pass in a word, let's say hello. Now we can save this to a output variable and then go ahead and print it. Now you'll see I have that echo thing that I told you about earlier. But now here's the key part. What if we take the output of this function 1 and we use it as an input into function 2? How would we do that? Well, we know that the output of function 1, this, is in fact a string and it is a piece of text. So we can then put it into function 2 as the input. And we would do it like this, function 2 and then brackets. And so now the output of function 1 becomes the input for function 2, and then that input is then title cased. So now if we run our code, you'll see that not only do we have the hello hello functionality being carried out, we've also got the final text capitalized at the beginning. So that's pretty interesting, right? We're only able to do this because we understand how the return function works. And we've got two functions that have outputs, and we've effectively changed the output of one function into the input of another one. Now, this might mess with your head a little bit, so don't worry. In the next lesson, we'll take a quick look at the return keyword in more detail. Specifically, let's see what happens when we have more than one return statement in the same function. All right, for all of that and more, I'll see you there. In the last lesson, we looked at functions that return some sort of value. We created a function called formatName that returned a string. In this lesson, let's see what happens when a function has more than one return statement. When the computer encounters a line that has the word return on it, then it knows that this line is the end of the function. If I add a line of code after the return keyword, notice what happens when I run this code. It doesn't ever get executed. And this is because the return tells the computer that this is the end of the function and you should now exit the function. You can actually have multiple return keywords within the same function. And you can even have an empty return keyword. So just the return keyword without anything afterwards. So for example, we could check whether if the f name is equal to an empty string or the L name is equal to an empty string. So in this case, it means that when we called formatName, maybe we didn't give it any inputs. For example, let's say that instead of just calling the function as it is, we actually used the inputs function. So what is your first name and what is your last name? Now what happens is it'll ask us for a input, and it will take these two inputs and then call that function and return the formatted version to be printed. So now in this case, it's possible that we might have just not given it a first name or not given it a last name, and it probably shouldn't go through these lines of code. But at the moment, it's still running this function, trying to get the title case from the empty string and then printing it. And I can prove this to you by just adding an extra word in here. So again, empty first name, empty last name, and then it prints result, and then of course nothing. How can we get it to bypass the rest of the code if the user typed in an empty first name or last name? Well, we could use what I mentioned before, an early return. So we could just write return without anything afterwards, and this is going to escape the function. So it's basically going to terminate the function early. Now, this time, if I leave an empty first name and last name, you'll see it prints none, because there is no output from this to print. Now, of course, it's probably safer to actually return something that tells the developer what's actually going on, so we can give a meaningful message like return something like this. So this way we can catch the cases when something is not quite right and then exit our function instead of wasting time for it to continue working on something that we don't want it to do. We've covered a number of things in today's lesson, and I want you to combine this with your existing knowledge to tackle the challenge in the next lesson, to get to grips with this concept of functions with inputs and with outputs. Hey guys, I want to quickly spend a few minutes talking about a concept in Python known as docstrings. Docstrings are basically a way for us to create little bits of documentation as we're coding along in our functions or in our other blocks of code. Now, previously we've seen that when we use other functions, like the ones that were ready defined by Python, like the length function, I can see this little piece of documentation that tells me what this function is actually going to do, namely return the number of items in a container. So how can we create the same kind of documentation for the functions that we write? Well, we would do that using docstrings. The docstring has to go as the first line after the declaration. So here we've defined the name of our function, the inputs, and then after the colon, the first indented line will be the docstring. But that's not it. You also have to use 3 of these quotation marks, and it's in between these 3 quotation marks that you can write your documentation. We could write something like, well, what is this format name function going to do? What would we want our future selves or another user who's using this function to know about it? Well, it's going to take a first and last name and format it. Notice how with docstrings, you can actually write strings that are multi-line. Normally, if I was to create a normal string, let's say, A equals a string. If I hit the enter key, I'm going to get a warning because it's going to interpret this as the end of this line. And it won't see this closing quotation mark as being a part of this string. But when we use a docstring, we can write as many lines as we want, and it will be interpreted all as the same thing altogether, as if it was fitted onto the same line like this. Now that we've added our docstring, it's time to see what it looks like. Now, if I call this function, you can see that the text we wrote here now gets populated in the documentation. It takes the first and last name and formats it to return the title case version of the name. So this is a way for you to be able to start documenting your functions and giving each function a little bit of an explainer. Now, you can also use this as a multi-line comment. So notice how when we write a comment and we go to the next line, it becomes code again. Now, you can, in fact, use something like this where you just comment as many lines as you like, and this will be interpreted as a comment as long as it's not assigned to anything. So for example, if I created a variable, then this is now a piece of code. Because it's a little bit confusing, the official Python guidance is actually to avoid multi-line comments like this. What is actually much easier is to just write your multi-line comment and then to highlight all of it, and then to hit Command and / or Control / on Windows. That's a much better way of differentiating the comment from actual pieces of code. Have a go at adding docstrings to the other functions that you've created and see it show up when you call your functions. So we're now ready to tackle our final project of the day, and that's building up a calculator program. If you head over to the link for the final demo project, you can see how it works. So firstly, it asks us for the first number that we want to calculate with. So let's start with 5. And then it asks us to pick an operation, plus, minus, multiply, divide. So let's pick a multiply by typing the asterisk sign. Now it asks for the next number. So let's say we want to multiply 5 by 3. So we'll type 3. And then once I hit enter, it will perform the operation using floating point numbers, and then it will give us 15. So 3 times 5 is 15. But now it asks us type Y to continue calculating with the previous result, 15, or type N to start a new calculation. So let's try the first version first. Let's type Y, and now it asks us again to pick an operation. So notice how this is repeated, same as here, the step 2 here. So now I'm going to pick a different operation. Let's say add, and now I'm working with 15, so 15 plus, let's say 15 plus 5. And let's hit enter, and now it calculates our final result, which is 15 plus 5 equals 20. So notice how in this version, it took the result of the previous calculation as the first number instead of asking us for it. And then we picked an operation, and then we added the second number, and it performed the calculation. So now we can continue working with the previous result, or we can type N to start a new calculation. And again, we loop back to the beginning, and we can start typing our first number, our second number, etc. So that's the goal for the final project. But before you do that, there's something I want to show that you can do with functions. So here I've created a function with the name add. It has two inputs, n1 and n2, and it outputs or returns n1 plus n2. So you'll notice this is one of the pieces of functionality that's going to be used in our calculator. How to pass in two numbers, perform the addition functionality, and then output the result. Now, we've seen functions declared like this before, but what you might not have seen is the ability to store a function as a value of a variable. So what does it mean? Well, let's say I decided that adding numbers was my favorite operation. Now, this is a variable name, and you've seen us create variables like this lots of times, right? I could say my favorite operation equals 3, or my favorite operation equals hello. I can add strings, I can add various values to the right-hand side of the equal sign to add a value to a named variable. Now, what you might not have seen is you can also do this with functions. However, if we want to store a function as a value, we can't add the parentheses because, as I mentioned before, we trigger a function with the parentheses. The parentheses are also obviously for adding in inputs, but if we just want to store a function to another name, give it another reference, then we would do it like this, without the parentheses, only with the name of the function. So now what I can do is, because that add function is now stored under a new reference, my favorite operation, I can now trigger that function as if I was using the add function. So 2 and then comma 3, and if I go ahead and print out the output of this result, you'll see I get 5. So this is pretty neat, and it's going to be pretty important in order to create our calculator. So now I want you to perform the first challenge, and I'm going to go through the result of the first challenge so we set you up correctly for tackling this project. So the goal is to first, I want you to do this. I want you to write out the other 3 functions. It's going to be subtract, multiply, and divide. So based on what you know about functions with inputs and outputs, and also obviously these 3 mathematical operations, create the other 3 functions: subtract, multiply, and divide. Pause the video now. Okay, let's go through this because this should be relatively easy to do. So let's first create subtract, and we again are going to use n1 and n2. And in this case, we're going to return n1, the first number, subtract the second number, so n1 minus n2. And then we're going to create multiply, again n1, n2. and we're going to return n1 multiply, so asterisk, n2. And finally, we're going to create divide, and we're going to write n1 and n2, and we're going to return n1 divide, which is the / n2. So there we have it. We've got the other 3 functions created. Now, PyCharm's screaming at me because I don't have enough spaces between the functions, but I'm going to write a lot more code, so I really want it to be compact, so we're just going to ignore that for now. Now, the next challenge I have for you is to add these 4 functions into a dictionary as the values. So the dictionary will have the keys of this. Plus is one key, minus is another key, multiply, and finally divide. So these are the 4 keys. So pause the video and see if you can figure out, remembering what you learned about dictionaries in previous lessons, how to store each of these functions as a value in a dictionary with these 4 keys, and obviously storing each function under the corresponding key. Pause the video and see if you can complete this challenge. Okay, let's go through the solution for this. Let's say I decide to create a dictionary called operations, and I'm going to save this as a dictionary. So I open up my curly braces to signify that I'm creating a dictionary. Now, I mentioned that there are going to be 4 keys, right? So plus, minus, multiply, and divide. Now, relative to each of these keys, I'm going to add the corresponding values. And I do that using the colon symbol. So the value for the key plus is going to be the function add. And then I add a comma, and I can do this for all 4 of my functions. Again, remembering not to trigger the functions because we're storing it and we're not using it, so we don't want the parentheses. So let me finish that for the rest of them, and finally for divide. So now we've got all 4 of these functions for our calculator stored inside a dictionary called operations. Now, just as we're able to trigger a function that's stored under a variable name, as you saw before, we can do the same with these functions stored inside our dictionary. So the final to do that I'm going to ask you to do before we let you go and do some independent work building this project is to use the dictionary operations to perform the calculations. So I want you to try out multiply. And I want you to multiply 4 by 8. And to do this using the dictionary. So see if you can figure out how to do this using what we've covered so far in today's lesson, and also your knowledge of how to use dictionaries and how to access their values through their keys. Pause the video. If you need a hint, go back to the lesson on dictionaries and see if you can figure it out by yourself without watching the solution. Pause the video now. Okay, so you might remember that the way that we access a value from a dictionary is we first tap into the name of the dictionary, we add a set of square brackets, and then inside the square brackets, we type the key word for word. So in this case, if we want to multiply, our multiply function is stored under the key, which is this asterisk. So now, if I go ahead and just print this value as it is, you'll see that I get a function called multiply. So that doesn't give me any results. But if this part is equivalent to this, then that means this is equivalent to this function. So now if I want to use it, I just need to add the parentheses straight afterwards. And you can see my PyCharm hints already knows what I'm trying to do. And it's asking me for n1 and n2. So I want to multiply 4 by 8. So I'll just type 4, 8. And then now if I run this code, you'll see that it's taken the 4 and the 8 and it has applied the correct operation, which is multiply, and put them inside this function to return the value 32, which then replaces this entire function call and then gets printed out into the console. So now that we figured out how to do this, the rest is up to you. So take a look at the bullet points for the functionality that we need for this calculator and look at the demo software to see what you need to build, and then pause the video and using the starting file, complete the project by yourself. Pause the video and complete this project. Okay, let's walk through the solution together so that you can check your code, and also if you get stuck, it'll be a good place to try to get unstuck. So I'm going to work through the functionality I've listed out one by one. That way we can keep track of what's going on and make sure that we achieve all of the requirements of this project. So the first one is program asks the user to type the first number. So that is going to be an input of some sort, and we're going to say, what is the first number? And then we add a colon, add a space so that they can type it in, and we'll save this to a variable called num1. Now next, the program is going to ask the user to type a mathematical operator. So plus, minus, multiply, or divide. So now that's going to be another input, and this is going to be pick an operation. And then we're going to put a space. And now we're going to save this inside a variable, which I'll call operation symbol. Now, how does a user know what to type? How do they know that they need to type one of these symbols? Well, if we look at the demo, you can see that we actually list out all 4 of the operators for them, and that way they'll know which symbol to use. So how can we do that? Well, we could use our existing dictionary called operations to give them an idea of what to type. So we could, for example, use what we've learned about looping through dictionaries. For symbol in operations, and then for each of the symbols, we know that when we loop through dictionaries, it just gives us the key as the binding to the first variable. So then we can simply just print out the symbol. So let's run this file as it is and see our first input trigger. And then we've got each of our keys in our operations dictionary being printed out. And finally, we get to the input where it asks us for the operation symbol. So now we're ready to tackle this sentence, which is program asks the user to type the second number. So let's go ahead and save this to a variable called num2. And it's again going to be an input, which is going to say, what is the next number? And then remember that with numbers, such as num1 and num2, we need to actually use it as a number in order for our mathematical operations to work. Because at the moment, if we try to do, for example, num1 plus num2, it's going to treat them as strings. So if I try to add 3 to 3, it's going to give me 33 instead of 6. And so in order for that to not happen, we need to turn these numbers into either integers or into floats. Now, because we've got division and we've got subtraction and we've got multiplication, in order for our calculators to be a little bit more mathematical and scientific, let's go ahead and turn each of these numbers into floats. So I'm going to wrap the input for num1 and num2 both inside floats. And now we're ready to tackle the next part, which is where the program is going to work out the result based on the chosen mathematical operator, and obviously work it out based on num1 and num2. So that is where the part comes in that we prepped for. We know that we can get hold of the name of these functions by tapping into the relevant key. And notice that we printed out each of these keys for the user so that they would pick it for their operation symbol. So that means we can use this operation symbol as the key selector to pick out the correct operation. And that's why we went through this whole process of setting up the dictionary and setting up the methods. So here, if we go ahead and simply just print the operations, which is our dictionary, and then using the square brackets, passing in the operation symbol as the key, you'll see that if I type plus, and it doesn't really matter which number, you'll see the function that gets picked will be add. But if I pick a different operation, say this one, then the function that gets selected will be multiply. And all we need to do to activate it is to add the parentheses, and then the two numbers that we're going to pass into any of these functions will be n1 and n2. So let's pass num1 for n1 and num2 for n2 so that these user-generated numbers gets placed into whichever function they desired, and then it will output the result of that calculation. So let's run this code and try something like, again, 3 plus 3. And now we get 6, which is a lot better than before. Now, notice that in the demo, when we do the same thing, it gives us the whole calculation, which I think is quite nice because then the user sees the entire equation. So let's replicate that in our code as well. So instead of just printing the result, let's go ahead and create a f string and place this calculation inside a set of parentheses. Alternatively, you can place it inside a separate variable if you think this makes it easier to understand and easier to read, and then we can simply place the answer into the f string. So our equation is going to be num1 and then space and then the operation symbol and then space and then num2 and then finally equals, and we get to the answer. So let's try this again. 3 plus 3, we get this whole equation printed out, which is kind of neat, I think. So the next part that we need to tackle is the program should ask the user if they want to continue working with the previous result. So this answer keeps the result from the first calculation, num1, whatever, num2. Now, if the user wants to continue working with that number, as is usual in most calculators, then we want to ask them that question right about now. So we're going to use an input and we're going to say type y to continue calculating with, and then we'll insert the answer from the previous step, and we'll say or type n to start a new calculation. And that way we can get hold of their request. Do they want to restart and type in n1 again? Or do they want to simply just type an operation symbol and a num2 and use the previous answer as num1? Now we need to do something about this input. So let's save it into something called choice. And we can save the choice, which we know is going to be y or n, and we can check the choice. So if choice equals, and we'll check first for y, and then in that case, that means they want to continue working with the previous answer. And so what we'll do is we'll set num1 to equal the answer. And what we need now to happen is to get them to get the symbol and the next number and then print all of this out. So something like this. But as you notice, this is kind of repetitive. So what do we do when things start repeating? We write a loop, or we use some sort of programming way to save us from typing out or having lots of repeated code. So we could have a variable called should accumulate, so that we could decide whether or not we should accumulate the answer to the next round of calculations. And while that is true, then we will perform all of this functionality and get to the end here. And if again the answer is y, we set num1 to equal the answer from this step. And then because it's a loop, it's going to go all the way back to the top. So that means that this num1 here can't be inside the while loop. And so we need to take it outside so that it doesn't overwrite this part of the code here. So this part will loop. This part will start at the very beginning when the code starts. So now let's run our code file and see if all the functionality up to this point works as expected. So I'm going to add 3 to 3, and I'm basically going to keep doing this. So I'm going to type y to keep calculating, and again I'm going to add 3. So now you can see the next stage, they're taking 6, which is the answer from the previous stage, plus the new number that I wanted to add, using the operation that I selected to calculate the new answer. So let's try a different operation. Let's say we've got 9 and I want to divide it by 2. And now I get 4.5, which is kind of nice because I've got floats now. So the next thing we need to tackle is what to happen when the user types n. At the moment, not what we want, because we actually haven't got anything that addresses it. So let's write an else statement. And we know that we've got this variable that controls the while loop. So let's go ahead and set it to false if the user no longer wants to accumulate the answer and continue calculating. Now at this stage, it's probably also a good idea to have some new lines so that it separates what the user was doing before. So this way we get that illusion, like what we see here when we type n, that we restart from the beginning. So once that's done though, what we need to do is to start all the way from up here. So how can we do that? Well, what if we take all of this code and wrap it inside another while loop? Now, while that would work, it might be a little bit confusing. And there's actually a slightly simpler way of doing this. We could create a function called calculator. And this function is going to include all of this code. So I'm going to select all of it and then indent it in one go. Now, what I'm going to do is I'm going to call this function inside itself. And this is something in programming known as recursion. So if you solved this project using another while loop, that is perfectly acceptable and it's a perfectly good answer. But while we're here, another wild joke, I want to show you how you can also use recursion. So we've got this function called calculator, which we obviously need to call outside the function so that it runs after the program starts. And then at this line, it sees it, and then it goes into the definition and starts running all of these lines of code. But once it gets to here in the else statement, we're going to call calculator again. And what that's going to do is it's going to go to the very beginning of the calculator and try to run all of this code. And it will continue recursion until the user decides to choose something else. So let's try out this functionality, our upgraded calculator. Let's try 4 multiplied by 5 equals 20. Let's type n so that we start a new calculation. We've got all the space added between the previous calculation to appear as if we're starting from the beginning. And then we'll try and do a different calculation. What's 3 divided by 2? And now we could type y to continue working with that 1.5, or we could type n to start a new number. The only final thing we need to do is just to add the logo so that when the calculator restarts up here, we actually see the logo. So let's first do our import right at the top, and the file is, as always, called art. And once we've got that, we're going to make the print statement for the art.logo the first thing that happens in our calculator program. So let's do a final rerun, and you can see we've got our calculator with our nice little logo, and then we got our calculation abilities. We can either accumulate to continue working with the previous numbers, or we can simply type no to start calculating with a brand new number. So there you have it. That is the calculator program in its entirety. And if you want, you can always improve these projects. They are, as I say always, they are learning projects. So they're trying to get you to use some piece of knowledge that you learnt during the day's lessons or previous lessons. But they're not perfect projects. And if you wish, you can always write more code and do more research, search the internet to make it your very own version. But if you're satisfied with what you've learned from this lesson and you've understood all of it enough to be able to build this project or be able to understand the solution code and go back to build your project, then I'm happy that you've managed to get through today's content. So all that's left to do is rest up, and I'll see you tomorrow.
Hey, well done. You've completed day 10. That's a lot of progress. Now, tomorrow is a big day because there's the capstone project coming up, your very first one. And before that, you really need to get a good night's sleep so that your brain is refreshed and you're ready to go. So here are some of my tips for getting a good night's sleep. Firstly, don't set a wake alarm, set a sleep alarm as well. Have an alarm that tells you when it's time to start winding down, because we all know how easy it is to just keep watching YouTube video after YouTube video. I do that myself. Now, another really good idea is to avoid looking at a lot of screens about an hour or 2 hours before you go to sleep. The amount of blue light from the screens, even if you have night shift on, can make it really hard for your brain to start winding down and want to go to sleep. So one of the things I do is I actually have this, I don't even know what this is normally used for, but it provides a filter that gets rid of all blue light, and I sort of just walk around like this at night. So you can try this, or you can basically just read a book instead of looking silly like I am. And the important thing, but make sure that you get enough sleep and you get good quality sleep and that you're prepared and ready to tackle the next day. So have a good night's sleep. Good night from me, and I'll see you tomorrow.
Hey, it's Angela here. Congratulations on making it through the first 10 days. Today, I've got something very special lined up for you. Our first capstone project. Today we'll challenge you to apply everything you've learned so far into one big project. You're going to need to dig deep and apply all your Python skills for this capstone project. But by the end of the day, you'll have built an awesome blackjack game to enjoy. This is probably going to be one of the hardest things you'll build yet, but at the same time, the end result is also going to be the most fun. The final project you're going to be building is blackjack. And if you head over to 247blackjack.com or search for any other free online blackjack game, you can hit play and you can click deal for the dealer to give you some cards. The game is really simple. Essentially, you're trying to get as close to 21 as possible. And all of the cards which have a jack, a queen, or a king count as 10. So you're adding these two cards up, 5 plus 10 equals 15, and you're trying to figure out if you can risk getting another card. So I'm going to click hit, and I'm going to get one other card, but that takes me over 21, and so the dealer wins. So this is the game that we're trying to create. This is what your version of blackjack is going to look like. Now the user interface is a little bit simpler, but it's just as fun to play with. So our first two cards are a 9 and a 10, and it also shows us one of the computer's cards. Now I'm already on 19, 10 plus 9. I'm close to going over 21, so I'm going to type N and end the game right there. I end on 19, the computer ends on 18, and because 19 is greater than 18, that means I win. Have a go at playing the final game, but once you're ready, head over to the next lesson so that we can actually build this game ourselves. For all of that and more, I'll see you on the next lesson. Have fun. All right, let's talk about the mechanics and the program requirements for the blackjack game that you'll create. For those of you who are not familiar with the game of blackjack, also known as 21, I'm just going to spend a few minutes to go through the rules with you. Blackjack is a game that's played using cards. And the goal of the game is to add up your cards to the largest number without going over 21. If the cards in your hand add up to more than 21, then it's called a bust, and it means that you lose immediately. And it doesn't matter how much you've gone over 21, as long as it's over 21, then you lose. Now, the way that the cards are counted is that all the cards from 2 to 10 count as their face value. So a 6 is a 6, a 9 is a 9, etc. But the jack, queen, and king each count as 10. And the other special card is the ace. Now the ace can either count as a 1 towards your total, or it can count as an 11. And depending on whether if you've gone over 21 or whether if you're under 21, you can decide which value you want your ace to represent. Let's play a sample game. Let's say that the dealer over here got a 10 to begin with, and you got a queen, which also counts as a 10 to begin with. So these are the first cards that are dealt, and both of these cards are revealed. And then the dealer deals another card to each of you. Now the dealer's second hand is concealed, so you can't work out what their total is, but you can see your own card. So at the moment, we don't know what the dealer has. It might be 10 plus anything, but we know that our score is 13, 10 plus 3. At this point, you might ask the dealer for another card. So now you have 3 cards, and luckily it adds up to 20 without going over 21. But there is also a possibility that you might have gotten a card that would have pushed your total over 21, at which point you now lose. And it doesn't matter what the dealer has in their hand, you've already lost because you've gone over 21. Now let's say that we got lucky and our total adds up to 20. Now at this point we say we don't want any more cards, and the dealer reveals their hand. If, like in this case, they end up with 20 and we have 20, then we end up in a draw. So whenever your score equals the dealer's score, then you will draw rather than win or lose. Now, if on the other hand, the dealer ended up with an ace, which we know can count as an 11, And they actually scored higher than us. They have 21 and we have 20. Well, in this case, we would lose. Now, the rules also state that if the dealer ends up with a hand that's smaller than 17, so 16 or under, then they must take another card. Those are the basic rules of blackjack. But I recommend that before you get started, head over to the link that's in the blackjack starting file and have a few games of blackjack, just so that you can see for yourself how it actually works and how you win and how you lose. And then head over to the final version of the completed project and play our simplified version of blackjack. This way, you'll see what the end result is that you're trying to create, and it will be easier when you're creating the code yourself. Now, as I mentioned, we're going to try and keep our version of blackjack a little bit simpler, and we're going to assume a couple of things. The first thing is that the cards that we're starting with comes from this list. You'll notice that I've got 2 through to 10 all represented in the list. And then I've got Jack, Queen, and King represented as 10s as well. So this means that the 10 has 4 times the probability of occurring compared to the other cards. Now the ace is going to start off being represented as 11, and it's going to count as 11 until the user goes over 21. Now finally, we're going to assume that we have an infinite deck. So it means that when a card is drawn from the deck, it's not removed from the deck. Whereas in a real casino, they have maybe 6 or 8 decks of cards. When a card is drawn, then there's less probability of that same card occurring again. And this is how professional card counters, the people that the casinos hate the most, actually go about trying to optimize and improve their chances. But in order to keep things simple in our game, we're not going to deal with things regarding probability or removing cards from the deck. We're going to assume that each of these cards in the list have equal chance of occurring. If you head over to the starting project, you'll see each of these rules written out in more detail. Take a look at it so that you're aware what our house rules dictate. Now, if you scroll to the very top of the Blackjack project, I've given you 4 tracks. So just as when you start a video game, you have the choice of normal, hard, extra hard, or expert, it's the same in this project. You can limit yourself to using only 1 hint if you are at expert level in Python. You can only use hint 1 and 2 if you want an extra hard challenge and maybe a little bit of a cry at the end. There's also hard and normal. So I'll leave the choice up to you. And if you scroll down, you'll find all the hints listed in here. Now, I recommend everybody, no matter your experience, everybody should try out the Blackjack game and also look at how the final project is supposed to work. But then I've got other things such as a list where I've broken down the program requirements. You know how we always say when you have a big problem, always try to break it down into smaller pieces. Now you can, of course, create this list yourself by exploring the game, exploring the final project, and then writing your own to-do list of things that need to be coded up. Or alternatively, you can look at the one that I've created inside hint 2. Inside hint 3, I've created a flowchart for you, which takes the to-do list and breaks it down into a flowchart where you can look at the logic in more detail. Now, of course, as always, it's a good idea to create your own flowchart using a tool like draw.io or using a piece of pen and paper. But if you need help, it's there for you, and you can download the PDF and read through it. Now, the rest of the hints will go through how to solve this project in even smaller bite-sized chunks. Depending on your own level of Python at the moment, choose your own difficulty level. But I just want to say before you get started that this project is difficult, and I wanted to give you a bit of a challenge and to push yourself so that you get stronger. But there will inevitably be moments where you will have doubt and you will be wondering, what am I doing? I don't understand anything. And in this moment, I want you to look yourself in the mirror and tell yourself that you got this, you can do it. And that remember that I'm here rooting for you. I believe you can do it. You've got everything that you've learned so far will enable you to do it. There's nothing new in this challenge. You just have to put all the pieces together. You have to push through the difficult parts and maybe sleep on a problem and think about it and then come back to it. But I believe you can do it. Once you're ready, pause the video, head over to the starting project and give it a go. And once you're satisfied, then head over to the next lesson and I'll walk through the solution with you. All right, so how did that go? I hope it went really well and you've managed to complete it all by yourself. If you got stuck, I really recommend just having a sandwich, have a cup of tea, take a break, and then come back to it. You'd be surprised what your brain can do when it just has a little bit of rest. But I want you to make sure that you've really given it a proper go before you come here and watch the solution. Because I'm going to walk you through the solution step by step in case there are little bits or something that you didn't understand or something that you want to check. But I really, really hope that you've managed to tackle most of this yourself. All right, so without further ado, let's get started coding up our Blackjack project. Hopefully you've already used hints 1, 2, or 3. And I'm going to get started with hint 4 and build up our Blackjack project step by step. Now, the idea of the hint 1, 2, and 3 is to get you to create these small to-dos of your own so that you can have practice breaking down the problem into a list and then breaking it down into a flowchart and then breaking it down into smaller bite-sized to-dos. So let's start out with the first one. We have to create a deal card function that uses the list below to return a random card. And 11 is going to be the ace in this deck. So let's get started and we're going to go and create our deal card function. Now this function is going to contain these cards. So I'm going to go ahead and paste it in, make sure it's indented so it's inside the function. And now I'm going to use these cards to randomly pick one out of this list. So to do that, we can of course import our random module. And then I'm going to use random.choice to pick a random card from my list of cards. And then this of course has an output, this random.choice. So I'm going to save that output, namely the random card, inside another variable called card. And then finally, we're going to return this chosen card as the output. So that's step 4 done. Now let's move on to step 5. So we're going to deal the user and computer 2 cards each using the deal card function. And very helpfully, the hint tells us that we can start out with a blank user card and a blank computer card list. So we basically just have to add 2 cards to each of these lists. To do this, I'm going to use a for loop and I'm going to use the range operator to run this for loop twice. So you've seen this syntax before when we talked about for loops, and I've got an underscore here because we don't actually need this particular variable. All we need is for this loop to run twice, and this code is going to achieve that. Every single time this loop runs, we're going to get a new card by calling deal card. Now remember that deal card has an output. It outputs a random card. So if you want, it's actually quite helpful to add some documentation to this. So we could say returns a random card from the deck. And now when I write deal card, you can see that the doc tells me that this function is going to return a random card from the deck. So that random card is going to replace this function call so we can capture that data by storing it inside a variable. So we'll call that new card and set it equal to the output from the function deal card. Now, the next thing we're going to do is we're going to add this new card to the user's cards. So at the moment it's an empty list and all we have to do is say user cards dot append, and then the object that we want to add to that list is going to be the new card. Now, some of you might be tempted to instead use the plus equals. you might want to write something like this: user cards plus equal new card. And I want to show you what actually happens when you run this, because this is a really common error. We get a traceback and we get a type error. It tells us that the int object is not iterable, and it highlights this line 49 as the reason for the error. So what's going on here? Well, this plus equals is actually shorthand for writing the extend function. Now you can see that the extend function is something that extends a list by appending elements from the iterable. So what does this mean? Well, it means that whatever you put inside this parentheses, it has to be a list itself. For example, if this new card was a list of cards, so maybe just the first dealt card and another card, or even just it by itself inside a set of square brackets, which turns it into a list, well then if we run this code right now, we no longer have any errors. And if I convert this back to what you saw before, which is using the plus equals, we also have no errors. But when you only want to add a single item, not a list, to an existing list, then you have to use append. So hopefully you didn't have this issue, but if you did, this is the reason. Now that we've created these two lines, you can see that it's a little bit redundant because we're creating this new card variable just to hold the output from this function. And then we're immediately putting it into this list using the append. So instead, we can actually just get rid of the middleman and put deal card directly inside the append. And this does exactly the same thing in a single line of code. Once we've done this for user cards, we'd probably want to do the same thing for the computer's cards. So computer cards.append, and then we call deal card again, remembering the parentheses. So we've got a total of 3 parentheses at the end. And this way, we deal a new card, and that new card gets appended to the end of this list. All right, so now let's tackle hint number 6. We're going to create a function called calculateScore that's going to take a list of cards as an input, and then it returns the score after calculation. And it tells us that if we get stuck, we can look up the sum function to help us. So let's create a function called calculateScore, and this calculateScore is going to take some cards as an input, and then inside the body, it's going to calculate the total of all the cards in this list. So if we take a look at the sum function in Python, the way that it works is you can put a iterable, so like a list, inside the parentheses as an input, and then it's going to add up all of the items in the list, and it's going to return the total. Back in our code, we can simply write sum, and then inside these parentheses, we can pass over the cards and we can return this value as the output. Basically, if we had cards equal to a list with 1, 5, 3, 4, then this sum function is going to end up being equal to 1 plus 5 plus 3 plus 4, which is going to be equal to 13. And then that will become the output of this function. So now let's move on to hint 7. A blackjack only happens when we have a hand with only 2 cards, and those cards have to be an ace and a 10 value card. In our deck, we know that an ace is represented by 11, and we have a number of 10 value cards. So there's a number of ways that we can check for this blackjack. One of the ways is by checking to see if the 11 is in our deck of cards. And then we can combine that with an AND to check if the 10 is also in our deck of cards. And finally, we can check to make sure that we've got a hand size of 2. So we can check that the length of our cards is equal to 2. And this would represent this logic: a hand with only 2 cards, an ace, which is represented by 11, and a 10. Now, on the other hand, we could actually also simplify this, because a hand with only 2 cards that must contain an 11 and a 10, we can, instead of checking for both 11 and 10, we can check to see if the total, so if we summed the cards, and if this was equal to 21, then it would be exactly the same thing, right? 10 plus 11 is 21, and we've still only got a deck of 2. In this case, what we want to happen is we want to return 0 instead of the actual score. So this way we can indicate that the user or the computer has got a score of blackjack. That's hint number 7 sorted. Let's move on to hint number 8. It tells us that inside calculate score, we should check also for an 11, which is an ace. If the score is already over 21, then we should remove the 11 from the cards and we could replace it with a 1. Because remember that an ace can count as an 11 or a 1. So in the beginning, when the user's score is very small, then we probably want to count it as an 11. But once the user goes over 21, then we probably want to change it and count it as a 1 instead, so they don't go over and they don't lose. Let's first write the if statement. So if there is the 11 inside our deck of cards, and the sum of the cards, so the total score, is already over 21, then we want to do something about it. And the hint tells us to look up the append and remove functions. So we've already seen the append function many times, and we know that it just adds a single element to the end of the list. Now the one that we haven't used a lot of is the remove function. And this will search for the first instance of the given element and removes it out of the list. This is kind of what we need to do. We need to go ahead and remove the 11 from the list of cards. So we can write cards.remove, and inside the parentheses, we use the 11. And then we do cards.append so that we end up adding a 1 instead of the 11. This way, we remove the 11 and replace it with a 1. And hopefully our cards will now take the user to below 21. Now let's move on to hint 9. So we want to call calculate score at some point in our code. And if the computer or the user has a blackjack, or if the user's score is over 21, then the game is going to end. This might be a good time to start tidying up our code a little bit, because we've got our function over here, the calculate score function. And remember that you can only call a function after it's been declared. So for example, if I wanted to call this function over here, then I actually can't. I can't say calculate score because it hasn't yet been declared. So instead, what I'm going to do is I'm going to take this function and I'm going to move it to where we dealt our cards. So now that I've moved my function to above the line where I want to call it, it's now become valid code. And this is the place where I want to call it because it's only after I've dealt the user and the computer some cards can I actually calculate their scores. Firstly, I want to calculate the score using the user's cards. So this list of cards from the user gets passed into this function and uses all of the logic to output some sort of score. And then I'm going to store that score in a variable, which I'll call user score. And I'm going to do the same thing for the computer. So computer score equals calculate score. And remember, it's always helpful to add a little bit of a docstring to tell ourselves and other programmers what this function does. Let's quickly summarize it. So this function is going to take a list of cards and return the score calculated from the cards. So now when I open that parentheses, I know that I probably have to pass in my list of cards in order to get back the score. And now we've got the user's score and the computer score. So this score could equal 0 if they got a blackjack, or it could just simply be the value of the cards that they hold all added up together. Now that we've called calculate score, we also want to make sure that if the computer or the user has a blackjack, or if the user score is over 21 then we have to end the game. Let's write our if statements. If the user score is equal to 0, or the computer score is equal to 0, or the user score is greater than 21, then in this case, we're going to tell the game to end. So we could create a new variable called isGameOver, and we start out with false, of course, but then when this happens, we're going to change that variable to true instead. Our isGameOver variable is just a simple Boolean. It starts out as false, and when certain conditions are met, then we change it to true. Now at the moment, our program is not finished, so it's not really obvious how we're going to be using this isGameOver variable. But we're setting ourselves up for the next steps. Now that we're tracking if the game should end, we can look at this value to determine what to do next. So that's hint 9 completed. Let's test our code and see how everything works so far. I'm going to add some print statements here so that I can see what the user's cards are and what the user's score is. Using an F string, I'm going to show your cards, so the user's cards, and the current score. And I'm also going to print the computer's first card. Remember when I first explained the rules of blackjack, the dealer will reveal their first card. So you get a little bit of a clue as to what kind of hand they might have. So in here, we're going to insert the computer's cards, and we're only going to pick out the first item. So the one at index 0, and we do that using a square bracket after the name of the list. Let me just change that typo there. And now we're ready to give this program a run to see how it works. Now we've got our first cards showing, which is the user cards, and it's a list of 2 cards, a 3 and a 2. 3 and 2 adds up, of course, to 5, so the current score for the user is 5. Next, it shows us the computer's first card, and that is a 4. Now we can be reasonably assured that our code is working. And it's a good idea to regularly test your code so that you don't wait until the end when there are a lot of problems and you don't know which part of the code is responsible. Now let's move on to hint number 10. It says that if the game is not ended, ask the user if they want to draw another card. If yes, then use the deal card function to add another card to the user's card list. If no, then the game has again ended. Over here, in the if statement, we can add an else, because if the game hasn't ended, as in they haven't gone over 21 or nobody's got a blackjack, then we're going to ask the user if they want to get another card. I'm going to use a input, and I'm going to ask the user to type Y to get another card, otherwise type N to pass, and I'm going to save this input inside a variable, which I'll call user should deal. Now we can check to see if this variable is equal to Y. Well, in that case, we're going to add another card to the user's card list by doing the same thing that we did in the beginning, where we dealt 2 cards to each player, by saying usercards.append, and inside the parentheses, the thing that we want to append is the output from deal card. So just a quick check to make sure you've got all the parentheses there, and then we're ready to address the else. If they didn't type Y, then that means they don't want another card. Well, then in this case, the game has again ended. So we can say isGameOver equals true. Let's take a look at the next step. How can we get our game to repeat itself? So hint number 11 tells us that the score will need to be rechecked with every new card drawn, and the checks in hint 9 need to be repeated until the game ends. Notice how we've got this flag, isGameOver, which is set to true whenever the game ends. It starts off being false, and what this means is we can actually create a while loop, which basically keeps on calculating the user's score and the computer score, makes all of these checks, which are in hint 9, and then repeats itself until the game ends. Let's go ahead and do that. After all the initial setup, we're going to create a while loop. And the while loop is going to be active until the game is over. So we can say while not is game over, then go ahead and carry out all of these instructions. So calculate the user score, calculate the computer score, check that nobody's gone over 21 and nobody's gotten a blackjack. And if the user wants more cards, then they should. If they don't, then the game is over.
So let's go ahead and run and test our code. You can see that the first two cards we get are 10 and 5, which makes up a score of 15. So 15 is kind of nowhere near 21. So let's go ahead and type Y to get another card. You can see that our while loop is active and it goes back to getting another card. And we end up with 10, 5, and 10, which unfortunately means that we're over 21 and so we lose. But if I tried this and I typed N, then you can see the game ends immediately.
That worked perfectly. So now let's go back and tackle the next part. Hint number 12 says once the user is done, it's time to let the computer play. The computer should keep drawing cards as long as it has a score less than 17. So the while loop is responsible for dealing with when the user wants to keep drawing cards. But once that's done, then we can tackle hint number 12, which is how does the computer actually play? What is its strategy? Well, we know that the computer has to keep drawing cards as long as it has a score of less than 17. But of course, 0, which represents a blackjack, is also less than 17, but we don't want it to draw a card if it has a blackjack. We can represent this logic using a while loop. While the computer score is not equal to 0 and the computer score is less than 17, then in this case, we want to keep drawing cards. We're going to take the computer's cards and we're going to use the append to add a card by dealing another card to the computer. And then we're going to recalculate the computer score so that it updates and this while loop is evaluated on the latest score. So the computer score is going to equal calculate score using the computer's cards. And that means that the updated computer score is equal to the return value from calculate score.
Now, one thing you'll notice here is that we've got a warning underlined for the computer score. And when we hover underneath it, it says the name computer score can be undefined. So what does it mean here? Well, notice that we first define this variable computer score inside this other while loop. Now we're hoping that hopefully this happens first, and by the time we reach line 46, we already have a value for computer score. And this will happen in pretty much all cases. But just in case there is a glitch and there is no value for computer score, or even in the case where this entire while loop is skipped, then this computer score will be equal to undefined. It won't actually exist. That variable won't have been created for us to check whether or not if it equals to 0 or if it's greater or less than 17. So how can we fix this? Well, right up here where we've got our user cards and computer cards, where we defined all of our empty variables, we should go ahead and define this computer score right here. Now, we can't set it to equal 0 by default because that means blackjack in our game. So let's set it to a number that we, when we test our code, will know for sure there is an issue. Let's set it to a negative number. So notice how as soon as I've got that variable defined somewhere outside of the while loop, this warning now goes away and it will always have a value, even if it is a value that signifies there's something wrong with our code. And that will help us debug as well. Now, you'll notice that we've actually got a similar situation with the user score. The user score is only defined inside this while loop, so it's created as a variable here and only assigned as a variable here. And in future, if we want to use it, we also need to do the same thing.
So let's just also create a user score and set it to -1 as well. So now that we've completed hint number 12, it's time to move on to the next video where we're going to go through the final hints. At this point, we've created 2 while loops. The first while loop is for the user so that they can continue taking cards, and the second while loop is for the computer so that the dealer can follow their strategy. Now it's time to tackle hint 13, where we create a function called compare. We pass in the final user score and computer score, and then we compare the scores to see who has won, who has lost, or if they have a draw. So remember that in order to call a function, it has to be declared before the line we want to use it. So let's go back up and let's add our compare function here. This compare function is going to take the user score and also the computer score, and it's going to compare these 2 scores. If the user score is equal to the computer score, then we said this should mean that it's a draw. So we'll return some sort of message that represents this. But elif, or else if, the computer has a blackjack, so the computer score is equal to 0, well, in this case, we should return that the user is lost and the opponent has a blackjack. And then we go through this list and we add in all of these other conditions. So I'm going to speed it up a bit. Now for the final condition, it says that the player with the highest score should win. So we can write an elif that compares the user score against the computer score, and we're basically saying if the user score is greater than the computer score, well then that means that the user wins. But if that's not true, and because we've covered everything else, we now have the final return, which is you lose. Now remember that if, elif, else statements are evaluated from top to bottom. Even though if the computer scores a 0, which is a blackjack, which is obviously much less than whatever score the user might have, because it's going to return at this point and it's going to exit the function, it will never get to this comparison if this is already true. If you get confused about how if, elif, and else works, especially the order in which you add the conditions, have a look back at the lesson where we talked about this in more detail. This might be a good time to revise that concept. Now, another warning that we see in our compare function is the underlines under the user score and computer score. And if we hover over them, it says it shadows the name user score from outer scope. What does that mean? Well, it means that we've decided to use the same name for our variable to be used inside our function as the name of a variable that we created outside that function. So how can we prevent this? Well, we have to rename the element as it suggests. Now, if we click on this, then it opens up the rename window, which is going to find everything that's inside this file to change that variable name. So let's say that I decide to change it to uscore and refactor. You'll notice that everywhere inside that function where I use that variable name has been renamed automatically for me. And the other variables which are unrelated to this particular usage are untouched. And this is a really nice way to rename things if you ever want to. And you can also get to that manually by right-clicking on it, refactor, and then rename. And now you can name it to whatever it is you want. So in my case, I'm just going to call it C-score for computer score. And then I'm going to hit enter and all of those changes will be enacted. But now that we've completed our compare function, we're going to use it at the end of our code here, because this is the time that the user is done drawing cards, the computer is done drawing cards, and now we can call that compare function and pass in the user score and also the computer score. So this should hopefully give us the final result as a piece of text. Let's run the code as it is and see what happens. So we start out with a 3 and a 10, making a score of 13. We can see the computer's first card is a 3, and we're asked whether we want another card. So I'm going to type Y so that we get another card and closer to 21. And now we have 3, 10, and 6, making 19. So I think I'm going to say no to pass and hope that I win. So we could probably give the user a little bit more information, like revealing the final deck, what the computer got and what we got. I'm going to go ahead and create some other print statements above this one. Maybe I'll tell the user that your final hand is this, and the final score was. And then let's reveal to them the computer's score. And then finally, we can print the user score and the computer score to tell them who won, who lost, or whether if it's a draw. So in this deck, we've got 2 and 8, making 10. So I'm going to add another card. Now we're on 16, and I'm going to try and add another card again. And now I'm on 26, so the game is very much over. And it tells me my final hand has a score of 26, the computer's final hand has a score of 20, and I lose. If we wanted to play another game, because we are blackjack addicts, then we want to give the user some sort of means of doing this, right? And that's what the last hint addresses. So we're going to ask the user if they want to restart the game. If the answer is yes, then we're going to clear the console and start a new game of blackjack, and also show the logo from art.py while we're at it. Let's go ahead and add an input. And we can ask them, do you want to play a game of blackjack? Type yes or no. So remember that this entire function is going to be evaluated, and the result or the output is going to replace this part of the code. So we can say that while the input is equal to Y, then we're going to keep playing the game. And the game is all the code between this part where we create our empty variables and where we do our comparison. So if we actually put this inside a function by indenting it over and then creating a function here called play game, well then we can actually call this function play game every time the user types Y. Now we don't want to clutter up our screen with all the previous games, so before we call play game, we also want to clear the console. And to do that, we're going to use that trick that we saw from previous lessons, which is where we print the \n, the new line character, and we multiply it by 20 times. And then we can call play game so that the code in this function gets repeated. And we also said that at the beginning, when we play game, we're going to show the user the logo from art.py. So let's go back and import that as well. So from art, import logo. And then at the beginning of every game, we're going to print our logo. That's all there is to this project. And now let's run it one final time and see the whole thing in action. Do you want to play a game of blackjack? Type Y or N. So yes, we've got our logo. And then it says type Y to get another card and type N to pass. So we're on 19. That's pretty tenuous. I'm going to pass. And I end up with a score of 19. The computer, unfortunately, has gone over 21. So therefore, I win. And we can keep repeating this to play more games of blackjack. So I hope you had fun building this game with me. I know this was a really difficult project, and I know that some of you would have probably had some issues, but I really hope that you persevered and you got through it in the end. And through the process, you've managed to apply a lot of the things that we've learned in the last 10 days. This is a good time to review the concepts you've learned and have a think about what you might need to revise or revisit so that you're really, really strong on all the concepts and you're comfortable to continue on to the next 10 days. Now, if you want to take a look at the solution code I've got here, then simply head over to the solution.py and you will see everything that I've written in here for you to be able to browse and refer to. So now rest up, well done for finishing this day. And if you haven't completed it, don't worry, there's always another day tomorrow. You can always come back. And eventually, with deep perseverance, you will get there in the end. I believe in you.
Hey, well done for completing your very first capstone project. Now, I know it was a difficult project, but it's meant to stretch you just enough so that you're still struggling, but you still have all the components that you need to tackle it. Now, in this project, we saw a lot of the things that we learned in the previous days being put into use, like while loops, for loops, functions, variables, everything all packaged together. Now, these are the fundamentals that you're learning in each of the days and each of the lessons, even though individually they seem very small. But when put together, you can create really interesting and really complex projects like the Blackjack project. So even though it was difficult and even though you had to stretch yourself, as long as you've got solid foundations, then you can continue and you'll be able to build even better things. So together, we're going to make sure that you have a really solid foundation before you continue, before we start building more fun projects like websites and data mining and data scraping and data visualization and all of that. So make sure that you review all the concepts that you've learned so far. And if there's anything that's not quite 100%, then just review the content, practice it a few times, and then continue. And you'll be so much better off for that solid foundation. So have a good rest, and I'll see you tomorrow.
Hey guys, welcome to day 12 of 100 Days of Code. Now today we're going to be building a number guessing project and we're going to be learning all about scope. So if you take a look at the final demo project for day 12, you'll see that we've got a guess the number game. So welcome to the number guessing game. I'm thinking of a number between 1 and 100. Now in the demo, there is a little bit of answer text, which you won't have in your final game, but this is just to make it a little bit easier for us to test this game. So the correct answer is 100, which we already know. Now we're asked to choose a difficulty, easy or hard. Now if we choose easy, it means we have 10 attempts to guess the number. And if we guess a number and it's too low, it'll tell us that it's too low. And if we guess a number that is too high, then it will be too high, until we somehow figure out the correct answer, which in this case happens to be 100. Now, if we go ahead and tried the hard mode, you can see we only have 5 attempts to guess the answer, and we have to be able to get there using these clues of low or high to try and guess the correct answer. So this is what we're going to be building, and in the process we're going to be covering a lot about scope, about global variables, about a lot of the stuff that we've sort of started to think about and to use in our code, but formally we haven't yet really approached. So that's what we're going to be doing, and once you're ready, head over to the next lesson. The first thing I want to talk about is a concept known in programming as scope. And this scope is something that we've actually come across already in our programming. But I wanted to leave it until we've seen functions, we've seen if and while loops, different types and blocks of code before we start talking about this really important concept. Now, if you want to visualize this concept, imagine you have a house with a fence around it and you plant an apple tree inside your garden. Think about who can access those apples. Just you and your family, right? But what if instead you had an apple tree in the neighborhood, by the sidewalk, for example? Well, this is kind of free for all. Anybody can go and access those apples. This is a starting point for how to understand scope. Take a look at the code that's in the starting file and try to understand what it's doing. First, I create a variable called enemies and I set it to equal 1. Then I create a function called increaseEnemies and I try to set that variable to 2. Finally, I call my function, triggering all the lines of code inside. And now I want you to predict, what will this print statement print in the console and what will this print statement print? And it might not be what you expect it to be. So I would expect that here I've got a variable which is equal to 1. When this function is called, this variable enemies should now be equal to 2. So when it's printed down here from outside my function, this should be equal to 2 and this should also be equal to 2. But look at what happens instead. I get enemies from inside the function equal to 2, but from the outside the function, it's equal to 1. So what's going on here? To really understand this, we have to understand the concept of scope. And scope is a really, really important thing in programming. You see it in every programming language. And although it's a little bit different between the programming languages, it all goes back to that concept of the apple tree being within a fence or outside a fence. So let's take a look at some other examples before we come back to solve this problem. The first thing to think about is a concept called local scope. Local scope exists within functions. So for example, if I was creating a game and I had a function called drink potion, which is somehow going to strengthen my player, well, maybe it would have a variable that's created inside the function. So it could be something like potion strength, and I could set that to start off with a value of 2. Now, in this case, if I was to go and print this variable potion strength from within the function, notice I'm indented here. And of course, I need to call this function for that to happen. Notice what happens when I run the code. It's equal to 2. That's what we would expect, right? But notice what happens if I try to print the potion strength from outside the function, here. This firstly gives me an error right when I'm writing it inside the editor. And when I try to run it, it gives me an error inside the console. And the error is a name error. And it tells me that the name potion strength is not defined. Clearly, I've defined it here, but why can't I access it outside the function? Well, this goes back to the concept of local scope. When you create a new variable, or indeed a new function, inside another function, it's only accessible. You can only use it when you're inside that function because it has local scope. It's only valid within the walls of this drink potion function. What if we wanted it to be accessible outside the function? Well, now we need to think about something called global scope. The only difference between global scope and local scope is where you define or where you create your variables or your functions. So let's say we have a different variable. Let's say that I created a variable called player health and it starts off being equal to 10. Now let's say later on I have the same drink potion function and this potion has strength of 2. So now inside my function drink potion, if I wanted to print my player health, even though it wasn't defined within the function, this is perfectly possible. And if I call my function drink potion and then run the code as it is, you'll see 10 being printed. So this has a global scope. It's available anywhere within our file because it was defined at the top level of the file. Now, when I say top level, I don't mean physically at the very top of the file. I mean that it's not within another function, like potion strength here. because this is defined indented inside a function. So this is a local variable, whereas this is a global variable. And global variables are available within functions, no matter how deep it gets nested, and it's also available outside of functions. This concept of global and local scope doesn't just apply to variables. As I alluded to before, it also applies to functions and basically anything else you name. This is a concept called the namespace. So we defined this variable player health. We defined this function drink potion. Anything that you give a name to has a namespace. And that namespace is valid in certain scopes. This concept of scope applies to basically anything you name. If I was to nest this function drink potion inside another function, let's call it game, well, this drink potion now has local scope within the function of game. So this is why this line is now erroring out, because it can't actually see inside this function. So now, in order to call this drink potion, I have to be within the four walls of the game function. So whenever you give name to anything, a function or a variable, you have to be aware of where you created it. Now, it's easy to notice where you've created functions. We have the def keyword, right? But when you create a variable, that's the first time that you give it a name and you set it equal to something. And where you write that line of code defines the scope of that particular variable. Here, it's outside of every other function, whereas here, it's inside a function, actually nested 2 levels deep, so it has local scope to this function. Now, unlike some other programming languages, if you've come from, say, C++ or Java, there is no such thing as block scope in Python. What this means is that if you were to create an if statement, say if 3 is greater than 2, and if you were to create a new variable inside an if block or a while loop or a for loop, basically any sort of block of code that's indented, this does not count as a fence. It still has the same scope as its enclosing function, or if there's no enclosing function, then it has global scope. So let me show you a full example. Let's say we had a list of enemies. So the enemies could be skeletons, zombies, or aliens. So now if I was to define a game level, right, like the level that the user is currently playing at, let's say they're on level 3, and I create an if statement and I check if the game level is less than level 5, well, in that case, I want to create a new enemy, but I don't want the enemy to be too difficult to beat. So I'm going to pick from the list of enemies and I'm going to pick the first one. Notice how even though this new enemy is a variable that's created within this if block, if I go outside the if block, so I'm not indented at all anymore, and I try to print this new enemy, this is perfectly valid code. And if I run the code, you'll see skeleton being printed. But notice how as soon as I embed this within a function, so let's define a new function, and now this line errors out. Because within the function there is local scope, so now this new enemy is available anywhere within this function, because blocks like if, while, for, all of these blocks of code with colons and indentation, they don't count as creating a local scope. So in order to print this new enemy, I actually have to be within the boundary of this function, which means my code has to be here. The most important thing to remember from this is if you create a variable within a function, then it's only available within that function. But if you create a variable within an if block or a while loop or a for loop or anything that has the indentation and the colon, then that does not count as creating a separate local scope. But one thing you might see when you're using some variable that is defined within a block, such as an if or a for, is you might get this warning from the linter, which reminds us how to write good Python code, that the local variable might be referenced before assignment. So it's basically saying, well, what if the game level is not less than 5? What if it was like 10? Well, in this case, if we try to run this code, this print statement will never be executed because this if statement is not true. So this variable new enemy is never created. So then what are we printing here? We're printing nothing, just air, right? So in order to get rid of this warning, what you can do is outside of any blocks, such as if, for, or while, you can declare and create that variable and initialize it. So let's create new enemy and set it to empty. Well, in this case, what it sees now is that there is a new enemy variable. It has been already created, and depending on these conditions, it might be modified, but it will always be able to be accessed. So the outcome doesn't really change, but the linter sees these situations where something could potentially go wrong and is just reminding you. So you have two choices. You can ignore it if you know what it's saying is complete rubbish because you know your code better than it does. Or you can follow its orders and simply initialize the variable before you ever use it, and instead of creating the variable inside a block that may not be accessed. Coming back to our original example, I want to talk more about the global scope and the concept of modifying something within the global scope. Here we have enemies, which is a variable that has global scope, and here we have a function which creates a local scope. Now we think that we're tapping into this variable and setting it to 2, but in fact we're actually creating a completely new variable that's entirely separate from this one. And this is why when we printed it here, it showed it was equal to 2, but when we printed it here, it showed it was actually equal to 1. If you want to make this a little bit more obvious, I can call this a skeleton, and I can set this to be a zombie. And when I hit run, you can see again, this prints zombie, this prints skeleton, because these two variables are actually entirely different things. And we're not changing this right here at all. We're just creating a new variable that has a local scope. Now, it's usually a terrible idea to call your local variables and your global variables the same name. But in this case, what we actually wanted to do was we wanted to modify this variable. We wanted to do something like maybe plus equals 1. And notice how as soon as I write plus equals 1, then my editor starts going crazy and tells me that this local variable enemies is defined in an enclosing scope, is referenced before assignment. What does that mean? It means that the editor thinks you're trying to tap into a local variable that you defined somewhere around here. And then you tried to modify it by adding 1 to the previous value, but you actually haven't defined it. What we wanted to do, though, is we wanted to tap into this variable and change it here. In order to do this, we actually have to explicitly say that we have a global variable, which is called enemies, that's defined somewhere outside of this function. And that is the enemies that we want to use inside this function. So it basically takes that global enemies into the function and allows you to modify it. Without this line of code, we cannot modify something that is global within a local scope. Now, there's a reason why it's so difficult to modify something that has global scope. You probably don't actually want to do this very often because it's confusing and it's prone to creating bugs and errors. Because this variable with global scope could have been created anywhere in your code, right? And you would be modifying it completely independent of when you created it. So it might have been days between when you wrote this code and when you wrote this code, and it just makes everything more fallible, more easy to fail. This is why very often people will tell you when they're teaching you Python to avoid modifying global scope. You can read it, that's not a problem. You can use it within your code like we are here, but don't try to modify it within a function that has local scope. But what can you do instead? What if you wanted to have this functionality, like a function that changes the number of enemies? How can you achieve this without modifying the global scope within the function? Well, you could use what we learned about return statements instead, right? What if instead of modifying the enemies, you actually just simply returned it as the output? So return the current value of enemies plus 1. Now, once you call this function, you'll get hold of the outputs and you can save it to the global variable enemies. So this now means that this function can be taken away and placed anywhere in your code, and you don't actually need to know how it works. As long as you know that this is how you increase enemies, then all you have to do is just call it. Remember, you should be careful with variables that have global scope, but don't believe the people who tell you that you should never use global scope. Global scope can be incredibly useful, especially when you're defining constants. Global constants are variables which you define and you're never planning on changing it ever again. It's just something like, for example, the value of pi, right? You want to look it up once and you want to put it into your code and you never want to look it up ever again. And every other time you want to use it, say inside a function, then all you want to do is just tap into that value of pi. So usually, in order to differentiate these constants, which you're pretty much never going to change, from the variables, which you're likely to change, the naming convention in Python is to turn it into all uppercase. For example, if you had pi or you had a URL that you needed to use, then these are all going to be uppercased, separated with underscores. What this means is that later on in your function, and you want to use one of these global constants, as soon as you type it, you can see it's uppercase and you know to remind yourself to not modify this inside your code. Now that we've talked a little bit about scope, it's time to put your knowledge into action, head over to the next lesson, and I've got a quiz that will test your understanding. So for all of that and more, I'll see you there. Now that you've completed some of the scoping problems, it's time to tackle the final project. This final project is a little bit special because now I think you've got enough experience and enough skills under your belt to actually create this project entirely from scratch by yourself. So you're flying solo now. Now, the first thing I want you to do is to play this game quite a few times actually, just so that you get a good idea of how it works. Now, the first thing it tells us is welcome, and then it tells us it's thinking of a number between 1 and 100, and then we get to choose a difficulty. So I'm going to choose hard. Now it tells me that I have 5 attempts to guess the number, and I'm going to make a guess. Now it tells me that 50 is too high. It's not the number that it was thinking, and I have to guess again. And notice how I started out with 5 attempts. I'm now down to 4 attempts. So let's try 25. So 25 is too low, but 50 is too high. So that means the number is somewhere in between there. Let's try 30. Again, too low. Let's try 40. Too high. Maybe it's 45. But I only have 1 attempt left because I went for the hard level. And as expected, I didn't manage to get the right number, and I've now run out of guesses. So I've lost. If we run again, we can try playing this on an easy level. On an easy level, we get 10 attempts instead of 5. That gives us a little bit of extra opportunity. So let's try 50. 50 is too high. 25 is too high. 10? 10 is too low. So it's between 10 and 25. So let's try 15. Now, if 15 is too high, but 10 is too low, then we're pretty close to the answer. It's now between 12 and 15. Let's try 13, 14. There we go. The actual answer that it had in mind was 14. And I had 4 attempts remaining to get the final answer, and I managed to get it at the end. Play through this game at least 3-4 times on the different levels. And remember that the easy level has 5 goes. The hard level, the user gets 10 goes at guessing the number. And look at how the code works and how it's functioning. And then I want you to break down this problem. Write a to-do list, create your own list of tasks that you need to solve, and start with the simplest one. And once you've tackled that, start putting in some comments into your code. Write down the functionality your program needs, and then write the code. And then test out your code and keep going until you've tested it and made sure that it works in all situations. So this final project has no starting code. I'm not going to give you any comments or to-dos to start off with. I want you to try and tackle this entire project by yourself. And the only thing I'm going to give you is this link so that you can try out the final project. And I know that there's a lot of ways that you can cheat, but don't do it. Have faith in yourself. If you tackle this for an hour, I'm pretty sure you're going to get there in the end. You have free reign on the styling or the wording, whatever it is you want it to say, but it has to have the same functionality. Now, this also means that if you want to get some ASCII art of your own, then you can head over to this website, which I'll link to in the course resources, and just type the name of your game. So maybe it'll be guess the number. And you can change the font that you want for it. Maybe something a little bit isometric, or maybe ogre, or maybe train, whatever it is you want. And then once you're happy with the font, you can select and copy everything that's on there. And then inside your project, you can create a new file called art.py and then create a new variable and set it equal to the design that you've got in mind. Now, in order for it to look right, you actually have to create this as a doc string. So 3 quotation marks to begin with, and then 3 quotation marks to end. And then just make sure you have enough horizontal space to display the whole thing in one go instead of it being truncated when you have a little bit of space, and you should be able to see the actual design. Pause the video now and create this number guessing game by yourself as the final project. How did you get on? Hopefully you managed to complete the project and you're just here to check through the solution. Now, if you haven't given it a proper go, and I mean at least an hour at tackling this, then go back, keep going. It's only when you struggle that you actually get better. You can watch me type code all day long and it's not going to make you a better programmer. So I know you're going to try really hard, and I want you to try really, really extra hard and make sure that you can complete each of these projects by yourself. Now, when you're creating a new project from scratch, like we're doing right now, it can seem a little bit intimidating staring at a blank screen. The first thing to do is to just divide up the project into individual components. So while you're playing this game, you can see that there are different bits of it that we need to complete, right? The first one is printing all the starting parts of the game. The next one is trying to figure out how to set this difficulty level, getting the user to type in a word, easy or hard, and then changing the number of attempts based on that. We can already start thinking about maybe we need to make a function to set difficulty. And then we need to let the user make a guess, right? So they're going to guess a number. So let's say I'm going to type in 50. And then we have to somehow check that guess against the number that was originally selected, and then check to see if it's too low or too high. So now we have some additional parts of our program, right? We need some sort of way of choosing a random number between 1 and 100. So that's the first thing that's probably going to happen in our code. We need to have a function to set difficulty. We probably need some sort of functionality to let the user guess a number. And we'll also want to check that number that they've guessed against the number that we originally had to see if it's too high or too low. So probably a function to check users' guess against actual answer. Now notice how every single time I make a guess, my number of attempts go down. So we also need to track that, right? Track the number of turns and reduce by 1 if they get it wrong. Now it's looping back again to this stage where we're making another guess. So if 50 was too high, then maybe we'll guess 25. We have to have some sort of way of repeating this part of the code, right? We're going to repeat it as long as they have attempts left and they are wrong. Now, if, however, they get it right, so I think I have a good chance of getting it right. So if 25 is still too high, let's try 12. And there we go. When I get the answer right, it tells me you got it. The answer was 12. So now we've got some of the basic parts of our code down in comments, and we can start thinking about how to write it out, right? Let's start by tackling the easiest one, which is choosing a random number between 1 and 100. All we have to do for this one is just to import the random module, or even better yet, from the random module, import the randint function. Now, inside our code, we can simply just use randint. We can say the answer is equal to a randint that is between 1 and 100. And of course, remember that randint includes A and B, so both 1 and 100 can show up. In addition to this, we probably have to give the user some of these messages. So I'm just going to copy some of these messages. So I'm going to print welcome to the guessing game. And also I'm going to print that I'm thinking of a number between 1 and 100, like that. So now we've got an answer that they need to guess, and we've got a little bit of starting text for them. The next easiest thing in this is to figure out a way of letting the user guess a number. So we know that we'll need an input to ask them to make a guess, and we can use that as the prompt. And then we're going to have to save their guess and convert it to an integer. So they're going to be typing a number here, right? And we'll call this guess. Now the user is able to guess a number. And we now have to figure out some sort of way of checking the user's guess against the actual answer. This is probably a good time to create a function. So why don't we go up to the very top and create our function here. We'll call this check answer. And we're going to pass in the user's guess and the actual answer in order to achieve this checking functionality. So in this case, we're going to check to see if the guess is greater than the answer. Well, in this case, it's too high, right? So we'll just print too high. Now, what if the guess was actually less than the answer? Still not equal to the answer, but in this case, it's too low. So now the final condition is they actually got it right. So you could write elif guess is equal to answer, but you could also just use else because there's no other possibilities. This else statement catches the moment when they actually get it right. So in this case, we're going to print what we have here, and then we're going to print out the answer. So of course, we're going to replace that with whatever the actual answer is and turn this into an F string. So now that's that step done. And let's think about what else is easy that we can knock off the list. Let's make a function to set the difficulty. So up here, in addition to our check answer function, I'm going to create this other function, some way of setting the difficulty. So let's call this set difficulty. and it's probably not going to take any input. It's just going to do some sort of action. So when we first start off the game, it already asks us to choose a difficulty. So I'm going to copy this text and I'm going to put that into an input. Choose a difficulty, easy or hard. And then we're going to save this probably into a variable, which I'll call level. So the level of difficulty that they want. Now, if this level that they chose was equal to easy, well, in this case, we want to set the number of attempts that they have to 10. So they have 10 attempts. But on the other hand, if they chose hard, then they only have 5 attempts. So this is probably a really good time for creating a global constant. So we already saw this in the previous lesson on scope, but this is a really nice thing because it means if we create this global constant at the very top, then if we want to switch around how our game works, we can really easily access these constants by just scrolling to the top of the page. Let's call the first one easy level turns. So the number of turns you get on easy, which is going to be 10. And then we'll have hard level turns, and this is going to be equal to 5. Now I've got these two constants, which is global, and I can use it inside any of my functions or basically anywhere on this page. If the level is easy, I'm going to set the number of turns to equal the easy level turns. So this is going to be a number, right? Else, so if they chose hard instead, then turns should probably be the hard level turns. Now, setting it here is no use. I actually need it inside my game. So now going back in my game, I need to let the user know how many number of attempts, how many turns they actually get. To start off, I'm going to use a print statement that just prints the number of attempts they have remaining. And it's not always going to be 5. Sometimes it's going to be 5, sometimes it's going to be 10. So what I'll need is some sort of way of tracking this number of turns, right? But how do we know how many turns they get? Well, it depends on what they chose here, right? If they had chosen hard, then turns should be equal to the hard level turns. If they chose easy, it should be equal to the easy level turns. So instead of using this as some sort of global variable, which I have to change inside here, which would require me saying global and then turns so that I can access this particular variable and change it inside these steps, it would be much, much better if I just returned these values as an output from this function. If this is set as return, then I can simply call this function setDifficulty, which is going to trigger this input. And then once the user has set it, then the output is going to be the actual number of turns they have. And I can now use it inside this print statement to show them how many turns they have. Now, I've already written quite a bit of code actually, and it's probably a good time to run the code. While I'm testing my code, it's probably a good idea to actually see what the answer is. So we can add a bit of testing code that just prints out what the actual answer was selected as. And if we run the code now, you can see we've got the starting part pretty much down. Welcome to the number guessing game. I'm thinking of a number between 1 and 100. And then we've got our little hint here. So we have to make a guess. So let's say I guessed 50. Now it's asking us to choose a difficulty. So I've already got a little bit of a problem here. I should actually have this before the other part. So I should choose the difficulty and then make a guess. So now let's stop and run and see if we've fixed that bug. And you can see, yep, indeed, it asks us for a difficulty first. So I'm going to choose easy. And it tells me that I've got 10 attempts remaining and then to make a guess. And if I choose hard instead, then it tells me I've got 5 attempts. Now, if while you're playtesting this game and you realize that actually 5 is not enough, then all you have to do is scroll to the very top of the game, change this one global variable here, and all your changes will be reflected in the code below. Now let's get back to our game. Let's say I make a guess and our code ends, right? Even though I've got my check answer, it's not actually being called anywhere. So let's go ahead and call that function, check answer, and then we can pass in the user's guess that they made at this step. And we can also pass in the correct answer, which comes from here. So let's run our code again. So I'm going to choose the easy mode and I'm going to make a guess. Now 50 is too high because I can actually see the answer, so that works, but I can't guess again. It's not letting me. It's actually ended the program. So we probably have to tackle this particular to-do if we actually want to get the right functionality. How do we get the guessing functionality to repeat if they get it wrong? So that, as you might have guessed, is probably going to require some sort of while loop. While they've gotten it wrong, we probably should go and let them make a guess again. These parts will definitely need to be repeated. So let's create a while loop. What are we going to check in our while loop to make sure that it keeps on going? Well, the thing that we're trying to aim for is to get the user to guess the actual answer. If we set the while condition as while guess is not equal to answer, then that pretty much guarantees that these lines of code will keep going until the user actually gets the right answer. Now, however, when we do this, we get an error. Well, because guess hasn't been declared yet. So why don't we declare it outside of the while loop and simply just create it as a variable? So we'll set that to equal 0. Now, at the moment, this is a global variable. This is a global variable. So it's probably a good idea to put our game functionality inside its own function. So we can create a new function here, which I'll call game. And now we'll need to call and trigger this game inside the global scope if we actually want this to be carried out. Now that we've done all of this hard work, let's run our code and let's try it out. Let's go for easy. And I'm going to start off by guessing 50 as always. 50 is too low, so I'm going to go for the next number. Let's try a number that's a bit too high. 95, too high. Now, what if I actually get it right? Well, it tells me you got it. So the only thing that we're not really doing is tracking the number of turns so that we tell them you have 10 attempts, you have 9 attempts, you have 0 attempts. And if they get 0, then they're going to lose, right? Here we have this print statement that runs only once because it's not inside the while loop. So let's tackle our final to-do to track the number of turns and reduce it by 1 if they get it wrong. Now, where do we know that the user got it wrong? Well, inside the check answer function. If it's too high, if it's too low, then we have to deduct the number of turns they have. But if they got it, then we don't. One way of tackling this is, again, creating a global variable called turns, set it to start off at 0, and then inside this function, we simply just say turns minus equal 1, and also turns minus equal 1 when it's too low or too high. Now, because this is a global variable, we again would need to say global turns in order to use it inside our function. But as I mentioned, this is not a good idea because it means that you're modifying the global function within a local scope. How can we achieve the same functionality without having to use a global variable? Well, we could instead just pass in the number of turns that we currently have, and then inside our function, we can return the number of turns minus 1. And we can do the same down here. So now, when we call this function check answer, we can pass in the current number of turns, which remember got set by the set difficulty function, and we can pass that into here. Because it's not immediately obvious that this function actually has an output, it's probably a good idea to add a docstring to this function. Remember the 3 quotes, and then in between we're going to say checks answer against guess, returns the number of turns remaining. now when we actually call check answer, you can see that this is what actually happens and that we have a return that we can be aware of. If this is going to be the number of turns remaining, then we can save that to this variable turns so that we update this local variable every time we check the answer. Now, this part is a little bit mind-blowing, so you might actually want to put this through Python Tutor and step through it step by step to see what's actually going on and how this turns variable is being updated by the output from this function. If you're totally happy with what's going on, then feel free to keep going. So now let's check out our code. Now, what if I actually ran my number of turns down to 0. So let's try hard, because this is only going to give us 5 attempts. So let's say I guessed 50 and then 70, and then I'm just going to put in some random numbers so that I end up with no remaining guesses. You can see it's actually not stopping me, right? And also, for some reason, we have a bug where the number of attempts we have remaining is not actually being printed. So let's address that issue. Well, if we want it to happen every time and repeat, it's going to need to go into the while loop. Instead of printing our number of turns here, why don't we print it here inside the while loop instead? So let's make sure the indentation is correct. And now let's try it again. So I have 5 attempts remaining. Let's make a guess. I have 4 attempts remaining. And notice how it's counting it down. 3, 2, 1. This should be my last guess. But notice how it actually keeps on going. It doesn't stop the game. I can keep going, and it's going into negatives now. How can we fix this? We need some sort of way of tracking when this number of turns goes down to 0. And when that happens, we have to stop the game and tell them that they've lost. Why don't we create an if statement, check if the number of turns is equal to 0, and print something. Let's check the actual final version. Let's see what happens in this case. When I run out of goes, I make a guess, it's too low, and it tells me you've run out of guesses, you lose. We can print that here as well. But notice how if we run the code as it is, so let's just keep guessing the same number until I run it down to 1. So now I make a guess, it tells me you've run out of guesses, you lose. But it's still letting me keep going, even though I've lost. How can we make our game end? Well, luckily, we've got our game inside a function, which is being called at the very beginning. Now, remember that with functions, you have the return keyword. You can return with an output, or you can just write return for it to exit and end the function. So now, with that return keyword in place, once I run out of turns, see what happens. It stops and it doesn't let me guess anymore. Perfect, we've managed to get that right. The final thing that we're still missing is this prompt for the user to guess again. Now this is kind of optional, it depends on your own feel for the user experience. I think it makes sense to say it's too low, guess again, because it's kind of telling them to do something. Although this make a guess also prompts them to make a guess. So you can have it, you don't have to. If you wanted to have that, then you probably actually have to check that they still have turns remaining. And if they do, then make sure that the guess is not equal to the answer. So they haven't got it right within this turn. And then to print that guess again. So now every time they get it wrong, but they still have remaining guesses, it should say too low, guess again, or too high, guess again. But if they actually get it right, then it says you got it without asking them to guess again. Now we've pretty much completed this code. Of course, you could have added additional art, so you could have created an art.py and then used the text to ASCII generator to create a ASCII art. And then back in here, we could have imported it. and we could put that at the very beginning of the game. But the rest of the customization is basically your own, right? You're free to do whatever it is that you want to, and to change the wording, to change the text. The really important part was that you were able to play this game, understand how it worked, and then break down the problem into smaller pieces that you could tackle one by one. And if you had trouble actually completing this program by yourself, then you should have noticed when we were walking through it, when I just broke down that big problem into smaller chunks, how much easier it became tackling each of the smaller things, right? Choosing a random number between 1 and 100. You can definitely do parts of this. And as you built up the game, towards the end you realized, this was missing, or that might be nice. Then you could start adding more and more bits to it. But hopefully you've actually managed to build out your own version, and it's even better than what I've done. And if you're particularly proud of it, be sure to share it so that the rest of us can take a look and have a play with it as well. So I hope you enjoyed the project today, and I'll see you tomorrow.
Well done on completing day 12. Now, one of the things that I really want to say to everybody is don't be so hard on yourself, because I know that I do it too. You know, sometimes your inner voice says like, I can't believe you missed a day, or like, why couldn't you get the answer the first time? It doesn't mean that you failed. As long as you keep trying, you're succeeding. So don't worry if you've missed a day here or there. Don't worry if you had to do one day in 2 days, or if you didn't get the solution straight away. As long as you keep going at it, you're going to succeed eventually. And remember, I believe in you.
Hey guys, welcome back to 100 Days of Code. Today, we're going to look at debugging, the process of removing bugs from your code. If you managed to get to this point, you've probably written quite a bit of code already. And I will bet that you've probably made some mistakes, some typos, some errors, and some bugs. So in this lesson, I want to talk about some techniques and tips for how to find bugs and how to get rid of them from your code. Now, the first documented bug was actually found by this lady, Grace Hopper. She was probably one of the first programmers and one of the pioneers of the job that we're undertaking right now. Now, in her notes, you'll find a moth that's been taped to the notebook. And this was found in a relay that was preventing her code from running properly. And this was pretty much the first actual case of a bug that's been found in a computer. Even though we're not dealing with moths these days anymore, we're still going to end up finding bits of things in our code that prevent the code from doing the things that we want it to. The important thing to remember is don't feel down when you've created a bug, because everyone gets bugs. And when I say gets bugs, I mean we create them, right? So once you've gotten over this, next I want to talk about some of the tips and techniques that you should follow on how to quickly be able to identify and remove these bugs. So the first step is to describe the problem. If the problem is messy and it's not well understood in your head, then it's almost impossible to debug it. So untangle the problem and try to make sense of what's going on. Now, in this block of code, we're going to practice describing the problem to help us solve this debugging problem. Now, if you take a look at this function, you can see that at some point in the function, we're supposed to print this line out into the console. But if we go ahead and hit run, you can see that nothing gets printed. So what's going on here? I want you to take a look at this function and describe the actual problem. What is the for loop doing? When is the function meant to print you got it? What assumptions are you making about the value of I? So pause the video, read the function, and have a go at describing the problem. All right, so what we've got here is we've got a function that loops through all the numbers between 1 and 20, and then once that number reaches 20, it's supposed to print you got it. But the problem is that when I reaches 20, it doesn't print this line into the console. So now that we've described the problem and we understand what's going on, let's see if we can solve it. If we think about this problem, when I reaches 20, it doesn't print out this line. There's an assumption in there, right? The assumption is that I will definitely reach 20. But if you think back to how the range function works, the stop or the upper bound is actually omitted. So when you write range 4, it actually produces a number from 0 up to 3. And in our case, when we write 120, it actually goes from 1 all the way up to 19, but not including 20. The problem here is that I actually never reaches 20. So this assumption is completely false. Pause the video and see if you can fix the code so that this line actually gets printed. All right, so all we need to do is change this to 21 instead of 20. And now when we hit run, you can see it actually works and we managed to debug this problem. Always, when you come across a problem in your code, try to describe it so that you really understand what the issue is, and then test your assumptions and see which of those assumptions is actually false.